In a world clouded with complexity and ambiguity, there exist significant opportunities for disruption and growth. At Tiger Analytics, we help our clients navigate this uncertainty, empowering them to move decisively through shifting sands, unlocking these opportunities. We work with our clients to strategize, design, and engineer a future-ready enterprise. At Tiger Analytics, we've been reimagining possibilities with cutting-edge AI and analytics, solving some of the toughest problems out there and building the blueprint for tomorrow. And at the heart of this mission is our battle-tested team of exceptional technologists and consultants. It's our unique expertise and character that enable us to create exceptional value even in hazy conditions. That's our Tiger Gene. The Tiger Gene is what makes us learn relentlessly, experiment without fear, seek help and offer help. The Tiger Gene is what helps us uncomplicate complex problems, build for the future, deliver clarity amidst ambiguity. To our clients who are traversing a fog of uncertainty, we are not just a technology partner, we are a certainty partner, relentlessly seeking, solving, challenging, and growing. Together, as we set bold ambitions and target extraordinary outcomes, let us experience the power of data-guided decisions, the potential of connected insights, the promise of an AI-empowered future. Experience certainty to shape a better tomorrow with Tiger Analytics.
AI is changing the world around us, and the complex world of software development is no exception. EPAM AI Run is transforming the entire development lifecycle, not just by generating code, but in supporting multidisciplinary teams, boosting enterprise-wide productivity and optimizing every step of the process.
AI Run, it really helps us accelerate product ideation. It helps us arrive at new product hypotheses more quickly.
You can validate your hypothesis faster in production.
Writing test cases.
Fit kernel requirements help us align our product roadmaps.
Instant market research.
To create stories.
For rapid and collaborative business case development.
AI Run drives a first-time right approach, boosting speed, productivity, and quality, from project onboarding to product deployment, with an ecosystem of trained GenAI agents that unlock next-level collaboration. It's a natural evolution for one of the world's leading engineering and innovation organizations.
At EPAM, we have been delivering tech-enabled solutions for leading global enterprises for over 3 decades. Over the last decade, our AI capabilities have accelerated from early apps and code generation to enhancing the efficiency across the entire SDLC.
All the silos that were existed in the form of ticket passing back and forth is gone.
It's a better quality product, it's faster product. It doesn't replace real humans, but allows us to do better our research work.
With a superior quality product at a 30% faster time to market, AI Run delivers instant ROI.
It's kind of in the name, AI Run.
We're revolutionizing the way we deliver digital products with EPAM AI Run. The future made real.
By 2025, enterprise spending in Gen AI will soar by 50%. And it's not just statistics, it's actually call for all of us. And we're already helping many organizations create the value by reshaping customer experience, by generating the content in every medium, by automating innovation, by improving demand planning, and also streamlining many different data and business processes.
Traditionally, large language models operate in zero-shot mode, producing output token by token without revisiting or refining their work, much like writing an essay in one go without any revisions. While impressive, this method has its limitations in achieving top-tier quality. Agent workflows address this by introducing an iterative process, enabling LLMs to refine their outputs.
Are you tired of using the same data quality approach without seeing improvements? Remember, the root cause of 80% of data issues come from development, 15% from operations, and less than 5% from the data itself. Think of your data system as a data factory. Implement data reliability engineering. 1. Implement data testing during development. 2. Monitor your data processes.
Good morning, ladies and gentlemen, people of the audience. We're about to begin in a little while. Welcome to DEES 2025, an AIM initiative. Like I said, we're going to start momentarily. Until then, I'd request all of you all to make your way inside, take your seats. Make sure you double check that your phones are on silent before we begin. Requesting all of you all to make your way inside, take your seats, and double check that your phones are on silent. Just in case you have colleagues or friends on the way, please give them a call, send them a message, ask them to get here as quickly as they can, as we're about to begin momentarily. Thank you.
The most pressing challenges. We started as a small, passionate team of problem solvers, driven by the belief that data could empower businesses to think bigger and do better on their own. Self-sufficiency remains at the core of our offerings to enterprises. We strongly believe that we live in an age of hyper-personalization. Enterprises, in the quest for being digitally at the top of their game, often face critical challenges. Challenges that can result in millions of dollars lost or missed opportunities to earn them. They're looking to evolve while overcoming their own unique set of challenges.
We today engage with more than 60 plus global enterprises across multiple verticals like retail, consumer goods, pharma, technology, and many more to come.
We're here to enable them to make smarter, faster decisions with enterprise intelligence. It's not just about solving problems, it's about building trust both with people and the tech and creating everlasting value.
Our strength doesn't just lie in numbers, it's in the unparalleled expertise of our mathematicians. Our people are the heartbeat of MathCo. They innovate, collaborate, and bring ideas to life in ways that drive real-world outcomes.
Every individual has a space to take ownership, make an impact, and shape not just their careers, but the success stories of our clients.
Everything we do revolves around creating meaningful experiences, whether it's through exceptional delivery for our clients or the way we collaborate and support one another as a team.
Each mathematician's goal aligned with our larger mission to empower decision makers in global enterprises to own and activate intelligence.
Our goal is to scale MathCo from where we are to 10 times our size, 10x in terms of the value that we add to our customers, the quality of experts we have on board, and the capabilities that we invest in. All in all, we want to be a one-stop shop for all our customers' digital transformation needs.
Until recently, AI was a field for specialists, scientists, experts. An amazing technology, but so complex only a few people could use it. Well, that doesn't fly with Snowflake. Since the day we were founded, we've made it easy for all types of people to work with all types of data. And today, we're applying that can-do, let's-do, will-do attitude to AI. We're eliminating complexity. Simplify, simplify, simplify. And putting the power of AI into the hands of everyone. The era of enterprise AI is here. It's easy, efficient, and trusted. Right now, thousands of organizations around the world are driving success in the AI data cloud. Join us, and let's put AI to work for you.
In a world clouded with complexity and ambiguity, there exist significant opportunities for disruption and growth. At Tiger Analytics, we help our clients navigate this uncertainty, empowering them to move decisively through shifting sands, unlocking these opportunities. We work with our clients to strategize, design, and engineer a future-ready enterprise. At Tiger Analytics, we've been reimagining possibilities with cutting-edge AI and analytics, solving some of the toughest problems out there and building the blueprint for tomorrow. And at the heart of this mission is our battle-tested team of exceptional technologists and consultants. It's our unique expertise and character that enable us to create exceptional value even in hazy conditions. That's our Tiger gene. The tiger gene is what makes us learn relentlessly, experiment without fear, seek help and offer help. The tiger gene is what helps us uncomplicate complex problems, build for the future, deliver clarity amidst ambiguity. To our clients who are traversing a fog of uncertainty, we are not just a technology partner, we are a certainty partner, relentlessly seeking, solving, challenging and growing. Together, as we set bold ambitions and target extraordinary outcomes, let us experience the power of data-guided decisions, the potential of connected insights, the promise of an AI-empowered future. Experience certainty to shape a better tomorrow with Tiger Analytics.
AI is changing the world around us, and the complex world of software development is no exception. EPAM AI Run is transforming the entire development lifecycle, not just by generating code, but in supporting multidisciplinary teams, boosting enterprise-wide productivity and optimizing every step of the process.
AI Run, it really helps us accelerate product ideation. It helps us arrive at new product hypotheses more quickly.
You can validate your hypothesis faster in production.
Writing test cases.
With clearer requirements, help us align our product roadmaps.
Instant market research.
To create stories.
For rapid and collaborative business case development.
AI Run drives a first-time right approach, boosting speed, productivity, and quality, from project onboarding to product deployment, with an ecosystem of trained Gen AI agents that unlock next-level collaboration. It's a natural evolution for one of the world's leading engineering and innovation organizations.
At EPAM, we have been delivering tech-enabled solutions for leading global enterprises for over 3 decades. Over the last decade, our AI capabilities have accelerated from early apps and code generation to enhancing the efficiency across the entire SDLC.
All the silos that were existed in the form of ticket passing back and forth is gone.
It's a better quality product, it's faster product. It doesn't replace real humans, but allows us to do better our research work.
With a superior quality product at a 30% faster time to market, AI Run delivers instant ROI.
It's kind of in the name, AI Run.
We're revolutionizing the way we deliver digital products with EPAM AI Run. The future made real.
People of the audience, once again requesting all of y'all to kindly settle down as we're about to begin, requesting all of y'all to take your seats. Also, a quick request for y'all to double check that your phones are on silent as we're about to begin. We're about to take the lights down. I request your kind attention to the screen, please.
Artificial intelligence.
AI.
Coexisting.
AI. Good morning, ladies and gentlemen, people of the audience. This is the part where I wave and say hello to you, and you say hello back to me. Hello. Hi, morning. How's everyone doing today? Okay-ish, good. How many of y'all, like me, are still sleepy? Hands up in the air. You can be honest, come on. One hand went up, 2, 3. Okay, 4. All right, how many of y'all are wide awake? Hands up in the air. Wide awake. And the rest of y'all? Just curious. Okay, how many of y'all don't care? Hands up in the air. 1, 2, 3, 4. I like honest people. 5, very nice. Okay, good morning, everyone. So my name is Vineet Vincent. I will be walking you through what is going to be happening on this stage over the next 2 days. It's my absolute pleasure to be here with you. Before we begin, I've made this announcement twice. I'm going to say it once again because it's very important. Pull out your phones from your bags and your pockets. Just double check that it's on silent. If you can do that very quickly, just make sure that your phones are on silent. I know a few of us might have multiple phones, so just make sure that maybe all of your phones are on silent before we begin. Just giving you a few seconds to do that. Thank you very much. Welcome to Data Engineering Summit 2025, or as we'd like to call it, DES 2025, India's premier and only conference solely dedicated to the field of data engineering. Proudly brought to you by AIM Media House. Once again, I'm going to request your kind attention to the screen, please.
From cave walls to phone calls, we've always wanted one thing: to connect. Over time, how we connect has changed. It got faster, smarter, and bigger. Now it's not just people talking to each other. It's machines, apps, systems, all talking through data. And at the heart of it all, data engineers, building the roads that keep this new world running. Data and AI are helping us live better, work faster, and solve big problems. This is just the beginning. Welcome to DES 2025.
Like that video said, welcome to DES 2025. Can you put your hands together for each and every one of you for being here this morning? Thank you very much. This is the 4th edition of this premier conference, and we're not just talking about data. We're celebrating a renaissance, one where data engineers are no longer backstage, but finally taking center stage. Over the next 2 days, you'll get direct access to some of the top engineers and innovators from the world's leading tech companies. They'll dive deep into topics like ML system architecture, next-gen data frameworks, and real-world business solutions. This is going to be one of 2 halls. So we have the main hall here, and we also have hall number 2, which is down the lane on the left-hand side. So make sure you check out both halls, access both of them. We'll explore everything from data lakes and transformation to strategy, training, and governance. All you can expect is a power-packed agenda with keynotes, workshops, fireside chats, and panel discussions. All of these led by some of the brightest minds in data engineering. Thank you each and every one of you all for being with us here today. And before we jump into the first speaker of the day, I'm going to remind you all that we have the AIM booth outside, and they host some fun contests and challenges. This will be happening throughout day 1 and 2. So make sure you head over to the AIM booth outside. And don't forget to swing by to win some goodies and be a part of a lot of fun. Also, grab a copy of the latest print edition of the AIM magazine. That is also available. A print edition of the magazine is available. Go to the stall, pick it up. Again, before we jump into the first speaker of the day, events like these happen with people like y'all in the audience, quite obviously. But events like these also happen to our incredible sponsors, and they are here with us, and without whom DES 2025 would not be possible. This year's DES 2025 is powered by Genpact in association with MathCo, Snowflake, and Tiger Analytics. Our platinum sponsors, EPAM, IceDQ, and Starburst. Our gold sponsors, ClickHouse, Sigmoid, Target, and Tridents. Our silver sponsor, CData. Exhibit sponsors, Carrier, Melissa, Startree, and Yidu. Can you give all of them a massive round of applause for making this event happen, please? Thank you very much. The next 2 days are truly going to be special, so network as much as you can, smile a lot. Make sure you step out and check out all of the exhibitors outside. A lot of the names that I called, pretty much all of them are outside and more. So make sure you head out, have conversations with people. Do we have a deal? Yes. To the 8 people that responded, thank you very much. Do we have a deal? Yes or no? Super. Okay, as the audience, you have, I think, 2 jobs when you're in the audience. Number 1 is to pay attention to everything that's happening on stage. Number 2 is when we announce people coming up to the stage, your job is to clap and make a lot of noise for them. Do we have that deal as well? Yes or no? This is turning out to be a slightly slow start of the day. Do we have a deal, yes or no? Okay, can we try this? Like, let's say I say, oh, the next speaker coming up on stage is yada, yada, yada. Please put your hands together for him. That was very proper of all of y'all. Thank you all very much. A little bit of hooliganism is also allowed, so you can go, can you try that? Just go, woo! Okay, super. You can add that. You can go, whatever you want. Okay, just add a little bit more enthusiasm. Make them feel welcome. They're here for each and every one of us. Do we have a deal, yes or no? Okay, I like whoever those people were. +5 points to Gryffindor. Okay, very nice. Once again, we're going to try this once again. In 3, 2, 1, make some noise. And put your hands together while you do that. Perfect. Okay, that's what you're going to do when every speaker takes stage. It's time for us to jump into the first speaker of the day. A quick reminder, make sure you step out during the breaks and check out the stalls outside. For the first session of the day, we're going to talk about what does it take to build a truly modern data engineering practice. One that's agile, scalable, and ready for Gen AI. This session unpacks the principles, tools, and mindsets that define the next-gen data stack. The person coming up on stage is from startups to Fortune 100s. He's helping teams simplify, scale, and stay future-proof, right at the heart of modern data movement. People of the audience, your job is to make a lot of noise for him while he walks up to the stage. The first speaker of the day, please welcome the Senior Manager, Sales Engineering at Snowflake, Mr. Sumit Tandure. Put your hands together for him.
Thank you so much. Thank you to all of you for being here as well. What a phenomenal energy outside and inside the room, right? I think we are still trying to forget the traffic woes of Bangalore, looks like, right? The long walk across the bridge from the flyover. If some of you come from the eco-world side of the Bangalore city, I see some familiar faces also in the crowd, so thank you for being here. Wonderful. So I was looking at the topic list for the DES Summit, and it looks like there are more Gen AI sessions than data engineering sessions. That's the state of affairs today, right? Because all of us want to learn more about that. But the thing is, they're definitely not two different things. The Gen AI sessions are very closely related to data engineering, because without a very solid data engineering foundations, you cannot have a very good Gen AI, right? Goes without saying. So great pleasure to be here, and the first speaker of the summit. It wasn't intended to be, but it happened to be the first session of the day. So again, a big thank you for being here. All right, so we all hearing about Gen AI. We're kind of getting drowned into Gen AI and all of that. What we are seeing is this is the year when we will see more and more use cases going into the production. Because last couple of years, we saw a lot of experimentation, pilots, different types of hosted models, API models, and all of that. And now it seems like we have come to a place where more and more of these use cases will go into production. Yeah. I think we will also get questioned on the ROI. What is it really that we are getting out of these projects? Are we really seeing value in it? So for both of these things, one is to roll these projects out into the production, and other is to derive the ROI out of them. The big thing is how solid is our underlying data engineering foundation? Because for the enterprise AI, if the data is not good, if the data is not high quality, if the reliability of the pipes which are feeding the data is not great, these Gen AI products cannot be productionized, right? So that is the fundamental and most important aspect of building these into the production. Now, that is definitely one big disruption which happened in the industry, right? A couple of years ago, the big thing about Gen AI, and now rolling it onto production. The other big thing we are seeing from a disruption standpoint is this data interoperability. These ability to have multiple engines talk to the same data, regardless of which engine originated from, and so on. Now, of course, open table formats are not new. They have been there for a while. But what has really happened is the vendor support, which has built around formats like Iceberg, has become phenomenal, right? For a long time, the open table formats were kind of very closely guarded secret with certain vendors. Only one vendor supporting one particular table format, and then the other one was sort of, dying off. But then we had Iceberg, which suddenly popped up on the screen, and huge amount of support from a large number of vendors over there. So that has kind of changed the equation now. Huge adoption from Icebug side. Number of vendors which support that ecosystem is big, and the contributions are coming from all sides of the equation. It's not just one vendor, but different customers, vendors, partners supporting the Icebug phenomena. The other thing we also saw is on the catalog space. The catalog has also been sort of a problematic area because initially we had a high meta store and so on, which didn't really caught the fancy because complex, not very scalable, and then again we had proprietary catalogs. What really is happening now in the Icebug space is that catalogs are also becoming open source, so that you are not dependent on a particular vendor, but regardless of the vendor, you can actually make use of the same catalog. If you really look at this phenomena of table formats and catalogs, it's really an unbundling phenomena, right? We all have some database background. What the databases were doing in a single engine, single place, the open formats have kind of unbundled that, right? So we took the storage, put it into a different system in file formats. We took the engine and we said, okay, multiple engines can work. Then we look at the governance and the controls and permissions and said, okay, we now have a catalog, which is again unbundled. So this whole thing got unbundled, and now they're coming together again in a fashion which is completely open and can be used with multiple interoperable engines, right? So that's what's happening in the catalog and open table space, allowing multiple engines to talk to the same data and maintaining the same level of governance. Now, on the GenAI side, if you really see, one big thing it is doing is just what SQL did to structured data. LLMs are doing the same thing to the unstructured data, right? SQL made it really easy to get value from tables, rows, and columns. LLMs are making it very easy to get value from PDFs, audio, video, all sorts of multimodal data, right? We all used to say that 80% of the data in the world is unstructured, right? The problem was that unstructured data was lying there in storage systems, in deep cold storages, but there was nothing happening on that unstructured data. Or even if you wanted to do something, it was really, really hard. The OCR technology, the NLP technology was a domain of very select few people, and it was really hard to get value out of it. What GenAI has really done is put the button in the hands of everyone, that regardless of what you do, you can actually get value out of unstructured data. This used to be a domain purely of data scientists, people who could deal with libraries like NLTK, Spacey, all of these, right? And then get into natural language and get value out of it. What LLMs have done is now data engineers are empowered to just look at unstructured data as if it is again a source of structured data, get it into our data system, combine it with the rest of the data. So it is leading to a very tight coupling between the structured and unstructured data, which was very, very difficult earlier. Yeah. With these two disruptions, what we are seeing is how the new age or how the modern data engineering stack has been built is few principles around these, right? As I said, more and more you want to put things into production, you need to have more robust and reliable pipelines. The first principle there is, how do you simplify this architecture for the AI? Because if something is very complex, it cannot become mainstream. It cannot be widely adopted, right? So to make this AI products really mainstream, we have to simplify the underlying architecture and the pipelines and the data engineering required for that. So first thing we are seeing is companies will want to go in a direction which helps them simplify this entire architecture for AI products, right? Right from the time data is in the source, bringing it into places where it gets consumed, and that entire life cycle of AI coming together on the data, it needs to be simplified. So that is a big area of focus and emphasis which we are going to see from a data engineering side. You all must have heard about RAG pipelines, and now we talk about MCP and A2A and all these agentic frameworks, right? So things will have to be brought in a way which makes it very easy to bring all this together in a simplified manner, right? The second thing, like I said, is open and future-proof platforms. People will not want to invest in things which become sort of closed or cannot be built upon with multiple layers on top, right? So more open table formats, future-proofing with different products and engines built on top. So that's more on the simplified and openness of the side. If you see the second pillar, it's more around the productivity and integration with DevOps practices and zero operations. You know which are the best data pipelines? Which are the best data pipelines in the world? The pipelines which don't exist. The pipelines which don't exist are the best data pipelines in the world. Because let's be clear, if pipelines exist, they break. And when they break, all sort of hells get loose, right? So how do we make the zero operations data pipelines, reduce the amount of friction between the data and the products, build as less pipelines as possible, and whenever we have to build them in a very robust way, build them in a way where developers can really control them with enough amount of observability and integration with their day-to-day practices. So that's more around the developer productivity and making as less operational overhead as possible for the developers. On the third pillar, if you see, it's more around governance and efficiency, because when you want to put things into production, you want to make it very well governed, very robust, tightly controlled. Even when the LLM models are built, the biggest question is, how do you make sure that the output of these models are not available to people who do not have access to this data? When we implement RBAC on the data systems, it is very easy. There is an RBAC, there is a person who has access to it, there is a person who do not have access to that. But when you build LLMs and you open it up to the entire enterprise, the questions you ask, how do you control what answers the LLM gives to which person? It's very hard to control, right? Because it's a chatbot we have built and anybody can ask any question. How do you tie this RBAC controls right to the application layer so that the answers which you get are controlled at the access layer, right? These are some of the challenges we will see on the governance side. Ultimately, we all want ROI. Our CFOs want ROI. So how quickly, how fast, and how in an expensive way we can deliver value, that will continue to be a big driver with data engineering practice as well, right? So 3 big pillars. Number 1, simplification and openness. Number 2, productivity. And number 3, governance and efficiency. These are some of the big principles we are seeing from a data engineering practice standpoint. Now let's see how we can look at some of these principles and how Snowflake really helps there. So first one, we talked about unstructured data. The biggest thing with unstructured data is, number 1, it's lying scattered in multiple places. So our object stores, or maybe even on-prem places, it is tied into the application, so on and so forth. How do we take this unstructured data and get the important values out of it, right? This could be invoices, contracts, loan documents, so on and so forth, right? There are fields of importance which you want to pick up from here and then bring it to people who are on the field so that they can operationalize all of this into their day-to-day life, right? There are doctor's prescriptions, MRs which go on the field, and all of those handwritten notes also need to be brought into that. So now with LLMs, what's happening is you have LLMs which are really good in reading this data, whether it is images, whether it is text, whether it is layouts, tables. These LLMs can really read all this data, and you can embed this into data pipelines. So for example, Snowflake has this product called Document AI. What Document AI does is it has a built-in model under the hood, really good in extracting certain specific fields from these documents. So if you have these invoices or contract documents and have certain fields of importance, you can extract that and bring it into the tables very easily. You have a UI where you can define some of these parameters, and it builds the pipeline automatically. It gives you a function. You just invoke the function, and basically the data keeps coming into your tables from the unstructured data. Now, of course, there are multiple options here. So Document AI, there is also things like parsing the text based on the level of resolution of the image or the complexity of the document. There is also multi-model LLMs now. So if you want to do charts, for example, charts cannot be parsed in a normal way, right? So if you have charts and want to correlate with that certain things in the document, there are multi-model LLMs to do that. So that's for simplifying the data engineering for unstructured data. Now, we also want to build search engines and chatbots on top of unstructured data. That's where we do RAG pipelines, right? Now, these RAG pipelines, typically, the way it is built is you have a place where data is being stored. Then you have a place where the AI models are running, right? So there is a lot of interaction between them. Data is coming into the data side, going to the AI systems, which are sort of embedding, chunking, doing all this work, and then writing it back to the data system. So you have specialized vector databases for this particular work, right? So there are vector DBs, there are unstructured stores, and there is then data warehouse or data lake. So again, multiple layers, which make it really complex. Now, what you can really do with Snowflake is you have something very simple called as Cortex Search. You go and build this Cortex Search service. What it does is in the backend, it does all of this work for you. embedding, chunking, building the index, all of this gets taken care of automatically. There is some bit of pre-processing which you need to do with parse text, but then beyond that, everything gets embedded with Cortex Search. And then on top of that, you can build a front-end UI with Streamlit, and then you can do whatever interactions you want to do via the UI with end users. Right? So easy to build these kind of RAG pipelines and make these answers very grounded in truth. Because in enterprise AI, you want enterprise data to be sourced for giving these answers appropriately. Right? So simplifying this entire RAG pipeline structure, that's another thing you can do with Snowflake. So just a case study, there's a customer called Compare Club. They help people compare financial products like Policy Bazaar in India, right? So you have different companies offering loans, different companies offering mutual funds and so on. Which is the best one to go for? They help people compare that. They did analysis of their voice transcripts when customers call, what kind of help do they need, what kind of problems they are dealing with, and how do they improve this service and personalize this service, right? So they're able to support hundreds of sales agents by building this particular application with Snowflake. The other problem which happens with LLM is that if you are making an external API calls, these APIs have to be invoked, and then the throughput which you get is not massive, right? So you get limited by the kind of throughput you get between the data and AI. By hosting these LLMs right into the data platform, you get much better inferencing and a much higher throughput. So you can actually process a lot more data in a faster time frame. So that was the first thing I talked about, how do you simplify the AI pipelines? Just a couple of examples, but there is a lot more you can do there. And that is going to be one of the principles which we see coming this year. On the open lakehouse side, if you see, like I said, Iceberg has really become the de facto standard for broad vendor support. We see a lot more interoperable vendor neutral activities happening in that space, right? So we continue to improvise that ecosystem from our side, and it's of course open source community. So how do we bring things like variant data type there, geospatial data type there? So all the goodness which is happening on the Snowflake side, how do we bring on the Iceberg side as well? The next thing which happened is Apache Polaris, which is an open source catalog. So it's not tied to Snowflake. You can really use Apache Polaris in anywhere. You can host it in a container. You can host it in a VM. You can also host it in Snowflake if you want, right? So that makes the governance outside the Snowflake boundary. And you can talk to this catalog through multiple other engines. Could be Spark, could be any other engine for that matter. The third thing is in terms of the spectrum of workloads which can work on this, you're no longer limited to AI, ML, or analytics. You can bring new things like data sharing, data applications, and whether it's batch or streaming, all of that. So initially, the lakehouses were very limited to BI and AI type of work. What Snowflake started to do was bring this data sharing into the picture where regardless of which organization I'm in, we can start to do this collaboration across the organizations. Now that data sharing is also possible with open formats like Iceberg, right? And you can build data applications on top. So that's a modern open lakehouse. Again, a case study how Goldman Sachs built their lakehouse with Iceberg and Snowflake. They used to have this vendor onboarding process, different vendors who bring their data into the platform, and that used to take a long time because every vendor had a different way of bringing data through ETL pipelines and so on. So they really simplified these pipelines by using Iceberg and data sharing. So now all of their vendor data providers basically use Iceberg and then provide the data from there to their Snowflake account. And then within the Snowflake account, we have this lakehouse which takes the data in, builds the native applications, processes that through dynamic tables, and then leads to the final outcomes. Yeah? So 15x speed improvement in bringing data from vendors. Right, so that was on the simplification and openness pillar. Let's look at the second pillar of developer productivity. Like I said, the best pipelines are those which don't have to be built, but you still have to build some pipelines. Now, to that extent, what happens is we are also seeing a lot of movement towards what is called as declarative pipelines. So if you look at typically pipelines, we want to define a schedule at which this job has to execute. We also want to define what delta data has to be brought in, right? So there is a change data capture, things like streams, tasks, and so on. What Snowflake did was come up with something called as dynamic tables. It's a single statement, a declarative statement. You create this table, define with the duration, and that's it. Whatever SQL logic you write here, it keeps calculating automatically at a periodic interval on an incremental data set and keeps persisting those changes. So from whatever line of code we had to write earlier in terms of scheduling, finding the change data, persisting it, it all becomes simple with a single declarative statement, and that keeps happening automatically, right? So again, big simplification from a pipeline standpoint there. If I want to eliminate the pipelines, then I have an option of data sharing, like we saw the example of vendor onboarding in that particular example. So now there are multiple applications which do this data sharing. So if you heard, Salesforce now has a data cloud, and there is a data sharing happening between Salesforce and Snowflake. So you don't have to build the pipeline. From Salesforce CDP, you can bring the data directly into Snowflake. Same way, ServiceNow has a connection with Snowflake now. So there are more native connections, more data sharing. There are multiple other app providers who are now doing data sharing so that you can eliminate those pipelines, right? So fewer pipelines with data sharing option over there. Snowflake also acquired this company called Datavolo a few months ago. This is now getting embedded into what we are calling Snowflake OpenFlow, and we will have more native connectors going forward so that you don't have to, again, bring a new ETL framework. But from the Snowflake account, you can configure a connection to the sources and then bring data inside. The third big thing we are seeing is how do we integrate more and more DevOps practices into the data operations, right? The data code is becoming complex. It needs to be maintained and managed almost like we manage the software life cycle, right? So all the DevOps practices in terms of continuous build, continuous deployment, continuous release, how do you integrate all those aspects with the data platform, right? So again, to that end, there are things like Python API, Snowflake CLI, declarative change management for the database, etc. You have all the integrations possible so that from GitHub, Git Actions, something like Bitbucket, you can push those changes of the code. First thing is you build the environment inside Snowflake through the, say, Python API. Once you have done that, you can trigger a code push into Snowflake through Snowflake CLI. So whenever there are changes, from the remote Git repository, we can push those changes. And then on an ongoing basis, continuous releasing these pipelines through integrations with Snowflake CLI, right? We also made altering the objects very easily with things like execute immediate from or create or alter from the GitHub files. So you can easily integrate GitHub repo with Snowflake and push these changes into the system. Here is a case study of a company called Travel Pass. Basically, they manage the traveler's booking experience, the travel experience. So they migrated about a huge amount of data from Spark to Snowflake, about 130 dynamic tables which they have. They were able to go live in just about a week after migration. So again, big saving and very fast time to value. They saw 65% cost savings by moving from managed Spark to Snowflake. Now, if you are not familiar, Snowflake has something called as a Snowpark. What Snowpark does is whatever Spark code you have, you can bring that Spark code into Snowflake. There are few minor changes which you might need to do from a compatibility side. We are also reducing those changes to make it as compatible as possible. But essentially, your Spark code can run inside Snowflake with Snowpark, right? With the same governance and reliability of Snowflake platform. So they saw almost 350% efficiency in delivering data to their businesses. All right, let's look at the third pillar now around governance and efficiency. So when we talk about governance, there are three broad areas, right? Firstly, knowing your data. What data do we have in the system? Right? It comes back again. Firstly, knowing what data do we have in the system, right? So classifying the data, is it PII, is it non-PII, auditing, tagging, all those capabilities around data classification. So you have things like object tagging, auto classification. Recently released support for Indian identifier. So things like PAN, Aadhaar card number, GSTN, they are now available as automatic classification. So if there are columns which contain this PIIs or Indian identifiers, Snowflake will automatically classify that as a semantic category. And then you can build masking policies on top to make sure not everybody has access to that PII data, right? Very few platforms you find where you have the support for Indian identifiers. We have integrated that. Once you do that, you want to protect this with different types of attribute-based access controls, like column-level masking policies, row-level masking policies. conditional policies, and so on. So you have all of that available to protect the data. So even when you are unlocking this data by sharing to other people, you have options to control the access via these role-based controls, things like data clean room. So you only expose the amount of data required, and not the PIA directly, but allowing them to only join and overlap the data where it is required. So you bring the same level of control all the way till you are unlocking the value out of that data. Now, the thing with this governance is it's available out of the box. You don't have to bring something as an add-on, or you don't have to think about it retrospectively. What is happening in the data lake world is, initially people were more worried about solving the big data problems. So we brought the engine, we brought the data, and then we started worrying about governance. How do we bring now this RBACs and ABACs into the system? And that made it very complex. So some of the people who are implementing catalogs now on the existing data lakes, they are really going through major pain points, because implementing catalog on an existing data set and platform is not as easy. You have to go through the entire definition process, integration with the environment like Active Directory, and then roll it out onto every object, every cluster, and so on. Yeah? But in here, it's available out of the box. So from the day one, you have a platform where you can start with governance baked in. And the same governance can be brought forward till the AI layer, because when we do things like embedding and vectorization, we can actually make sure there are access controls implemented at that level, so that when the chatbot is responding, it is also respecting those access controls. And finally, bringing efficiency in an automated manner with a single platform where data, AI is integrated together. You don't have to bring multiple systems into the place. And any improvements which we are making to the system is continuously flowing for you. So we recently introduced some performance enhancements on the Iceberg side. Now you do not have to do anything on your side. Those enhancements will automatically flow into the system. And without making any changes, you now have better performance and better cost efficiencies. Right? So this is continuously flowing improvements and optimizations over there. Right. Again, bunch of case studies there in terms of people who have done either time reduction, cost reduction, or faster data availability with things like Snowpark, dynamic tables, and so on. Right. So coming to the end of it, in terms of what you can do with the entire set of data engineering pipelines from data to AI, you have different constructs for the ingestion side. So integration with Kafka, different streaming pipelines, data sharing, or I talked about OpenFlow now to get data from various connectors. Transforming this data through different constructs like dynamic tables, stored procedures, Snowpark, etc. And finally, delivering the data via data sharing, Streamlit for building applications, or even unloading the data to various systems. You can actually do this end-to-end data engineering framework with Snowflake. I know a lot of you like notebooks as well. So there are notebooks in Snowflake. You can work on it as if you were working on Jupyter environment in your local systems. Right? There are containers as well. So if there is something you want to do in a containerized environment, you can spin up a container and work inside there. All right, I get my ring to complete the session. This is the last one I want to leave with. Data engineering is definitely one of the most important workloads for Snowflake, but that is not the only workload. Of course, Snowflake is very well known on the analytics space, so you can do all types of analytics like embedding it, very low latency, highly interactive analytics, geospatial, time series, lakehouse analytics, all of that. On the AI side, you have embedded LLMs to do work on unstructured data like translation, sentiment detection, bringing the data to structured tables, and so on. We talked about data engineering a lot, and finally building applications on top for delivering outcomes and collaborating on the ecosystem, not just within your organization, but taking it to external organizations as well. Right? And of course, underlying you have the data, compute, and governance layer, which builds this platform for simplifying the data engineering pipelines. Right? So that's pretty much it from my side. Thank you so much for being here. Right? I don't know if you have option to take questions from the audience.
If you have a question, please put your hand up in the air. We will have a mic come up to you. And yes, the gentleman all the way at the back. We would like to stick to time. Can we have a mic move all the way at the back? Thank you.
Hey, hi. Shankar here from HDFC. So will this Snowflake, for all this data integration, will this work if everything is structured? I mean, I'm talking about the prerequisites, right? So if the data is already in the some of the structure format, will this work? Or if we have the legacy things where the things are not quite well, and lot of prerequisite activities are required to bring it format or like to a right format, or all the applications and everything. You have to prepare the upstream applications so that you can develop the efficient the pipelines. The efficiency doesn't necessarily start in the ETL that we do within the Snowflake. It has to be prepared from the the upstream systems, right? So how you approach for these scenarios?
Right. So if I get the question, like I have upstream systems which have the data. How do I prepare these upstream systems to bring data into Snowflake?
Yeah, because necessarily their governance, their controls also should align with the ETL, right? It's not like, okay, I need the data for these AI projects, give me the data. How will you prepare those upstream systems? Because those are built for some other purposes, not necessarily to give a data as a service for the other analytic projects, right?
Absolutely, absolutely. Good question there. So that is where the first step is to just tap into these upstream sources. So all we need is like tap into these sources by getting the data in. And I gave you examples of how, for example, from Salesforce, they can expose the data out. So all that these upstream systems need to do is expose the data either via APIs or say log replication or something of the sort, which allows us to take the data in. Because you rightly said, you cannot implement all this governance, and the objective of these upstream source systems is not building AI. They are there for transactional workload. So you have to bring data into a system which is meant for doing all of this work. So that is where you enforce governance, policies, integrate with AI, and so on. Yeah. So all you need to do is find a way to tap into these upstream sources. They will have some permission controls to bring the data in. As long as that is taken care of, rest of the things you implement on Snowflake. You don't have to do anything on the upstream system for that. Yeah. Thank you.
Thank you very much. Unfortunately, we've run out of time. Just in case people have further questions, would you like to take it outside?
Absolutely.
Yes? You'll make yourself available. Can we hear a big round of applause for the first speaker of the day? Thank you very much for being with us here today. We shall see you all offline. We're going to quickly jump into the next conversation for the day. This is the second speaker who is here to talk about how we're going to delve into how AI is reshaping the very foundation of data engineering. This session explores the rise of agentic systems, where AI doesn't just assist, but actively collaborates in building and managing modern data platforms. This next person stepping on stage with deep experience in architecting AI-native platforms, this gentleman is leading the charge in reimagining how data pipelines are designed and run in the era of intelligent systems. Please welcome to the stage the Senior Director of Data Engineering at Credence Inc. Please welcome Maulik Dikshit. Thank you very much.
How do I do this? That's forward and backward. Got it. Good. Okay. Hello, good morning, everyone. So, my name is Maulik. I'm a Senior Director Data Engineering at Credence. You just heard the profile, but I have something more interesting for you guys over here. Okay, so I'm pretty sure you will be interested in this bit of a goodie that we have. So how many of you follow Credence on LinkedIn? If you can raise your hands. Right, okay. So this is your chance. Tell me the latest post on LinkedIn from Credence, and this goodie is yours. Take out your phones and do it right now. Tell me the latest post. I'm waiting. So is this goodie. You can raise your hands and tell me what it is. Please go ahead. Launch with Databricks on the marketing side. Yeah, thank you for that. You can subscribe as well since you're on the page. Yeah. Sure. I'll start with another question though, okay? And again, I have no goodies for that, right? But let me start with a question. Let's assume there is a $50 billion company, a revenue with $50 billion. How much do you think will be the spent on data analytics? Any rough guesses? Or let me put up three options for you. $50 billion company, right? Under 5 million, 5 million to 1 billion, 1 billion to 2 billion. These are the three options. So how many guys think it's going to be under 500 million? Okay. How many of you think between 500 and 1 billion? Okay. And how many you think is 1 billion to 2 billion? Right. I love you guys because you guys are real enthusiasts. Okay. We will reach there one day, someday. But right now, the figure is around kind of less than 1%, right? So it's around 500 million, right? So that's the reality. Okay, sorry, my bad. So a $50 billion company revenue, typically 4% of it is spent on IT, right? So it's kind of 2 billion, and the data analytics spend out of that is 20%. So what it really means is that it's 400 million that you have to spend very wisely on your data analytics projects, right? Then there's a breakup of new projects and support is typically a 40-60 split, right? So now think about a scenario, right, where you can improve the efficiency of your development project by 20% and your support project by, let's say, 30%, right? You would be kind of unlocking 100 million of value, which can get again into your data analytics projects, and that will increase the revenue. It's a cycle that will keep on continuing. But how do you make that change? How do you unlock that 25% potential across your data analytics projects? So here comes the agents and Gen AI, right? So let me try to give you a simple example of an agent, what an agent really means, okay? So in the olden days, right, let me rephrase it. When I was a bit younger, right, basically you remember the queues that you had to stand, I mean the queue to get a ticket, right, a train ticket. You have to stand in long queues for 2 to 3 hours, spend ample amount of time, you get something, you may not get something, a lot of waste of time there, right? So what happened then? Then came agents. You just tell them what to do, they will do it for you, right? And you will get what you wanted, right? Now think of it a little bit more intelligent agent here. Okay, so the intelligent agent is the one that understands your patterns. It understands what you have done in the past. It gives you a suggestion on what you need to do, right? And it will also then maybe book tickets for you. Your life will be simple and great, isn't it? Basically, all your mundane tasks can be handled by agents, so you could do something more useful in life. More useful like attending DEES 25, right? And listening to this keynote as an example. Okay, so let's talk about some of the challenges that we face with data engineering. Time intensive, you know, data engineering projects takes time. It can take months, some are multi-year as well. It's constantly changing. Technology is constantly changing. You have so many different clouds, so many different technologies, right? So it's ever-changing kind of a scenario. Specialized expertise is what you need. You need specialists in every area. Data governance, I need a specialist. Data engineer, I need a specialist, right? Data analyst, I need a specialist. I need specialists for everything, right? You don't get those specializations. And low automation, right? I mean, we know we have built frameworks, etc., but it was so automated, it shouldn't have taken those months and years. It should have happened in kind of weeks, right? So data engineering is the single most bottleneck in my view, right? Which basically stops business from getting the value out of the data, right? And if you can speed that up significantly, it can unlock a lot of value, right? So these are the challenges. How you think Gen AI is going to change things tomorrow? So let me go here. This is today's experience. This is tomorrow's experience. Okay, so your manual pipeline creation will all be auto-generated. Human-led monitoring will be all AI agent-driven. Scheduled jobs will all be event-driven jobs. Siloed tools, you will have agents will do data observability for you across all your different ecosystem. Static dashboards will be replaced by insight-based dashboards. Copilot as an example. Your text to SQL as an example, right? It's already happening today. Reactive incident will be more of a proactive incident, and it's more predictive in that sense, right? So let's look at a story, okay? So this is a story of how a traditional data ops functions. Okay, it's an interesting story because we have all lived through the story at some point or the other. So we have three different characters over here. We have Linda, who is the support team. We have Brian, who is the support lead. And then we have Pete, who is the business owner, right? Now Linda is new, she's the support team, that's how it works, right? Let's assume there's a nightly batch that's running. It's a important monthly finance ETL batch that is important to meet SLAs. Something has failed at night. So Linda receives a call or a message that something has failed, right? She's trying to figure out things, but she's new. She really doesn't know what to do. So she calls up Brian, whose head is on the chopping block there, right, to deliver things on time. So the first thing Brian asks, have you looked at the logs? Linda is smart. Rather than saying she doesn't know, she says, I don't have access to those logs, right? So Brian says, okay, let me figure out. So he goes in, tries to find out what the issue is. He comes to know that it's a small thing where some kind of access is missing on some of the objects, right? So it says, Linda, can you fix it for me? So Linda says, let me look at the documentation, let me try to figure out, let me do a QA of it, let me do a UAT of it, right? Let me go through different phases of the cycle and let me fix it. Brian is smart. Brian says, okay, I have something with me, use these commands and it will work for you. And the issue is resolved. But again, you have missed precious time. You have missed your SLA in this case. And as you see Pete in the picture, he's not a very happy guy, right, who is the business owner of things. So you look at the workflow. There's a workflow on the left-hand side which says how you detect an issue. There's a workflow on the right-hand side which says how much time it's going to fix. It's a very complex kind of a scenario. And that's what we want to improve through something like an agent, right? So how will it work tomorrow? So the business owner is gone, Pete is gone, which is great news for us to start with. Now we have a new guy in here, which is the AI agent, right? So how would it work? Right? This is a repetitive. It's a pattern that keeps on repeating. So in this case, the agent is trained to handle this kind of a scenario. Okay. So the agent receives the failure, it understands what the issue is, it gives the access, it sends a mail log to Linda and Brian, the issue is resolved, right? The workflow is much more simplified in this case. Issue detected, the agent invoked, resolved, restarted pipeline, issue done, no SLA misses, right? So that's the power of an agent. So let's focus on that guy right at the top who is the agent. What really you mean by an agent, right? I give an example, but let's see what an agent really is. So this is an agent, a very simplistic view of an agent because we want to make it simple, right? So an agent has 4 parts to it: tools, memory, planning, action, right? So what are tools? Tools is nothing but think of it like your reusable functions that you have to build, right? It's your functions that does something or the other. Agent is also a function in that sense. So how is it different from anything that we are building today, right? It's still reusable. We build reusable functions all the time. The difference really is that this is Gen AI backed. What I mean by Gen AI backed is, rather than following a set of rules, if A happens then do B, if C happens then do D, right? Rather than following those set of rules, it has its mind of its own. It takes its own decision. It is autonomous. It understands natural language and then invokes the right set of tools / functions to make things happen for you. Right? So that's the basic difference of what we had to do in the past and what an AI agent really means. Okay? So now this is great, right? But now you need to sell it to the business to build those agents. So what's the business case to have these agents in your ecosystem? So let's look at that, okay? So the business case, we all know this, very repetitive in nature. We have fragmented tools, changing business requirements, data spread across multiple source systems, etc., etc. But the two biggest drivers that have changed things now, and this is going to be possible, is because of LLM AI and maturity, all your Gen AI models which are getting faster, better, cheaper, etc. And your development in agent frameworks. So the agent frameworks, the Lang chains, the Lang graphs, the A2A of the world, right? The MCPs, Autogen, you can just name them, right? They're just springing up, these frameworks, which help develop these agent frameworks very, very fast and in a way which is, you can deploy it in production. So what's the impact of it? A pipeline recovery time, which used to take 6 to 8 hours, with an agent will take a few minutes. Onboarding new data source, that's a big engineering heavy work. Ingesting a new data source, which used to take weeks for us, it's now going to take some days. Building pipelines from hours, 8 hours to less than 2 hours. Instant response, we saw an example, it's going to be much more proactive. Understanding your data, building data quality rules, it's a time-consuming job. The agent can do this for you, right? So agentic data ops isn't just about automation. It's about transforming your data engineering into a more resilient, intelligent, and efficient system, right? So that's what agents will do. So what are the different use cases that we can have for agents in data engineering? Let's look at some of the use cases that we have, okay? Again, I'll not go through all the use cases. We already discussed a few, so let's look at some interesting ones here. We talked about ingestion. We talked about quality. Code generation conversion agent. Probably this is a big one, right? I'll need to just talk a little bit more about this. Every business is struggling to become modern, right? Or change their existing platform to a more modernized platform. The project of any project that is going to change things or kind of from a traditional Teradata's of the world or maybe the data stages of the world want to go to modern platform, it's a multi-year project. It's not even months, right? So think of an agent that can translate your legacy ETL code into any of your modernized code platform in an automated manner. That is a big potential, right? That can save a lot of time, energy, effort. No one has time to have a multi-year project now, especially in, to kind of just get a value out of it, right? So doing this faster is going to be very useful. Application agent support we talked about. Documentation, right? How many of the engineers queue up to write their own documentation on pipelines? I'm pretty sure none of us, okay? So documenting your pipelines is another big advantage. So it becomes easier to understand what the system is about, right? So those are some of the use cases, right? Again, there can be many, many more as you go along. So that's great, right? It looks a lovely world. It looks like we are all sorted out here. But if we're sorted out here, then why are we talking about it and not already implemented it, right? Obviously, there are challenges and risks in doing this. So let's talk a little bit about challenges and risks, right? So let me read out a quote from Sam Altman, right? I'm hoping every one of you know him, okay? So what he says is that AI has the potential to be incredibly beneficial, but we need to think carefully about the risk it possesses or kind of has, right? So let's put a lens on the word risk here. What does a risk mean? Okay. So let me give you an example, right, of this risk, okay. So imagine it's your girlfriend's or wife's birthday. You want to make it a great evening for her, right? But you are a lazy guy, like every guy is, okay. And then you delegate things to an agent. You tell an agent, please book a cab for me, please book a restaurant for me, please book the menu, the champagne, flowers, cake, gift, etc., etc., right? You delegate all of this to the agent. Now the problem is that a wife or girlfriend will expect that everything will fall in place correctly with a 99% SLA in that sense. Okay. Anything below 99% is not acceptable. Okay. And so I hope you understand what the risk factor here means. Okay. So there's always a risk that you have to take. Data engineering projects, if it's less than 99% correct, you have to be accurate in your data engineering projects. You cannot go below 99%. That's a minimum requirement because the business will not accept it, right? So meeting that 99% SLA is extremely important for a data engineering project to succeed, right? So let's look at some of the risks and mitigations around this. So trust and autonomy. You need human in the loop, so that guy has to monitor what the agent is doing and it has done the right booking or not, otherwise you will be in trouble, right? Explainability, built-in traceability is important. What the agent has actually done, the logs that the agent creates. Security and access control. It has to be role-based access control. It should get access to the right systems only. Data leakage. You need to build in the guardrails, the masking, etc. in your data, so there is no data leakage in that sense. Bias and hallucination, that's a big one. So if you don't have the information up to date, or your agent hallucinates and it sends a gift in someone else's name, you know the problem that you will face, right? So you need to augment it with the right data, okay, through RAG system, etc., right? So agent system do introduce new capabilities and we will have new responsibilities there, but the right governance, observability and control patterns, we should be able to mitigate those risks, right? So that's on the risk part of it, right, that we have. So how is data engineering now changing the landscape? Okay, we'll look at it from 3 different lenses. Okay, so the first lens is around talent and organization shift. What it means by that is, from data engineering heavy teams, we will have agent plus engineering hybrid teams, right? Rise of agent developers and system designers. So there will be agent developers. They will still need context to your data engineering pipelines, but you'll have specialized developers in your team, which you so call as agent developers, which will help you augment your data engineering experience. Specialized skills will emerge. Operating model transformation, that's the second lens. From linear business cycles to more agent orchestrated cycles. What it means? Asynchronous scalability. What do I mean by asynchronous scalability? It really means that the size of your data engineering project will not be proportional to the size of the number of engineers you deploy on that particular project, right? So that's what I mean by asynchronous scalability. More projects, faster delivery, which is great, right? Business value acceleration, radical change, reduction in time to market. That's very important, right? Most of our projects struggle with this particular aspect. How do I make it, rather than months and years, to something like weeks to transform my data engineering landscape? Okay. So who are going to be the winners of this agentic space, right? So the winners will not be organizations which have the biggest data engineering teams. The winners will be the ones who have those smart and intelligent agents that are built, right? Agents which can orchestrate intelligence at scale, speed, and trust. Okay, so that's where we have to reach from an agentic solution perspective and a system perspective. So what is Tredence doing in this area, right? Tredence is transforming the DE landscape. It is building agents on top of all the different functions of data engineering. Ingestion, transformation, consumption, documentation. It is doing a lot of different things. It has a lot of business case as well, right? So think of a scenario where you're asking a question and you get an answer, it runs an ML model in the back, everything happens transparently for you in front, right? So These are all the different things that Tredence is doing in the space of agents. I would highly encourage you to visit our booth to look at some of those demos that we have, right, around agents and what we are doing with agents. So with that, I'll conclude my presentation. Thank you so much for your patience listening, and looking forward to meet you all at the booth. Thank you. Yeah, absolutely. Any question and answers? Happy to say, yeah.
So like before, just put your hand up in the air. We have someone coming up with a microphone. Please go ahead.
Hi, thank you for the presentation. It was very illuminating. I have a question about the LLM itself that you are using. Are you using a foundation model or are you using a fine-tuned model? Because the model needs to know what are the data engineering principles your pipeline is based on, right? So what needs to be done, as well as what is that architecture that has been implemented, right? So and for that you need some historical data to I mean, if you're fine-tuning, you need some historical data to train the model. Right?
Absolutely.
So how did you solve that?
Absolutely. That's a good question, right? So let's take an example of your code conversion patterns, right? I mean, of course, there's a way you can ask the LLM, I have a code, can you give me an output as an example, right? Now, it can give an output to some extent, but obviously, it may be only a percentage correct, maybe 30, 40, 50% depending on how complex your code is. So think of a scenario where you have your own repository of code on which you train these LLM models. And again, it could be any LLM model for that matter, right? We have done it on multiple LLMs models, be it Gemini, be it OpenAI, etc., etc. So if you are able to train your model on those code patterns and then ask the question, the percentage of efficiency can go up to easily 80%, 85%, even 90% at times. There's no 100% perfection here, to be honest, right? And then on top of it, you need to apply some rule-based engine as well. The rule-based engine, because your environment which is there on premise is going to be slightly different. Your schema names could be different. Your organization of data can be different. So it's a rule-based thing that you can apply on top of it. And that's how we managed to solve the conversion issue. So training your LLM model on your code repository is important to increase that percentage efficiency of some of those agents. I hope I answered your question. Sure. Okay.
Hi, I have a question here. So you spoke about various agents for lineage, for object evolution, and so on and so forth, right? These agents, are they Tredence-specific code deployed at the warehouse level or at the ETL level? Where do you deploy these agents typically?
Sorry, I couldn't understand. Can you repeat that? Is the agent specific to Tredence, you're saying?
Yeah, is it a Tredence-built agent? Where do you deploy the agent? Is it on the warehouse side? Is it on the ETL layer side?
So it's on both sides, okay? ETL side, business side. Both sides, we have agents for all of them, right? On the business side, we have agents along a lot of different functions. Let's take an example of supply chain operations. So we have agent on supply chain operations. That is going to, I mean, it's not a simple text to SQL, right? I mean, text to SQL is not that difficult to do if you think about it, right? I mean, you supply your data model to an LLM and it will give you a response, which is great. But to contextualize and understand the data patterns and not only just give a text to SQL kind of a scenario, to get deeper into that question and understand your data and give you recommendations on that is where the magic lies, right? And that's where Tredence is working on a lot of these use cases, and you will see a use case on SNOP in the booth itself, right? On how an agent is intelligently answering those questions and not just doing a text to SQL, as a number of things will be able to do, right? So it's all on the technical and functional side. Sorry, yeah.
Yeah, my name is Ponal Reddy and I am from MathCo, which is an Irish-based compliance company. So we have a specific requirement wherein our customers are like major banks and investment firms, wherein we have to display any compliance-related issue that any of the employees is doing. So there, what we are doing is, as of now, we are generating reports and giving it, and it is getting significant delays at times. And we have recently introduced, we will just directly read the data from the OLTP itself. Instead, what we want to do is like
that is actually giving a lot of toll on the application database, right? And that is a way forward, and that is what we want to do, but our applications are not supporting. So since you said like we can just directly read from the source system also, all that, right? So how do we solve that problem and like keeping an application active faster and reading the reports or like scattering the report needs also?
Sure. So you're talking of the data ingestion problem, right? How do you ingest data from these different multiple sources through something which is more automated? Is that the question?
And also the solutions part of it, right? When customer requires some report, that report has to come from the OLTP directly instead of like wasting time on the ETL and data pipelines. Like the AA agents, how can we deploy the AA agents which can directly hit this application database and give their data reports real time?
Got it. Okay. So ingestion is an interesting problem to solve to start with, right? And there are multiple ways. It depends on the persona who is trying to ingest data. If it's a data analyst kind of a persona, then you can have a notebook or something, whatever, notebook code, whatever you want to think about it, that you pass some parameters, it will create some temporary tables, because at the end of the day, what you really want is the framework, the baseline framework to be established, right? It's the automation part that you want to automate, right? So that no one has to go and configure it, write a YAML file, write a SQL query, get into weeds of things, right? So the framework is necessary. The AI agent is going to automate that particular framework based on the user persona that is there. Okay. Talking of how you can build reports directly on your source system data, I mean, again, of course, you can have automated semantic layer built on top of it. That's your Tableaus, Power BI of the world that sit on your semantic layer, and then you can use Copilot to generate those things. That is one particular option. But typically, we have not seen too many people trying to report directly of that operational system. You want to get that operational system in real time in other place, could be a database, could be a data lake, and then have a semantic layer that can basically respond to you in real time. Okay.
We have time for one very quick question. We'll do the lady in the front. Could we have a microphone move to the front, please?
Hello.
We're going to go there, if you, sir, excuse me, if you don't mind, if we're going to go there, if you don't mind. This will be the last question. Do you mind if we take this question outside once the session is done? If you don't mind, yeah?
Sure.
Thank you very much, madam. Over to you.
Hi, I'm Divya from Brain Labs. So my question to you is, are these agent cloud agnostic? Like, can they work across the clouds? And because each cloud has its own native services, which also has inbuilt services to do the same thing, right? But how do you differentiate Tridents with the cloud native agents for that matter?
So cloud native agents, right? And again, I don't want to name any company, but there are agents very specific to a particular cloud, and that's how it is, right? We always believe in democratization of the data. We have seen with our experience that typically customers don't have data on a single cloud. It will be a multi-cloud environment in most cases, right? People go on GCP, Azure, GCP, AWS, whatever it may be, right? So the important thing is that the tool or the agent in this case needs to be agnostic of the tool it is getting deployed on. So think of your Kubernetes of the world that can come sit on both those places. It's a Python-based agent, so it can sit on any of these different platforms. And that's how you can build out autonomy and make sure that those agents are not specific to a particular cloud or a technology. Of course, you may need to train it based on what that technology is, because you need to still work with the technology, but that agent in itself has to be agnostic, right? That's what we built as part of Tridents.
Thank you for that. Sure. Can we hear a big round of applause?
Thank you.
The gentleman from Tridents. There was a gentleman in the front there. We'll take the question offline if you don't mind. Yes. If there's anyone else who has questions, please meet Mr. Dixit outside towards the side of the stage, towards your left. He will be available outside for questions. For those of you all standing on the sides and at the back, there are a lot of seats towards that side, so you can make your way inside. There are 1 or 2 seats in the middle as well, so make sure you walk in, take your seats. Lots of seats are available. Thank you very much. We're going to jump into the next session. We're here to have a conversation of data platforms that are no longer just about storing information. They're evolving into systems that deliver contextual knowledge and enable smarter decision making. In this session, We explore how modern architectures are shifting to meet these demands. The gentleman coming up on stage has over a decade of experience across data and AI and is leading efforts to turn raw data into decision-grade context. He's here to explain why the future of data platforms is built on intelligence and not just infrastructure. Please welcome to the stage Principal and Head of Data Engineering at MathCo. Please welcome Varun Sarogi.
I'm audible. Good morning, everyone. I'm Varun. Apart from the introduction, keeping that aside, I'm data engineer by heart, been in this industry for over a decade. Passionate about this field, and I like having a lot of conversation around that as well, right? Also, one more thing that I want to point about myself is I am a big Formula One fan. I don't know how many of you are. Quick raise of hands. Any F1 fans? All right, quite a few, but I think the conversation will be interesting. So what I want to start off with, consider that, okay, Formula One is a high-speed race car. It is the fastest car that can, go. It takes the top speed has been 353 kph I think it was in Imola, if I remember well. It's upcoming weekend. So the thing about Formula One is the amount of data that is generated every corner, every millisecond. It's tremendous. It's like no other sports on the planet, right? Again, you can debate with me, but I'm being a fan. I'm a little biased about that as well, right? So what happens is there is no differentiation in how much data you can capture across teams, right? So 10 teams participate over 24 races now, and each of them keep capturing tons of data, gigabytes, terabytes of data every single day of their processing. Now, what differentiates them is not the amount of data they capture, but how do they utilize that data, how their different teams utilize the data, right? So consider you're sitting on the pit wall, and there is a race that is going on, and everyone is fighting for the track position. There is tons of data that is flowing in. The race engineer is talking to the race driver, and he wants to understand what should be his next strategy. The data is there. Data is there in the storage. How do strategy team take care of that data? How does the race engineer take care of that data and utilize that data? The point is not, hey, as a data engineer, I stored the data. So the point is, how do data engineering team or the strategist or the race engineer understand, interpret that data, and provide a lot of contextual information into it, right? So I'll deep dive more into it, but essentially how we are looking at data platforms is it's not just about storage anymore, right? So speakers who have already been on the stage, they shared a lot of insights into, let's not just start building pipelines. It's a world where you have to stop building pipelines. Also in the second last question, there was a talk about context is what drives these agents a lot, right? But I'll also add on to that, context has always driven decision making. It is just that we as a data engineering community haven't taken notice of that. I'm coming from a background of when we used to call data engineering as ETL, extract, transform, load. That's what I used to call myself. Back in the days, 13, 14 years back when I started, I just didn't know that where my career will go. And right here, I'm talking about data engineering, right? So it's a weird place to be in, but I think from ETL all the way to data engineering, I think what not coming our way, we don't know. But what is important for us to understand is the data itself has been evolving a lot, and the decision making as well. For some reason, this has stopped working. Okay, it does not want me to move forward. Can you check once? All right, no. Okay, maybe your steps helped. All right, so this is where we are, right? So our data used to look back in the day when I started, data was on the first left or maybe on the second diagram. Simplistic, take the data, feed into your systems, do analysis, and you're happy with it, right? Now this is what data looks like. This is literally what I scribbled. I thought this is the best representation of how the platforms look like these days. It is nothing beyond that. So what got us to this dilemma, right, of messed up data all along, right? So one is there have been an overemphasis on keep building long-term strategic programs. So leaders like building strategic programs and keep investing on that, and that has been the case all along, right? Not a lot of focus has been put on value-driven engineering or value-driven thought process or how you can add value to your business, right? So I remember working for an investment banking company back in the day where we were building or adopting them to AML, FATCA, those kind of regulatory bodies, right? Back in the day, my only job was to, hey, I work on Informatica. I just want to give data back to my team and the target, and they'll take care of it. I don't understand what the end use cases are, how they're utilizing it, what FATCA is, what AML are, anti-money laundering. I just don't care about all of that. There is this big shift that is happening from there and moving towards more of understanding those contexts, right? Now, then we move towards tool proliferation where there is a lot of conversation around how do you build adjacent tools, not just tools that replace or become better or add more value to it, but more and more adjacent tools, right? And then we move towards more around adding more rapidly evolving and AI/ML-driven infrastructure, right? We all knew that more or less where we stand, this reality that has hit us today, and I think 2.5 years back as well, in terms of getting value out of the data and how agentic systems are making things more complex. Because at the end of the day, we are looking it as a query. That, hey, user will hit a query, we will provide them data. But with every query, there is so much information that needs to go out, right? Because earlier what used to happen is any ML system, traditional or BI system, and I think you all know it. I'm being rhetoric here, but I still want to point that because there are a lot of young engineers also sitting out there, and it is important for them to understand is it's not just about, hey, give me a sales number for a particular region on a specific date. It is also about understanding what that user is, what date are they talking about, what region are they talking about, what specifics are they talking about. So the questions have become a lot open-ended right now. So when you have open-ended questions, your data that you have captured, it is not enough, or the data you have captured in a specific format is not enough anymore, right? So if you have to rewrite the playbook and think about how do we look at systems, right, and how do we build the data platforms of the future, and I think future is here. And I'm not claiming that we have decodified or done everything that is possible out there, but there is an attempt for us to understand how data platforms will move towards, right? So one is understanding how our shift has to go from pipelines to products. I know we have been talking about data products, right? If you have been in this field for some time, and if you're talking to your business stakeholders, everyone wants more control over their data and want to understand more details about their data. So take a specific example where you have a customer 360 that you need to build, right? So the reason for that to build that is your marketing team wants to drive more personalization, more campaigns, and want to target your customers better. So in order to do that, back in the day, what you will do is you will just say that, hey, I'll create a data mart, which will house all your customer data, and that's about it. But now what has happened is there is a shift towards understanding a product mindset in that data itself, right? So you have to build not just a data mart, bunch of data marts underlying your customer 360 to make sure you drive value, whether it is loyalty, whether it is through point of sales, whether it is through n number of customer transactions or customers coming into your store, etc., right? And it has to be varied formats. You just can't say that I'll rely on the traditional warehousing systems, but you have to have warehousing on top of that, put your knowledge graphs, your vector DBs, etc., right? I think you all know it about it already, right? I'm sorry. Now, from there now, it is not just about building platforms for AI, it is building platform with AI as well, right? So what I mean by that is understanding what kind of workflows you can embed, right? So I think there was a conversation around how we can start doing code conversion using AI, right? So traditional methods of migrating your code itself has changed. So in the earlier session of Snowflake, you also saw that there are dynamic tables getting created. There are Salesforce as an example that was taken, right? Salesforce Data Cloud, for example, has come up with all the integration points with multiple platforms like Snowflake, Databricks, of the likes, right? So that the data sharing becomes much easier. And it is not just about building for AI, right? Because you have to understand AI demands a lot of data. It is impossible to traverse that amount of data from your source systems and the amount of investments you have already done. So a lot of the technology providers are also going towards and making sure that they give data sharing as a methodology and not data transformation or moving the data around as a methodology for future needs, right? Very simplistic simplistic approach, but we didn't crack it. All the time when the data we see, we just go and build pipelines, right? That's a shift that is happening now, right? The most important part, I think which I have been pained a lot. So I joined MathCo like 4 years back. Prior to that, I was just looking at it as, hey, I'm a data engineer. I'll care about technology. I'll just push the data into the target. I'll not care about anything else. But boom, I joined MathCo. Everyone was talking about context. Everyone was talking about business problem. Everyone was talking about what value we can drive for the customers. And I was like, I'm in a very different zone altogether. So I had to relearn and redo a lot of my thinking in terms of how do I look at business problems and start decision and build data, not look at data and then think about what decisions it can drive, right? So I think the paradigm shift that has happened, or the transformational shift that has happened, which I think you all are already aware, is how do you look at right side and then go to the left, rather than just looking at, I'll pump in data and I'll make sure that that is available and not look at anything else, right? So that's where it is important that context just does not become noise, and agents, tags, etc. I'm not an AI expert though, but I try to read and understand some of these details out. But from my understanding, I know that you need a lot of context. And I give you an example. If you have to query something, it's an open-ended question. I can go and query anything I want, right? I'll go to an Indigo website and I'll query whatever I want about my travel information. No one can stop me. So if that is the case, then in that case, we have to make sure a lot of these data that we are pumping in are really of value, and there are a lot of context that is driven through that data, right? I've been talking a lot about context, right? So let's try to define it, right? So how we look at context, and I think it's a common phenomenon as well, is broken down into 8 different areas of thinking about context, right? I'll start with our favorite, metadata. We all, in the world of data engineering, metadata is like our super favorite thing that we all do. But what we miss is, with metadata, there is a lot of nitty-gritties and details that needs to be added now. Metadata cannot be an afterthought anymore. It has to be embedded into your pipeline. If your stakeholders, or if your managers, if your leaders, whoever are saying metadata, I don't have an investment for governance metadata, stop working then and there, I would say. There's no point going forward, right? Because without metadata, without tagging your information, you just can't drive any value. So consider a scenario, right? Okay, we'll come to that. First, I want to finish my thought here, right? Second is domain knowledge, right? So like I said, when I fell into MathCo's lap in terms of decision making, there's a lot of issues in terms of understanding the domain itself, right? I just knew data, I just didn't know domain. But every single customer, like a retail CPG customer, I work with a lot of retail CPG customer, they have very different nuances of how they define a lot of metrics as well, right? So how do you take that across different systems and understand that and embed into your knowledge base is very critical. So we are working on those such kind of frameworks, although conversation for later. Then I think there's a lot of conversation around when you query certain information, what kind of RBAC policies you will apply, right? Role-based access policies, for those who are not already aware. So it is important to understand whether that particular person asking that question is the rightful owner to ask that question. It's easy to say that, hey, I'll give access or not give access to the table. But consider a world where the data is coming from all different kind of databases, all different kind of data sources, and in the future, because of data sharing, delta sharing, whatnot sharing happening, how will we control if we don't have control over our user personas or the RBAC policies or any other access policies for that matter? So as a data engineer, we need to take note of that, and every time we start building pipelines, every time we start thinking about this information, these are the things we need to start worrying about, rather than just worrying about building the best pipeline with the best throughput, low latency, and being the most robust pipeline out there, right? We can't be working as a, an engine of a F1 car. We have to be working more as a strategist of an F1 team, right, where we understand the data and we drive those value. Very difficult, but something that we have to start doing, right? Then the other thing is that interaction history, right? So like conversation history of purchases history, etc., the frequently asked questions that people have set in, the feedbacks that you collect from customers, all of that also has to be embedded into your pipeline, right? Then moving on to business workflows, right? So understanding what kind of constraints you have in your entire business ecosystem, right? Being a supply chain, let's say, system, how do you understand what kind of constraints your entire supply chain system has? How do you embed that into your document? Because customers will ask questions. Your users will ask questions. How will you make sure that those questions are translated into useful actions, right? Then I think intelligent assets are more around like all the ML models that you're building, right? How do you tag them? So take an example of like MLflow as an open source system, right, that allows you to do a lot of these orchestration of your ML pipelines, right? If you do not take notice of or start building your use cases on top of that, it becomes very difficult to understand how to go from there, right? Then another thing is some specific tasks that you have to perform, right? That can also be a context in your overall thinking, right? Where there are SQL query logs that are coming in. If someone starts understanding as a site reliability engineer, if you want to try to understand what kind of issue that has happened in your entire system, if you don't understand or push in those logs into your system and store that diligently over a period of time, it becomes a challenge. Now, the ownership you can talk about, it sits with the site reliability team, not with data engineers, but I would still say that process that data, store it in a representation format is the job of a data engineer, right? And I think we cannot talk enough about real-time data in the context that it provides, right? Because I think whenever the data keeps streaming in, it's not just about taking the data from your source and just pushing it in the lowest latency possible. It is also about how do you embed more and more information, right? So take an example of retail and CPG industry where a lot is driven by, and it is so dynamic and it is driven by a lot of customer, how customers behave, what kind of market trends are going on, what seasonality you are in. If your users start asking real-time questions on the data that you have pumped in and you're not contextualizing it with the real-time information, right, that there is a holiday season coming in. So you will contextualize your data or maybe tag or you will feed in more and more information, then I think we are losing the plot, right? So give you a very realistic example, right? So I think we all know that people will start asking questions of, okay, what are the monthly sales from ISEC, for ISECs, right? Now, your system doesn't understand what ISECs is, right? Although your MCPs will go and fetch where it has to fetch, but you have to feed in those information, right, as to what ISECs is for your particular use case, right? We all know it, but are we really looking into it and making sure we take a note and really putting effort into tagging and extracting, putting metadata into those systems? At least in my limited experience so far, I've not seen a lot of focus going there, right? So just wanted to highlight that as well, right? And I think there are a bunch of other details out there, which you all are already aware. I don't want to go into it, right? So then how do we do it and how does it redefine data engineering, right? So we can't be looking at pulling the data from source system, putting in bronze, silver, gold, and just building a data mart, or just let's build a semantic layer, or let's use certain warehousing system like a Snowflake or a Databricks or a Synapse Analytics or whatnot, BigQuery, etc., right? It is also about how do you start understanding the relationships between your data. So like model relationships, right? Not just looking at rows as your simplistic information, right? Building ML ready and relevant information, right? So what ML ready is like, feature store is as an example, right? So looking at customer loyalty score, right? So that cannot be an afterthought or built outside of it, right? It has to be embedded into feature store. I still contest with internally with a lot of my colleagues, but I still feel that these are all the jobs of data engineers, of building these feature store out, etc., right? Because they understand the system better than anyone else, and I think we should take pride in that, right? So yeah. And I think another thing is context-enriched ETL pipelines. What I mean by that is, let's say your data is flowing in, right? Like I took an example of retail CPG. Feeding in real-time information of, let's say, a COVID happened, right? So feeding in that information within your pipeline, embedding that into it is much more impactful rather than an afterthought of how it will be done later, right? Joining tables is very easy, but the kind of systems we are looking at and the kind of information AI systems are trying to extract, the burden on the data platforms will keep increasing every single millisecond that we go, right? So the more and more information we can pump in during our entire phase of information, like all the way from raw till the gold layer and maybe beyond 100 different layers that we use, the more easier it is for us to move forward with it, right? So if we have to talk about 4 to 5 guiding principles, right, of how we can look at modern data platforms, then in that case, I think the first I would start with open standards that we are seeing, right? I think we already saw the keynote from Snowflake speaker that Apache, Polaris have kind of come into existence now, right? And there are wrappers that are getting built around it, right? We already know Delta Lake, right? That is coming in, right? So we have to start adapting more and more. Again, I'm being rhetoric here, but I think it's important for us to keep fixating on these points and understand that modern systems cannot be built on your systems of the past where you are tying everything in one single box. You have to make it much more open and much more federated in nature as well, right? That's where I think, again, we can have a very solid debate on that data mesh come into picture, right? Although in our experience, we have not seen data mesh being readily adopted across or 100% adopted in any of the environment. But I think the whole concept of giving your product level details and having control of your domain, that concept is very powerful. And that is where a lot of the systems are moving towards, where they want control over their domain rather than just control over their data in a specific zone, right? Then again, building low latency systems have also been critical, but I think one thing that has shifted is how multimodal systems are being built right now, right? So take an example of, some of you would have known about Azure Cosmos DB, for example, right? It's a multimodal database, right? So how can you start leveraging those sort of information and not give it an afterthought that, hey, I want to build a knowledge graph or I want to use a document database. I'll keep it, maybe use a JSON within a warehouse system rather than utilizing some of these systems, right? Multimodal systems for that matter, right? So I think some of these decisions have to be taken. There are a lot of investments that go into it, but the more open and the more business-driven thought process we put into these systems, the better it is for chances of us to succeed for such systems, right? Then governance, like I said, back in the day, I remember again from my experience, governance was just about 2 things. One was security, one about quality. Quality, we couldn't do it because we didn't have time. That was always the excuse we gave. And security is something we don't care. It is for the security team to do. And no one cares about data security unless it's a pharmaceutical banking customers, right? Again, retail CPG, we can have a debate all the time on that, right? How secure the data always is. But now the governance shift has happened where if you see lot of platforms are coming with easier ways of doing governance, right? So take example of Unity Catalog or Snowflake Horizon, for example. I think there are a lot of things that are getting embedded into the system which is allowing for easier governance, tagging, more descriptive metadata being aligned to your entire table, column, your model level details are being captured, right? So why not start utilizing that, right? Then I think ops, AI ML ops is very critical, right? ML flow I spoke about, which is a component of AI ML ops. But what happens after your model has gone into production? How do you train? How do you retrain? How do you make sure your DevOps pipeline don't break in the future, right? So those are all very critical guiding principles, right? And I think context I've already spoke about why it is critical, right? Now, where does context engineering fits into it, right? So I think it's a new terminology. When even I was researching few months back, I was surprised that, okay, are they going to take our job as a data engineer, right? I'm always scared about my job being taken by some other engineer for that matter, right? But I'm secured that way because I think if you look at this entire transition or history, right, all the way from domain thinking, right, I think building in those context models like the customer, transaction, and product, if we just look at separate entities, it will not work anymore. The customer has done certain transaction to buy certain product. How do you model that relationship? Maybe through a knowledge graph. That could be a way of thinking it, right? I'm not saying that is the only approach or the right approach, but that's one way of thinking it. And why it is important is whenever there is a query that is fired into by our human agents, so to say, whenever such queries are fired in, they would want information in one go. They will not wait for joins to happen. They will not care about whether you have information about a product or not. Again, very, very naive example, but I think you can extrapolate and understand what I'm trying to say here, right? Then I think in terms of federation, real-time signals, capturing that, I already spoke about. I don't want to spend too much time there. And then I think it is also about how do you build in your rule-based delivery of context systems, right, and align them with policy. And then finally, sorry, I have some less time, but I'll go a little faster. I want to talk about what kind of, okay, I still have time. So, okay, I'll move in. So now if I have to talk about what is that, if I have to look at the outcome that I want to achieve is relevant and trustworthy AI output that I'm looking at, and if I go all the way back, then the way we think it is in a very naive and a very structured way is, first we have to understand what kind of context sources we have, right? Structured, unstructured, metadata information, external. So we can divide it into business, data, and external context, right? That's how we can divide it. And then we basically assemble the context layer in terms of what kind of database we overlay on top of it, right? Whether it's knowledge, vector, it's traditional RDBMS, it's a document store, et cetera, right? And then from there, feed it into your AI systems or your MCPs take it, right? I'm using MCP as if I've worked forever on that. I've not. I just learned it recently, right? So it's a recent phenomenon anyway. And then, of course, governing and monitoring the context, so making sure that even after your pipelines have been released or your systems have been released, there is enough governance that is happening so that you can have those feedback loops and say that whether your data is doing the right, giving the right information that it is supposed to do, right? Okay, so someone played around with my architecture diagram while redesigning it because I'm not a great designer for PPT slides. So if you can see, the access information is coming from nowhere. So anyway, so if I have to put it all together, right, so there has to be a specific focus on metadata enrichment, context serving, and agentic network systems where your context serving needs to have knowledge graph, vectors, searchable systems, etc. And of course, your metadata enrichment setup needs to have all the information that it needs to provide. A shameless plug, there is a second topic that my team is going to talk about in 10 minutes in the hall 2, where we will go deeper into how what I spoke about at a 30,000 feet, they'll go deeper into at a ground level, how do we implement that as well, right? Now, if I have to compare with Formula 1, right, so I think traditional data engineers were pipeline mechanics, right, but now modern data engineers are more like race engineers, where they listen to strategic, contextual, and real-time information, they enhance those and build it out, right? They cannot just be looking at, we will build pipelines, and we will sit on the sofa and we will relax for anything to burn later on. They have to be involved in the process day in, day out. In AI, knowing what data means is as critical as moving it, right? We all know it. And I think we have to move away from being a pipeline builder to strategic enablers in this AI era, right? Oops. So I think a call to action is start designing your pipelines with context as a first-class citizen. And I think I already defined some of those contexts on metadata, business domain knowledge, user personas, business workflows. All of that has to be embedded into your pipeline and not an afterthought. That's a call to action. And I think it's not in F1 also, right? It's not always the fastest car that win. If you have been following last year, McLaren in the second half had the fastest car, but they did not win every single race. Red Bull, my favorite team, also won. And Max Verstappen won the championship as well, right? Although the first half was dominating. But it's also about strategy, it's also about data, it's also about how do you take that data into details, right? So it's not just about building the fastest or the most efficient data platform that has the highest throughput and lowest latency. Now the systems have evolved to more context-driven thinking. Have we cracked it? We haven't. Are we working on it? 100%. So that's all from my side. But yeah, thank you so much for your time.
Thank you, Varun. Unfortunately, we don't have time for questions. Any of you with questions, hands up in the air, so we know we can take it outside. There's someone who did this. So, anyone else? Anyone with questions? Okay, there's one person at the back. We can take it outside if you don't mind. Yes. Thank you very much, Varun. That was fantastic. Give him a big round of applause, please. All right, we're going to jump into the conversation that the next speaker brings to the stage. We're talking about how generative AI is redefining the role of data engineering, from automating pipelines to enabling intelligent data products at scale. This keynote dives into how enterprises can harness Gen AI to build smarter, faster, and more adaptive data systems. The next speaker who's going to take stage is helping global enterprises translate Gen AI hype into real engineering outcomes. And today, he'll walk us through how it's transforming the very backbone of data systems. Before I bring him up on stage, I'm going to ask all of y'all to kindly settle down. There are a few seats in the middle row over there. There are about 5 seats that I can see. Y'all can come forward and take those seats up front. And just as a general announcement to let you all know that if you step outside these doors, there is a space on the outside where seats have been put in, a cooler has been put in, you have speakers, you have the screen, we will show you the speaker and what the speaker is presenting on stage. So we have a little space outside, just in case this room is getting a little too claustrophobic for you. You can head outside, there is an open air space as well. The seats up front have been taken. There are seats towards that side. There are also about 4 seats in this space here. Anyone else, if you have a seat free next to you, just put your hand up in the air so the people at the back. Okay, perfect. There's that whole spot over there that's still available. There are 1, 2, 3, 4, 5, 6, 7 seats that I can count. The people at the back, would you like to move forward? There are seats in the middle there. Giving you all a few seconds to take your seats. All right, and just a kind reminder, we have a space outside as well with a screen, with a speaker, and also chairs and a cooler. All righty, like I said before, this gentleman is going to walk us through a very interesting conversation around generative AI and how it's redefining the role of data engineering. Please welcome to the stage, Head of Technology Consulting at Tiger Analytics, Mr. Prakash Rajgopalan. Welcome to the stage. Give him a big round of applause.
Hi, everyone. Thank you. Good morning, everyone. Can you hear me clearly? Okay, back-to-back sessions, a lot of information, exciting days at DES. So the theme today in most of the sessions is Gen AI, LLMs, agents, all of that impacting across the data lifecycle, right? So what we will look at in this session is to try to take a meta view, look at certain trends, broader implications, and hopefully gain some insight out of this. This clicker needs a lot of effort. Okay. I think I clicked too many times. Yeah. So let's just first quickly baseline what we are looking at, right? So this is something that all of you know by now, that LLMs are text-based. That's where they started. Then they have got multimodal. Coding has become one specific focus area for the LLMs. They are Turing complete. They are creative in the sense they are able to create stuff that they've not seen before. And they are getting autonomous. There are new capabilities like deep research, thinking, that have all come together to make this agentic era become real. So if that's what are the capabilities, what are the vendors claiming now as the next steps, right? So you see the big product vendors, Google, Microsoft, claiming 25% of my code is written by Gen AI, 30% of my code is written by Gen AI. Then Anthropic, which is the leading vendor in the code automation space or code creation space, is claiming that we can do 90 to 100% of code generation will be through Gen AI in the future. Of course, their timeline is 2029, 2030, but that's the claim, right? And on the other side, you can also see that the ChatGPT, which is OpenAI, which brought to fore all this for the consumer space, Sam Altman is claiming that 10% of humanity has used ChatGPT, which is like more than 500 million users on a weekly active basis. It's a lot of stuff, right? Now, vendors will claim what they want to claim. What are third-party vendors and assessment analysts, what are they claiming, right? So if you look at that, if you look at a research report McKinsey put last year, they said 92% of companies are increasing their investment in AI. The question then is, what are the other 8% doing? Probably they've already reached the peak of their investment. Then you have the UN report, which is worried about trade and development, looking at jobs and how jobs are going to be impacted. They're talking about 40% of jobs getting impacted. Doesn't mean 40% of jobs will get automated. Activities within 40% of jobs are going to be impacted by how GenAI is going to operate. Then you have Gartner, which has this hype cycle, which talks about how the new technologies evolve. It evolves in a cycle where, initially there's some skepticism, it's not going to do well, it may not make such a big impact, and then slowly there is an acceptance, and at some point there is a hype is more than the substance. You see that a lot of claims, hey, GenAI is going to bring world peace and hunger, but world peace is done by Donald Trump, so we don't need to worry about that. So that's the kind of thing that there's a lot of hype, but the fact that it is at the peak of the hype cycle doesn't mean it's bad, right? So it means the next stage is adoption into production systems. There is a plateau of productivity which will come. There is a light trough of disappointment. Then we'll follow that plateau of productivity where more and more adoption of these things into production systems, real-world scenarios come into play. The other interesting thing, which again plays into this standardization of features, right? All of the big vendors have same features in their products, right? So all multimodal, code, generative, as well as thinking, deep research, all of these vendors have the same features. It's only a question of which one is more competent for the job that you want it to do. There is standardization that way, and there are also industry protocols coming in which are getting adopted by multiple vendors, right? So you see MCP came from Anthropic, but MCP is being supported by OpenAI. A2A, agent-to-agent framework came from Google, but it's getting again adopted by OpenAI and others. So the industry is maturing. They're not competing for everything. They're collaborating where there is going to be greater adoption. They're competing where there is going to be a deeper silo that they can generate for themselves. Now, if you look at it, how do you look at progress of how agents and GenAI is going to work, right? So there is this institute called METR, which is Model Evaluation and Threat Research. They look at how the models are performing. They've looked at agentic performance. They have a database of 1,000+ tasks and activities. They compare how a human does and how an agent does. The measurement of time is based on how much the human takes to do that task, and the measurement of the agent is how accurate it is to do the same task, right? So they kept a threshold of 50% accuracy and then looked at over time from 2020 to 2025, how is the performance of the agent evolving, right? The trend they came up, this report came about 2-3 months back, is that the agent performance window, right? So the length of the task is, expanding, doubling every 7 months, right? We're all familiar with Moore's law for semiconductors. This is like the agent version of Moore's law. Now, of course, last month somebody else did a research on top of this and said, no, if you look at the window just from 2024 to 2025, the acceleration is every 4 months it's doubling, right? It's not every 7 months. So capability is evolving very fast. If you look at that, then this is the estimate that you see, for how much the agent may 2029, 1 man-month of effort can be done by an agent without an intervention. 50% of the time, right? So it's, don't take this too literally. It is a measure of progress. It is not a measure of 100% success rate for this length of tasks, right? They are able to tackle a task of this length half the time successfully is how they are measuring it. So look at it as a trend that we are looking at it, right? if this is the case, right, so GenAI can do a lot of stuff. So we look at what can it do for the enterprise. It is applicable for a lot of functions across the enterprise. If you look at it, right, when it started, one of the themes that came up was the board GPT, right? You could put instead of a board member for an organization, you could have a LLM sitting there and asking the questions and collating the inputs and providing some insight, right? So that's the strategy part of it, right? So of course, asking questions is much easier. All of us can do it. Finding the answers is where it's a little more complicated kind of work, right? So AI can impact strategy. It can give suggestions. It can give thoughts. It can run a strategy workshop virtually, asking the right questions based on certain set of guidelines and data. It can bring that knowledge to fore, right? Then if you look at it, AI for process. A lot of business processes are going to be impacted by GenAI, right? We see this, there's still a lot of clerical workforce which is still persisting because there's some degree of knowledge, some degree of discretion which cannot be automated through the legacy technologies that we have. But with GenAI, this can be attacked more effectively. So this is one sliver which is going to be much more impacted than anything else. We see this as one area that will become very critical for the enterprise. Then you have data, which we'll talk about a little bit more, where we can look at from ingestion to consumption, which is for insights, how it gets impacted. So that's the strength of it. Then when you have support, support when you're saying tech support or support for platforms and data engineering systems, that also has a lot of agentic approaches that can help solve for it, right? So in one of the sessions earlier, I think there was a talk about, how agents can help with support as well. Now, if we will focus on just the second part of this, that is the data and the other processes, rather than look at the enterprise level of things. Now, if you're looking at this, how do we, break this down? We look at it through 3 vectors in which you can analyze this. One is the data engineering life cycle. There are a bunch of activities that we do. These activities can be reimagined using some GenAI accelerators or code generation agents or others. That is one step. The second thing is any such paradigm that comes, a new paradigm comes, it also brings its own wave of new type of demand or an acceleration for certain kind of work, which is fresh work that will have to be done to enable that paradigm to be successful. That's the one about new demand patterns, right? Then it impacts all of us in the sense on our day-to-day life, we end up using GenAI. The enterprise incorporates GenAI into a lot of the work processes that we do. How do we look at that and rewire ourselves to use it more effectively? These are 3 vectors that we'll explore to see how we can make it right. So first part is looking at reimagining the solutions, right? This is a traditional view of medallion architecture, and then a semantic layer, and then a consumption layer. Across these things, we could look at it from a perspective of what kind of accelerators can be produced using GenAI to solve problems. So if you look at it, the first sliver of things is a data pipeline built from a perspective of data modeling and understanding the data structures, creating the source to target mapping, as well as creating the automated conversion of those source to target mappings as code, right? There's a session already earlier today which walked through this in pretty good detail by our engineers. So that's one way of looking at it at the discovery and the initial build of the data warehouse. The second is code assistance, right? So one is code migration. You could call it as transpiling, moving from one architecture to another, one platform to another, right? SQL to PySpark, so on and so forth, can be done much faster using accelerators that we can bring in forth from a GenAI perspective. You have code assistance when you want to write new functions. This is popular, Cursor, Databricks Genie and such, which can help you, or custom models that you build based on your own code base, learning your own accelerators, templates, your coding standards, which can generate compliant code that is without you having to write the code, right? So you can still give directions and make it work. Then you have synthetic test data generators to help you test it without having to go into production systems and collect the data. Of course, you could have data wrangling to understand what's happening when new sources come in and something is not fitting into the patterns that you have. The third set of things that we have is governance. You have, when you have, and I think that's the theme that you've seen through some of the other sessions as well, the data governance, AI governance becomes very important in this scenario where you have new data coming in, there is an automated operation happening. How does LLM understand data? What guardrails do you build in terms of data governance practices? How is your data catalog enriched? All of this can take the use of GenAI, but GenAI will also take the use of this to make themselves more relevant, right? In terms of data assets, right? So one of the things that we saw is you have, when a newcomer comes to an organization from a business function, there is a whole ton of data assets that they're there, and they need to come in and say, I need access to ABC. And they have to rely on the tribal knowledge. Somebody has to tell them, hey, this is the things that you need to get access to. Something from a GenAI perspective, you can enable a search, metadata search, which helps them say, I am the sales manager, joined for this jurisdiction. Tell me what are the assets that I should request access for. And then take that list and make the access request. Somebody else will review and approve it if that's what your role should provide you the access to, and so on and so forth, right? The last kind of activity that GenAI will transform for sure is support. You have automated understanding of tickets, auto-healing. You can have log analytics, looking at your logs, proactively addressing predictive monitoring. You have the financial part of it, cost optimization enabled through your GenAI-based accelerators, observability to see what is happening in your business process and address it, kind of an X-ray vision for making sure that the processes are working as intended. On the consumption layer, right? So you have a lot of data in the ecosystem, and knowledge-based search is going to make it much easier for people to understand how to relate to the data. And the other area that we see quite a bit of transformation would be on the BI side, right? There is a bloat of BI dashboards across the place, and just going from one dashboard to another for newcomers and everybody else is not very useful. Very periodically, organizations come in and say, can we rationalize BI, right? So remove things that are not being used. Because somebody came, they said, I need this dashboard. They used it for a few weeks, and then it fell into disuse, but it's still there, maintained, all of that stuff. So a prompt-based chat interface to give you insights. So it's not just going to give you a visualization. It's going to come and say, hey, why is the sales for product X dropped in the last 4 weeks? And then it will look at all the data, come back saying, okay, this is the actual data. These are my observations on why it has come down. And you could further even ask, what would be your recommendation? So it goes beyond just consumption of data or insight. It can even be a recommender engine. You can go through this entire cycle using this kind of a prompt-based chat interface for insights. Now, the thing that we need to look at is every few years there is a paradigm shift in technology, right? So when we look at GenAI, we can of course make our own observations, but we can learn from the previous paradigm shifts that we have seen. And in the first slide, I said, the UNCT, I put it, we are in the 5th industrial revolution. Revolution is a very strong term, right? It's like killing everything and starting again. Whenever I hear revolution, I can only think of the French Revolution and the guillotine and all that dramatic activity. But paradigm shifts are, waves of changes. It's a rapid evolution where you go into a new way of working, new operating model that changes things for you, right? So if you look at it, over the last 30-odd years, you could look at 3 paradigm shifts that we have gone through in this context of engineering, right? The first one was in the Y2K and offshoring mix. That's when, people started moving away effectively from green streams, the mainframes, AS400s, and all of that, and then got into this ERP, RDBMS, all of these waves accelerated during this time, right? So it doesn't mean that mainframes have gone away, they still exist, but there's a very clear trend away from it. Then if you look at cloud was the next big thing, right? So you wanted to build e-commerce websites that take a lot of clickstream data, look at it, and then recommendations, all of that stuff. Then NoSQL became quite important, right? So again, I'm taking slivers that are more relevant to data here. Each of these have multiple ways in which you can look at it. There are more interactions that you have. And then the whole wave of, there was at certain time, there was a lot of client-server apps. Even if you look at SAP or Oracle, if you had used it earlier, they used to be a client-server only app. Now, they did a wonderful job of moving it to the cloud, but have the same interface, same degree of responsiveness, which is the wrong way to do modernization. But nevertheless, they have the power in the market to stay, right? So client-server apps went away. Now, when you look at big data, so you have this whole concept data lakes, PySpark taking over in terms of new initiatives. Traditional data warehouses still continue, but they have taken a back seat, right? So that's how it has been over the last close to a decade. Now, there's a question for all of you. What do you think changes with GenAI? It's still early. There are a lot of trends. Anything that anybody wants to offer? What are things that are going to become more prominent, less prominent with GenAI? Sorry, I heard somebody. Self-service, all right. Sorry, data engineering? End-to-end data engineering, okay. Use of unstructured data, yeah.
End-to-end pipeline?
End-to-end pipelines. What is going to go down? Manual things. What was the other one about tasks? Repetitive tasks, okay. Yeah, yeah. So all of these are right? So there's no clear answer. Even mine is a guess in some sense on what is the way that we think it will go, right? So hyper automation, like I think some of these things that you said, right? So repetitive tasks, manual actions, end-to-end pipelines being generated by automatic means. All of this means hyper automation, right? That's the wave that we are going to see, right? Everything people are going to say, automate first, then figure out what the gaps are and fix that again. Right? Now, what's waning, I put in question marks all of these because these are still items in progress. Coding, right? So if you're going to, in terms of trying to, coding is somebody giving you a spec and writing it. Programming is you imagining it and writing it, right? So programming will still stay relevant, but the coding aspect of it will be taken over by agents, right? So if you give the spec, the code will come. Programming languages, if you know one language, that's good enough for you to understand any other language because you're not writing the syntactical structure for each of these code that is auto-generated. So it kind of makes your playground bigger, but at the same time your responsibility larger, right? So we will talk a little bit further about this, right? Now, what could be the new demand drivers that are coming in this kind of a ecosystem in terms of what is the new kind of work that we will see, new or a increased volume of work from a data engineering perspective? If you look at it, then you have things like descriptive definitions, right? So you have semantic layers, metadata, all of this is very important for LLMs and agents to access so that they can create more accurate output. So that's point one, right? So which you look at as things that we will have to develop more. There are more demands for data governance kind of areas, semantic layers, all of that. Then the second is, we'll also see a trend of more real-time sources, more unstructured real-time sources that can be integrated, looked at. For instance, we had, not necessarily real-time, we had a lot of documentation that is created for research, which gets fed in through a system to capture. There's no structure to the documentation, right? So each research report is different, but we still need to capture some aspects of it so that it's a searchable DB. So data observability in that sense will again come in. Then governance, right? So data governance, data quality. How do you test? How do you look at compliance? You know, as AI becomes more and more ubiquitous, governments are going to step in to see, you know, how it is affecting jobs, affecting people. There will be more guardrails the governments want to set. Now we need to ensure that the guardrails are being met in our systems, the way we design and handle it. So this is a very small snapshot of things. There could be a lot more, but the point here is, it is, you know, there's always this question of, you know, is it going to take away my job? Are things going to be like done with a lesser number of people? Yes, the things that we do today will be done with a lesser number of people, but there are things that we will need to do tomorrow that people will need to be employed at. So it's important that we keep upskilling, cross-skilling, reskilling, right? So this is something that I found interesting when I was looking at some of the research for this. Agents, if you look at agents, agents can also make mistakes, right? They may make mistakes. So how do we look at human in the loop? This one, this company which had put this website out, had a very interesting view, right? So instead of saying human in the loop, they are using human as somebody that the agent will call and demand. They said, you know, I'll give you an API, right? So if you look at the code there, it says, you know, human action await human dot operate operation, right? I will have a you know, call center or whatever waiting for the agent to call, right? It's inverting the human in the loop. You know, it's like the agent is calling the shots, saying, you know, when the human needs to intervene for some of the actions. So let's come to the last part of this, which is how are organizations and people having to look at new ways of working, right? So if all of these things, changes are coming in, what are the guardrails that enterprises need to put in place? What are things that they need to look at as part of managing their infrastructure, managing their flow of work while being compliant, right? So the first thing that they need to look at is prompt engineering, which is said, you know, it will become irrelevant, but it still continues to be relevant. Even if you look at agents, many a time their multiple personas are just the same LLM being wrapped in different prompts. That gives us the thing. And there is also a lot of security things like prompt injection and other things that need to be managed from that perspective. The second thing is context. Now, there's a rapid progress in capabilities related to context, right? The last Google model, Llama 4, all of them have humongous context windows, you know, 10 million tokens that they can look at. But if you send 10 million tokens out to the API and get it back, you're going to have a hefty bill, right? So just for one query. How do you wrap the right context for your right query? Some of this will come from the tooling. Some of this may need to be custom done, depending on the platform and the product that you're working on. Other thing is cost. Cost will become a factor as more and more adoption of these systems happen. Just like in cloud, even if you're working on Databricks, for instance, Databricks cost optimization or AWS cost optimization is a fairly involved task. The same thing will come for LLMs because tokens and other things at an API level, you're doing this. The last couple of things is, you know, one of the things that all these models have is a knowledge cutoff, right? So what data that they've been trained on is not current. Of course, now they can also use the browser and access the latest, but it's not the equivalent of having been trained on it. So the architectures that they recommend are influenced by the training data that they have seen. So if the training data is largely favoring a certain set of, and training data is more openly available, right? If it's favoring a certain set of architecture, that's the one that will keep on getting recommended. The second thing is, if there's a new framework that has come last week, 2 weeks back, 1 month back, it will not be picked up by the LLM. So you need to be aware of this. The organizations need to be aware of it. There are ways, maybe you can through prompts have it, or through MCP have these things discoverable at runtime and make them realistic. But that's something for us to keep looking at. And the last point here is we need to keep looking at the vendor capabilities as they evolve. A lot of the things we spoke in the accelerators, some of those things like, the earlier session Snowflake said, we are integrating it into our product, right? If Snowflake is already integrated with Salesforce, some of the data modeling related to Salesforce is going to be much easier when you're doing it in Snowflake or Databricks with SAP, so on and so forth, right? So it's a rapidly evolving space. Companies have to set up the guardrails, decide what, where, and when, and how GenAI has to be used, give freedom to the developers, but at the same time, looking at it. But what does it mean for employees, engineers, right? First thing, engineers have to move from being doers to being, having a boss mindset, right? What does it mean? You need to plan, you need to delegate, you need to review what the agents give you. You need to be clear what you need from the agent. If you are in a MVP phase, you can have a zero shot, hey, build me this, and then look at it, and then refine it. But as you go closer and closer to the production setup, you need to be very prescriptive, be clear on what it needs to adopt, how it needs to, what standards it has to follow, so on and so forth. We spoke about this already, programming languages may not be a constraint for a good programmer. If you know one thing, even now people can pick up fast, but this is going to be even faster. On the fly, you can go in and assess a code of a different language, different paradigm, and look at it. And all of us need to go from digital native to AI native, right? So AI first, think AI first. And the younger generation will be much better at it. Some of us need to get reverse mentoring to see, how we can enable it. The college kids out there, gaming their essays and everything using ChatGPT, they will game how to do better programming also through that, right? So the last bit I'll leave with you is, one of the things that, again, another creative thing, vibe coding has become very popular. But vibe coding, at some point, if you don't know programming, you're going to get stuck. So somebody built this service saying, you build your vibe code, bring it to me, I'll fix it and improve it and move it to production. Right? There are opportunities there which are spotted by some of these companies, but I just wanted to leave it as a last thing. And that means troubleshooting will always be a skill for employees. If you are able to troubleshoot and solve problems, we are good to go. All right, I think enough of the bells have rung.
So unfortunately, I think we do not have time for question and answers, but just in case you do have questions, will you make yourself available outside?
Yeah, sure. We have a booth. Please drop by. Great. Thank you, guys.
Thank you. A big round of applause to the speaker, please. Also, just double checking, if there are empty seats next to you, could you put your hand up in the air because there are people at the back? Okay. The people at the back, if you can just have a look, the hands up are in the air, the hands up. Okay. There are also spaces up in the front here. Also, just a quick reminder, there are spots outside. There is an entire arena outside, which is outdoors. I've noticed people taking cups of tea and coffee and going and sitting and watching what is being presented on the stage, which is also quite cool. So make yourself comfortable outside as well. Alrighty, we're going to jump into the next speaker coming up to the stage. We're going to take a look into the high-stakes world of real-time financial data, where every millisecond counts. This session will explore how to build a scale real-time price streams that powers intelligent financial decisions at a massive scale. This gentleman coming up on stage at I&D Money, he's leading the engineering behind real-time pipelines that delivers price feeds with the precision of a Swiss watch and the power of a fintech rocket. I will give the audience a moment to settle down before we introduce the next speaker. I'm going to request the audience to kindly take your seats and settle down. And if I could also request you to keep your conversations for later before the speaker takes stage. Thank you very much. Please welcome to the stage the Senior Vice President and Head of Engineering at IND Money, Kausal Maladi. Give him a big round of applause while he makes his way to the stage.
Can you guys hear me? Hi. Thanks for the quick intro and thanks for having me here. Really excited to be talking about different dimension of data engineering today, which is the price streams at scale. So as you all know, before I start, so that I have some context, how many of you know what IND Money is? Okay, a few people. So we are a financial portfolio. We started as an entire financial portfolio tracking system, and then later we have on the most important or the challenges that we faced as we started scaling this price streams. And as you all know, I'm sure even if you don't know IND Money, I'm sure a lot of people here would know why it is important for the prices to be streamed at a millisecond level granularity and then at low latency for making the pricing decisions on stocks, right? So I just wanted to touch upon a few business use cases before we jump in the technical stuff. So ideal thing is that we should be having super low latencies. There's humongous amounts of data coming in, about 0.5 million ticks per minute, and that kind of goes to about 2 to 0.5x on any peak days, some event days, some budget, or some sort of an election results and everything else. So we need to be able to be extensible for that. And we also need to be able to power the charts using the same data. We also need to be able to power the charts, and then those charts are very important for the traders. One, to be able to make the trading decisions, and also to look at how the market is moving, and then historically a lot of stuff. And also in the charts, one important thing is that we will end up having a lot of granularity at which the candles have to also be powered. So it's a bit of high quality data engineering problem where you will want to get the data. You already have the data, and then you want to slice and dice it into multiple different candles at different granular levels. And of course, one important thing about any system also is to be able to give the price alert. So whenever user hits a price point, he might want to get notified for his trading decision. And that they could be of multiple types. Okay, if I hit my stock at A value, alert me, and then, or if it could be, okay, if my stock changes at significant movement of 2.5% up or down, please alert me. So these are all the two important things, and obviously you know that I can't afford to send the alerts to the users a little later as well. And of course, one interesting thing that we've come up with is the AI chart pattern detection that I'm going to talk about a little later. But if you have seen, so this is obviously a typical any stockbroking app, and then we have lots of data coming in all the time, and then there is lots of different widgets inside the screens. So humongous amounts of data, both from the receiving standpoint and also from to be able to be served on the client standpoint as well. So yeah, so this is the chart pattern that I was talking about, and with chart, you see that we do power users with some sort of a patterns using AI, and this also needs to be fed the same real-time data that comes along, and then users can make their trading decisions. Here is a bearish pattern, some broadening rising wedge, or this is like a cup and a handle, like a bullish chart pattern. So the point here is there are lots of use cases that are required to be done for a trading system to be able to power using the single source of humongous amounts of stream data. Now, how do we solution in this, right? So what are the infrastructure strategies that we have employed to be able to make this reaching the end users with millisecond latency? Of course, there is a lot of fallback engineering. So the ideology here is that because this is a system where reliability matters the most, right? I can't afford to even go down for let's say a minute or a few seconds as well, because that particular trading opportunity is gone for that user. So a lot of fallback engineering is also required in the sense that both at the source of receiving the data from the source and also to be able to show it on the client devices. So for us to be able to build this fallback engineering, of course, multiple microservices, decoupling of them really helps. So I think I was talking about all those 4 different use cases out there. So all of them could still be powered using one single monolith, because they're all similar use cases working on the same data with different things. The other way of looking at it is to try and decouple them into multiple microservices. So what we have done here is, instead of doing it as a monolith, which is not wrong to do, what we tried doing it is independently deploy all of them as a separate microservices. What the advantage we get with that is, let's say if streaming service has to go down for some reason, there is this chart builder service which will still run and then build the chart. So reducing the damage of a downtime as well. And of course, there's a very important concept of multicast groups, slightly on the networking. I don't want to go deep into the networking side of the things, because this is purely data side of the data engineering side conference. So I wanted to touch upon what multicast group is, how it really helped us to be able to scale our systems to the amount of high scale throughput that we get and at lower latencies. And of course, what is the choice of language? So typically with data engineering, there is always one single way of doing things. People pick up one language, say Python or anything else, and maybe some Spark jobs, and then try to ingest the data and then push it to some data store. That is a typical way of looking at systems. What we tried imagining is zoom out of this entire ecosystem, try to reimagine, hopefully in a different way and in a better way, and then give the better control to the users. So this is the multicast group that I'm talking about. So for people who are interested here about stocks, the price ticks originate from exchanges, and then there is this concept of multicast. So a lot of brokers are all there here in the country, right? So all of them will be receiving that, right, through what is called as multicast through an on-prem infrastructure. And then from then, now for us to be able to power the data to the end users, what we in today's world want is to be able to power from the cloud, right? So you don't want to, you have lots of capabilities of doing it in cloud, so let's not go deeper there. But ideology here is, if I have to run my services in any cloud like AWS or GCP or anything, let's say I unicast into another server on AWS, and from there again unicast it to what is called as a multicast group. So there is a concept of multicast group in AWS or any cloud per se, which allows you to have, let's say if I can have, let's say 3-4 EC2 instances inside that multicast group, and then every machine starts receiving the data that is being fed. So invariably, what my server on the on-prem setup is receiving is being received by all 4 systems. And if you see here, there is no other additional hop, let's say one system sending data to the other. It's just basically directly through just pure play networking being received on all 4 different servers. So of course, the choice of language is also something that I've touched upon. So when we started using Golang, obviously we wanted to ensure that we are doing it with right configuration and then able to serve the users at scale. So what is the optimal number of Go routines, and then how much infrastructure is required for us to run this application? All of that matters. And of course, we built the WebSockets on Gorilla's framework, which helped us stream the data to the end users very fast. And this is very important thing where people should know how much profiling actually happens on your memory, from your memory standpoint, on CPU standpoint, or even Goroutine standpoint on any of your services. So PPROF really helped us to a large extent on that. So the beauty here is this humongous amounts of this data that is being received and to be served to the users is all being served through very, very minute infrastructures, which is small infra workloads, operating, probably a couple of our smartphones are even much bigger than that in terms of infrastructure. So yeah, this is one of the ways how, so when we were emulating lots of data, obviously there is a lot of computation and then also lots of connections. So because of that, there is a lot of CPU utilizations and all of that. So when the CPU utilization was checked in one of the cases, we saw that it was hitting the roof. And then pprof really helped us to nail which exact code block was the culprit, and thereby help us optimize that. So the other way of looking at it is throwing infra to the problem, right? So whenever a problem happens, throwing an infra to the problem versus trying to understand what is the particular code block which is causing the problem and then trying to fix it. So yeah, so okay, what are the other strategies that helped us to do this, right? So apart from the humongous amounts of optimizations that is done, there is always this network where people have to still receive that through the external networks on their devices. So we did a lot of accelerated smart routing. So there is this Argo smart routing from Cloudflare, and then there is also this smart routing. We use MTLS. So with all these configurations, we were able to get to a state where the data reaches the end users in shortest amount of time. I was also talking about this multicast group previously. So with this multicast group, what we are able to achieve is separation of concerns. As you can see, there are 4 different microservices, each of them responsible for doing something different altogether, and then 4 of them being independently developed, and then it's not like one system sending the data to the other. So there is no networking hop per se. So with this ideology, we are able to reach the end user all the way from the exchanges to the end user in very good latencies. So these are all some of the metrics. So we reach all of our 90% of the price sticks to the end users in about 200 milliseconds. And this same thing, the same ideology applies to any streaming systems, not just price streaming systems. So price streaming is one of the use cases that I wanted to present today. But the same thing could be for any streaming systems. It could be for video or audio streaming, or even the price streams that we are doing here. Yeah, coming to the streaming frameworks which helped us do this, there are multiple streaming frameworks with which you can power this data to be sent from the backend systems all the way to different backend systems and to also to the end user client devices as well. So we use NATS, open source framework. I'm a big fan of open source. And so what we did is we just tried reading the documentation, understand how NATS helps us set up the very reliable infrastructure. So it provides a very good high available cluster with which we will be able to stream any amount of data, any kind of data. So here we were streaming price data, but anyone can stream any kind of data where there is lots of data coming in which has to be distributed to humongous number of clients. And of course, the documentation, through open source, you can actually read the kind of code to understand how it behaves. And also there's a lot of good amount of documentation about how to use the libraries from the integration standpoint from the backend and also for the client libraries. And it can be set up in a couple of days without much of an effort. We were able to do that. And then it also supports JWT auth out of the box. So it really helps us in a lot of ways to be able to set it up. Of course, like I said, we learned that the fallback engineering is the best way. So what if this cluster goes down? I cannot afford to go down to my users, right? So we also have a WebSocket server built in-house as well. So this is also used for streaming. So this is like 2 paths, right? A versus B. And like I said, we were using Golang, so we used the Gorilla framework, which also helps you easily build WebSockets out of the box. So with this, you will be able to, again, use this framework to transmit any kind of data with sub-millisecond latencies and still be extensible, right? So I have a couple of learnings I wanted to share here is, of course, there is a lot of map kind of a data structure that is required at any point of time, because you have lots of data coming for a stock, and then you want to send it back to the users who are subscribed to that stock and everything else. So there is a lot of whole bit of operations on map. And then when you have writes and reads on the singular data structure, you always have what is called as you know, the mutexes, right? You want to lock and then unlock and then everything else. So those eat a lot of resources. So wherever there is humongous writes and not as many reads, as many reads as the writes are. So sync map actually does a good job. So it helped us save resources by about 75%. So which again, like I said, these are some of the concepts which helped us to run on a very low infrastructure with very good latencies. And we used network load balancer again.
We're just getting that checked.
Yeah. I don't mind. I think it's back. Okay. Oh, yeah. Okay, so we use. Yeah, better. Yeah. We use network load balancer quite heavily to be able to load balance among multiple different nodes. The advantage of using network load balancer again is that it is the OSI protocol, so that you know, if you are using an ALB, there is always this application layer coming in, a few milliseconds latency. So every millisecond matters. I think that was the theme. That was the theme of that talk as well. So how do we ensure that we are optimizing on every millisecond? I'll quickly run through a couple of important pointers on the tracking of latencies as well, because in the data streaming kind of services, streaming is one part of the things. But how do we know what kind of latencies are being, how is my data being served at what latencies? That is very important. So we did a lot of optimizations on this through payloads with, you know, when we converted the JSON into protobuf and all of that, we found that it was 50% better or even more. And then one of the most important things is people often get used to look at their CPU memory and all of the utilizations on AWS. So what we learned is when you are using data systems, data streaming systems, a most important thing is to see how much network also is being utilized, because every instance comes with X amount of, you know, let's say 10 gigabits per second or anything, X amount of network capacity. So keeping an eye on that helps. And also the APM monitoring through backend latencies, this everyone does. And then most important thing is how do we sample, how much time it's taking for the user. You can always sample some of the data received on the client and then have it instrumented through some APM tool, but you need to look at the fact that not every clock in the world is synced. So you need to do some bit of clock sound, you know, time adjustment as well. And then of course we use quite a bit of Redis ZSet and all of that to be able to, and kind of skipless kind of implementation to be able to power the price alerts for our systems as well. So a few takeaways: common sense engineering, rather than you know, trying to read too many books and then trying to come up with very complicated solutions, simplifying systems. Fallback engineering, always have something or the other as a fallback so that you don't end up running in disasters, and also be prepared for any disasters in case something happens, right? And yeah, of course, the last but not the least, I wanted to highlight the fact of making systems simple, architecting systems with simplicity than over-engineering them. So on that note, I wanted to leave the floor open for any questions that you may have.
So you can keep the mic. We have time for one question. If you have a question, put your hand up in the air. We have the gentleman in the middle. Can we have the mic moved to him, please? Please go ahead, sir.
Hi, I'm Amit Singh from Edelweiss, and we do something similar. Couple of things that, if you can talk about the data size. Are you looking at candlestick data or the tick-by-tick data, which is 1,000 TB per day, and node configurations?
Sorry, I didn't get the question. Is it?
So the price data that you capture,
Yeah.
you capture the market data, which amounts to about 1,000 TB per day.
Correct.
Or just the candlestick data.
Yeah.
And the node configuration on which you process the multicast feeds.
Yeah. So we need to be able to power the charts also with so much of granularity, because charts also need granularity at seconds level, if you are aware. So which means that I cannot afford to drop any packets for the charts use case versus the regular streaming use case. So we need to be still consuming the entire data packet to be able to power both the use cases. Hope I answer your question.
Can we just have the mic go back to him, please? Quickly. Thank you.
So I also hear that people use the nodes, the machines with 500 cores and 1,000 cores. What is the core configurations that you are using?
I mentioned it there, right? So each of the 4 different or 5 different microservices that we have, all of them run on 1 or 2 vCPUs and maybe about 1 GB memory. Yeah. So that's because of humongous amounts of optimizations that we have done at the OS level, at the networking level, and also at the application level.
Thank you, Mr. Maladi. Can we hear a big round of applause for him, please?
Thank you.
Thank you.
Thanks for having me here.
Oh, absolute pleasure. Just in case people have questions, would you make yourself available outside? Yes? Thank you. All right, he'll make himself available outside these doors. So just in case you have questions, please walk up to him. In the interest of time, I'm going to very quickly jump into the next introduction. This is what does it take to architect a unified real-time and monetizable data ecosystem in a global enterprise. This session offers a behind-the-scenes look at building Genpact's Dataverse, a transformation that's redefining how data delivers value at scale. We have a dynamic duo who's going to take stage from Genpact. Your job as the audience is to put your hands together and welcome them to the stage. They are leading this ambitious data architecture journey. Please welcome to the stage Mansi Murarka and Sunil Patil from Genpact with a big round of applause. Just give us a moment. We're going to get them onto the stage. All right. Can I do a little something with the audience while we wait for them? Would that be okay? Yes? Yes? No? All right. How many of you have seen me on these AIM stages before? Hands up in the air. Okay, 1, 2, 3, 4, 5. How many of you have not seen me on these AIM stages before? Hands up in the air. A majority. This is a good thing. Keenan, can you just put my settings on? So, apart from being an MC, I also do a little bit of music. I do a little bit of a beatbox. How many of you have seen a beatboxer live before? Hands up in the air. You obviously have. How many of you have not seen a beatboxer live before? Hands up in the air. A majority. This is good. Okay, beatboxing is relatively simple. You have one mic, you have a couple of speakers, and you do this. Oh, by the way, you have a fantastic sound engineer as well. And you do this. All through the mic. And then you add some more. You go. No. Did you all like that? If yes, make some noise. All right. This is the loudest you all have been so far, which is a good thing. I'm just looking to the side of stage. It seems like they need a few more minutes. A little bit more beatboxing, yes? Okay, the cool thing about beatboxing is you can also use words, sounds, and syllables to make a beatbox. For example, you can say beatbox. Can you all say beatbox? Very nice. Now say beat, box. Okay, it's not beats, box. It's beat, box. Now, with a little bit of practice, you stress on your burrs, and the burrs sound like this. Beat, box. Beat, box. And that's how I learned how to beatbox. The sound you have to go. Yeah? You all are getting it. So try the beat. Yeah. Okay. And you stress on the burst sound. So it sounds like this. You go beat, box, 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 Then you add a scratch, you go no. Yeah. Some more, yes? Or stop and leave? Your call. More, you have to say more loudly, come on. Okay, people are paying attention, this is good. More, I'm going to teach you to do a sound. Okay, it's a sound I've been doing since I started. Do you want something easy or something difficult? Something, so, didn't see that coming. Okay, something easy. When you're really tired at the end of the day and you go home and you sit down and you just go, right? Can you all do that very quickly? Without spitting on the person in front of you, please. Just in case you think spit is going to fly, cover your mouth. Thank you very much. Just go. Yeah? Now, when you do that and you tighten your lips, it'll sound like this. That's all I'm doing. I'm going. Give it a shot. Yeah. When we were little kids, we used to make this sound while we rode our imaginary bikes and drove our imaginary cars. We go. Did you all do that? Yes? Okay, so it's the same sound. You're just going. And on the mic, it sounds that cool. It sounds like a proper beatbox. Sounds like this. People of the audience, welcome to an AIM event. We call it AIM. My name is Vineet Vincent, and this is Beatboxing. Yeah. It seems like I need to get off stage, so one last sound before I leave. Yes? Can I teach one last sound? Okay. Basically, okay, another sound we made as little kids, I don't know if you all still do this sound. It's this sound. You go. How many of you did that? Hands up in the air. Lots of us, right? So, how many of you still do that sound? Hands up in the air. A few of y'all, still young. Nice, I like this. So basically, you're just going, not bad. So you can do it outward and inward. I do it inward, so I'm basically going, right? And then I put a word in it. I say, wow. Can you all say, wow? Wow, wow. Now I go, wow. Wow, wow. And then I add a beatbox. I go, wow, 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 wow. Wow, 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 wow. Thank you all very much. Okay, I've already given you their introduction, but I'll just call out their names if you don't mind. People of the audience, can you give yourselves a big round of applause for being here today? Yeah. Thank you all very much for being a fantastic audience so far. These two people, like I said before, they are a dynamic duo here to talk about what it takes to architect a unified real-time and monetizable data ecosystem in a global enterprise. The two people who know about this, they will be coming up on stage. Your job is to make a lot of noise for them. Please welcome Mansi Murarka and Sunil Patel with a massive round of applause. Thank you very much.
In the age of unprecedented AI hype, it feels like everywhere you turn, someone is talking about AI. AI in products, AI in services, AI in daily life, it's truly everywhere. But let's step into a different view. Let's take a quick tour of our AI kitchen. Here, the key ingredient for any AI recipe is data. Just like a great meal depends on fresh, high-quality ingredients, an AI solution depends on AI-ready data. Unfortunately, today, most of the data we've used, nearly 20%, comes neatly packaged from structured ERP systems. But what about the rest? Almost 80% of the ingredients, the rich flavors of unstructured data like emails, PDFs, videos, sensor feeds, are still sitting untapped, never tasted, waiting to be brought into our AI meals. To truly unlock the full essence of AI, we must prepare and use the entire pantry, not just the easy ingredients, but everything our data kitchen has to offer. For the true essence of AI to be realized, for AI to truly deliver its full flavor, we must build critical capabilities in our AI kitchen. Just like any great meal needs the right setup, our AI journey needs a strong foundation. We start with scalable infrastructure, the kitchen platform that can handle diverse and large volumes of data efficiently. Next is data quality, like washing and prepping fresh vegetables, ensuring that our data is clean, reliable, and ready for use. Then comes interoperability. Just like chefs collaborating, different systems and teams must work together seamlessly. And standing tall as the biggest pole in the tent, the one holding it all together, is data modeling. Because without the right context around our ingredients, structured or unstructured, even the best AI models fall short. Yes, I'm talking about data modeling, the often overlooked, but essential ingredient that makes the AI meal complete. And today, we'll show you how we're reimagining it to unlock the full pantry of AI-ready data. The traditional data modeling capabilities are not enough for today's AI kitchen. We have to reimagine something beyond, and that is Genpact's Dataverse. Dataverse automates data modeling workflows in an agentic way. Yes, an autonomous unit that crunches all kinds of data, structured and unstructured, and helps build intelligent, AI-ready data models seamlessly.
Good afternoon. I'm Sunil, here with my colleague Mansi. From last night, I'm quite unwell. So in the morning, I was not sure whether I can have this session. Then my manager, Sogata here, gave me the Chuck the India speech, and I'm in front of you. I'm not sure how much I can deliver, but I will try my best. So I hope you enjoyed all our AI kitchen tour. And it's time to reimagine most of our real life practices in this agentic world. We will not be surprised for next DEES summit, the corporates will send their agents as the representation. So things are changing disruptively. And today we are going to have the agentic AI tour, basically what we have done, what we have reimagined. We have reimagined the most foundational data management practice today. And Mansi will have that whole presentation, what we have done so far. For years, the AI was a buzzword, but in last few months, thanks to the explosion of these AI tools like ChatGPT, AI has truly democratized. I think you can start
the presentation. हो गया
You can start demo.
So let's begin by understanding what are the problems with traditional data modeling and the decline that it's been facing in recent years. Data modeling, as we all know, is interdisciplinary. It involves multiple teams like business analysts, data modelers, source SMEs, domain experts, and they all speak in different languages. To harmonize these multiple perspectives and create a common ground for understanding is a major challenge. Then there is the heavy reliance on expert skill sets like data modeling, domain expertise, which are hard to come by, and this leads to delay in the data modeling process. Then added to this, there is the manual relay of requirement gathering, emails flying back and forth, recurring team meetings, and tribal knowledge thrown in here and there. This makes the data modeling process inefficient and error prone. All of these factors lead to slowing down of the data modeling process and put project timelines at risk. With Dataverse, which is our agentic AI powered data modeling accelerator, we are bringing about a shift. As you can see on the right hand side, Dataverse reimagines the entire data modeling process through specialized AI agents. For example, the business analyst agent who analyzes the BRD and gathers requirements. The data modeling agent is equipped with the data modeling best practices and rules. And then there is the domain expertise agent who adds industry context to the model. So this process simulates the real world collaboration between teams, and also it bridges the skill gap and through the leveraging the power of LLMs. So Dataverse not only speeds up data modeling, but it also makes it scalable, AI ready, future proof, and inclusive of both structured and unstructured data. Next, what I'll do is I'll walk you through the Dataverse architecture. Can we please switch to the HTML view? No, not the laptop, the HTML view. Yeah. So this is the architecture of the Dataverse, and I'll start at the top left hand corner. So it all begins with the business requirements. The data modeler logs into the system and interacts with the conversational Streamlit UI. Now there are a couple of ways in which he can input the requirements. The first one is by the pre-configured selections that we already have on the UI, and the second is by uploading a BRD or a metadata document. Next, the business case is created and the inputs are logged in the backend for auditability and long-term memory. The backend storage that we are leveraging is Azure Blob Storage and PostgreSQL. Agent Ops is being used for agent monitoring and Key Data Vault for secure data handling. Now we come to the heart of the system, which is the master orchestrator agent. This agent coordinates the working of multiple downstream agents who all have their distinct roles to play. The master orchestrator also decomposes the goal and plans and executes the workflow based on the nature of the input. Here comes the decision point, which is whether the input is a BRD or a metadata document, in which case the workflow branches out towards either the business analyst agent or the source SME agent. So the business analyst agent processes the flow and gathers requirements, and the source SME agent inspects the metadata along with the data files from either SharePoint or direct database connectivity. These agents perform tasks like entity extraction, relationship mapping, parsing business rules, and identifying constraints. The output of this agent is then sent to the domain knowledge agent for enrichment with industry contexts like manufacturing, healthcare, insurance. He is equipped with the Genpact's domain knowledge repository in the backend. The enriched output is then sent to the data modeling agent for creation of the data model by applying best practices like naming convention, normalization, cardinality, etc. The data model is then reviewed by the model review agent who validates it against the data model scorecard, which is a rule of repository for measuring the accuracy, readability, completeness and other factors of the data model. The output is then rendered on the Streamlit UI for visualization and is also available for reverse engineering into popular data modeling tools. Finally, the data modeler can review and refine the output from the Streamlit UI and send it back for improvement in case of any changes. What makes this architecture special is the multi-agent design, where each agent has its own role to play, like the BA or the source SME agent, and they can work autonomously but are orchestrated via the master orchestrator agent. That's all from the architecture perspective. I'll take you all to the real demo now. So this demo is still in the nascent stage. We are still in the process of completing the application. It's in the very initial versions. So this is the landing page, the Streamlit conversational UI, and here we are asked for basic information like the client name, the data modeler's name and the business analyst's name. Now comes, just a moment. Here comes the more information about the client's context. So for example, what industry type, the domain that we are modeling for, the subdomain, this information. So here I am going to demo it for the accounts payable subdomain within the core accounting domain. Once we press confirm for these inputs here, then we get a list of business roles that this is an exhaustive list of business roles for the accounts payable domain. Why this is important is because the stakeholders are the ones who are the consumers of the data and they have certain data aspirations. So the model has to be such that it meets all these data aspirations of the various stakeholders. Then this is an exhaustive list of business use cases. The data modeler can select the ones which are relevant for their particular customer engagement. And similarly, there is a list of pain points which the data modeler can select based on the requirements. Now once we click save here, what it does in the backend is that the business analyst agent is kicked in once the business case is created, and the business analyst analyzes the requirements, extracts the entities, the relationships, the business constraints and the business rules. So these are the tasks that the business analyst agent performs, and once the entities are generated with the definitions, they are vetted by the domain knowledge agent once the business analyst agent shares the output with the domain knowledge agent. This takes some time to return because the query actually goes to the LLM and that's when it is returned. Normally if we were to do this, it would take a while, so I think a few minutes we can spare for the business analyst agent. So you can see here, there are the list of entities and relationships with the cardinality which have been outputted by the BA agent, and the business rules and the constraints for the accounts payable domain. Now next, we will create the business process flow. Now what is a business process flow? It's actually the flow of that particular business and all the actors who are involved in that process and the steps that they all take within that process. So what it does, it gives us a clear view of how that process is operating within that business. So let's give it a few minutes to extract the business process flow. Probably some error with the Wi-Fi. Next, we create the CDM. Now here what happens in the backend is that the data modeling agent has kicked in and he has received the inputs from the BA agent and he is going to apply the best practices which have already been fed to him in the backend through PostgreSQL, and the data model for the accounts payable domain is what the data modeling agent is going to create. So as you can see, it also generates a nice summary of the conceptual data model with the entities, their definitions, the relationships and the cardinalities as well. The diagram also appears for visualization. There's some issue with here. Also, we can edit it in draw.io here, which is a free data modeling tool where the diagram can be edited. So as you can see, it's generated the invoice line vendor and all such other entities that it has identified along with the relationships. Now we can go ahead and create the LDM. So in the LDM also what happens is, again the LDM creation of the logical data modeling rules have been fed in the backend through PostgreSQL, and those are the rules that the data modeling agent is going to use and create the LDM from the conceptual data model. What it does is it adds the attributes based on the conceptual data model. Now I'll take you back to the flow where we can do this whole exercise by uploading a BRD. So that is where the unstructured part of the document comes in. Unstructured part of Dataverse is what comes in. So this was when we were doing the structured inputs. Now we are going to do it through a BRD. So this is a BRD that we have for the retail industry, and it is a point of sales accounts, point of sales subdomain. Once we confirm, then we can go down here and upload the BRD. Once we save it, again the business analyst agent kicks in, who is going to analyze the BRD. In this case, the BRD is about a 10 or 12 page BRD, which gets broken into chunks and is embedded, and then based on the prompts, the BA agent is going to generate the entities and relationships from the BRD. Apologies for the internet also, it's a little slow here. Yeah, it has come back with the business rules, the constraints from the BRD. And the rest of the flow remains the same. The business process flow is created, and so is the conceptual model based on the BRD. So that's it from Dataverse. I'll leave it open to any questions.
Once again, if you have a question, just put your hand up in the air. We shall have someone come up to you with a mic. Yes, the gentleman up front. Anyone else? There's a gentleman at the back as well.
Thanks, Mercy. That was a very informative presentation. I had one question regarding the prompt engineering that you are doing. So is it specific to the BRD, in every case, or do you have some standard templates that work on no matter what the structure of the BRD is?
So there are validations that we perform in the backend, that there are certain sections of a BRD which should be there in the BRD, otherwise it wouldn't be a valid BRD to upload. So that is, we are doing validations on the BRD. That's how we are treating it. But we are not fixing any template as such for the time being. For templatized input, the UI selections is what we have created. So that also serves like a collection tool for business requirements, the UI inputs.
Can we have a mic go to the gentleman at the back? Could you put your hand up once again? Someone make sure we have a mic go there. The gentleman there. Yes. No, the gentleman right behind you. We're going to go to him first, if you don't mind. Thank you. Yes, please, go ahead.
So,
at the back. The both of you have glasses, but both of you are dressed. Okay, please.
okay. So my question is your.
So if you could hold up the mic.
Yeah. Sorry. Am I audible now?
Yes. Yeah.
So the conceptual data model which you are creating using your agents. So what is the accuracy metric you have for the reliability of the output data model? So what is it?
So what we are going to incorporate, which I showed you in the architecture, it's not there yet. We are going to have a model scorecard agent also. So there will be a list of parameters for measuring the completeness, the accuracy, the readability of the model. There are almost a set of rules of about 70 such rules in different categories to measure the accuracy of a data model. This is something that we already have. The data modeling scorecard is what we call it, and the output will actually be sent to the model review agent to measure the accuracy of the model and rate it. And if it crosses the threshold of that rating of the data model scorecard, that's when we'll pass it from the accuracy. And then there's the second point where we come to actual feedback from the data modeler. That's also something we are going to incorporate, that the data modeler can also give the feedback and make changes, which will again be improvised and incorporated in the model by the data modeling agent. So human feedback is an important part of the entire application.
Thank you for that. Can we go to the gentleman all the way at the back? We should come to you, sir.
So, am I audible? Okay, fine. So, I have a question related to the document upload and indexing that happened at the last stage where we were uploading an BRD document. So, I need to understand like whether you are doing
Sir, could you hold the mic up?
Okay, I need to understand whether you are indexing it on the live or is it like already indexed document, because the time it takes to generate the answer is what I'm looking for. Yeah.
It is live. For a BRD, it is live indexing. So that's how it happens. It is happening when we upload the BRD. It's not something that is already indexed in the backend, because it will be a new BRD. And once you have uploaded a BRD and it is already indexed and stored in the vector database, then you need not do it again, which is why we are creating the business case ID.
So for the do you have any restrictions on that file size? Like how much time do you expect to return back the result? Is there a batch process or is it real time? Because if the document size is huge and you are doing it on live, so is there any methods that you do?
So right now what we are doing this is for a BRD. We don't expect the BRD to grow beyond, like it won't go up to 100 pages or something. But even then, like I told you earlier, there are certain sections of the BRD that we are looking for, especially the requirements where the process is described inside the BRD. Those keywords and sections of the BRD is what we are specifically looking for. The entire BRD may not have inputs for the conceptual data model, right?
Okay, fine. Yeah.
Thank you. The gentleman who was there, we should go to you. We should come to you all, and the lady. Yes, please. Could you use the mic, please, if you don't mind, so everyone else can hear your question?
How do you audit the whole end-to-end process, what you have shown, like from the BRD to your modeling? Like, how do you audit that end-to-end process? Like, how do we ensure the accuracy and the reliability of that?
Sorry, what?
How do you audit that? How do you ensure the accuracy?
So, like I answered the gentleman behind you, we are going to be doing it through the scorecard agent. There is a set of rules defined which we have used in other projects also within Genpact. Those rules actually are for measuring the accuracy, completeness, readability, other factors of the data model. So unless the data model review agent, let's say, does not come back saying that it's 85 or 90 on the scorecard, till then the data modeling agent will keep refining the data model to reach that level of accuracy. And then the second, like I said, is the human feedback, the data modeler's feedback.
Do you have anything beyond this, like does it cover the data quality and then metadata or anything?
Quality, governance rules, all of these rules are going to be part of the data modeling scorecard that we are going to create in the backend. That will be a repository of rules for all of this.
Okay, gotcha.
Thank you for that. The gentleman there with your question, please.
So it's about the accuracy and efficiency of the model.
Can we push up his mic?
So we already talked about the accuracy and efficiency, but I want to understand how's the governance is happening. Is there any data quality checks? Because when we are getting the output, what are the parameters?
So actual data is not something that we are using here like you just saw. It's either going to be metadata or BRD. And data governance rules from a modeling perspective are going to be part of the data modeling scorecard, data quality as well. So yes.
The lady with the question there, yes please.
Hi, I'm Divya. So my question to you is, generally the requirements keep evolving, right? It's not just one time. So the BRDs keeps updating. So in that scenario, like how was the complete cycle taken care, right? So there will be a lot of changes in the data model, a lot of external factors will come in play. So in that scenarios, like how do you say that the model is right?
That's a good question. So which is where the beauty of agentic AI comes in. So if we were to do it manually, you know that a human being could lose past context, right? We'd have the older information stored in different places. We may not be able to fetch it when the requirement has changed, and we wouldn't have the historical context while making that change. But with agentic AI, agents have memory, both long-term as well as short-term. So the long-term memory has to be persistent, which is something that we are going to do in the backend with PostgreSQL. And agents also have short-term memory, so even during the one particular cycle, if the requirements are changing, the agent remembers the historical context, which is why agentic AI suits this data modeling accelerator pretty well.
Just a follow-up question on the same note. So you were talking about remembering memory, right? So based on the past data or probably that particular project data itself, right? So when there could be scenarios where you're thinking about storing the past experiences as a part of knowledge base, right? But each client requirement might be different, right? And their requirements, their data sources, or a lot of things change per client to client, right? So, but the same kind of an analogy might not work for client A versus client B, right? So in that case, like what is, how do you think the outcome that you are delivering is right? How do you expect that?
So if you noticed in the beginning, a business case ID got created as soon as I input the requirements. So for each client and the combination of the inputs that the client is providing, we are creating a business case in the backend, which is what serves as the long-term memory for the agents. So for every client and their requirements, it's going to be a separate sort of repository of what their needs and their requirements were. And the agent, as soon as the same inputs are given in again, remembers and fetches that exact memory from that particular client and works on that.
So you're saying it's not cross clients, like the knowledge across clients is
the
not
knowledge
leveraged?
base is for the data modeling rules itself, or the scorecard, which is generic, that can be applied to all customers, all clients, irrespective. It does not have to be customer specific. Even the industry context that the the domain knowledge agent is providing, even that is generic because
Yeah.
that industry will have that. So these are part of the knowledge bases, but the inputs are logged for the
For that
particular customer.
Okay, thank you.
Thank you very much. Unfortunately, that is our time for questions. Would you take a few questions outside if you don't
Yeah,
mind?
sure. You can
Yeah.
come and visit us at the Genpact booth and we can take more questions there.
So the gentleman who put up your hand up front, thank you very much for understanding. Can we
Thank
hear a
you,
massive
everyone.
round of applause
Thank you.
for them on stage? Thank you for that. Very attentive audience, very interesting questions, yes? All right, we're going to move into the next conversation for the day. We have a conversation which is surrounding the idea of, is generative AI living up to the hype? Not without solid foundations, it is not. This session dives into why modern data platforms are the real enablers of Gen AI success. And why is it time to fix the plumbing before we chase the magic? So we have with us someone who's here to share sharp insights and a few hard truths on building platforms that make Gen AI actually work. Please welcome to the stage onboarding engineer at Starburst, Shivani Benur, with a big round of applause.
Hello. Hi. Good morning, everybody. So we are here to talk about something that's in top of mind for all of us. How do we build data platform that not only handles the complexity of today's data platforms, but also unlock the immense potential of data? So we are going to explore how we can move beyond our current limitations to step into a future that is more unified and intelligent data future. Hi, I am Shivani. So I'm onboarding engineer from Starburst. In the past, I've done multiple hats, starting as a data engineer and an implementation engineer here at Starburst. So I'm very excited today to tell you about how we can empower ourselves to lead this transformation. Okay, we all know the data drill, right? So we all have the enterprise data siloed and fragmented across different data sources, and making it extremely difficult to access this data. So what the ETL does is that it tries to skim through all this data, churn huge amounts of data, and try to move into a warehouse. So when we do that, it creates a single source of truth. But with this, the data is often siloed, outdated, and fragmented. So we are not even ready for what are the growing needs of data science and AI, which actually needs to process a lot of unstructured data, creating a lot of multiple copies of the data, again adding a layer of complexity on top of it. And this also creates multiple copies of the data, which also creates inconsistencies as well. So don't even started about managing these data sources and governing these data sources. It all feels like a maze, right? So yeah, so the future of the data that we all want is something that is open data stack. So for us, the data engineers and the data folks out here, the future data platform would hit just that sweet spot where it has the abilities of perform a warehouse without the cost price attached to it, right? And also it gives you the option to use your favorite tools, all your open source favorite tools, right? So at the same time, you don't have to worry about the complexity of moving the data at all. This all makes sense, right? So what we are aiming at is not having just a lakehouse, which you already have, but actually having an open hybrid lakehouse. So to start with the open hybrid lakehouse, how do we build one? So what we need to start with is an open query engine. That is Trino. So Trino is that engine. For those who is not aware of Trino, what it does, Trino is the massively parallel distributed SQL query engine, which is open source. It was originally developed at Facebook for running data at petabyte scale. It's also known for querying data across multiple different sources, that is called as the query federation, eliminating the need to move complex data around and writing scripts. right? So it also has the design so that it can separate your compute and your performance. You compute and your storage so that you can scale both of this independently without to make sure that you save on the cost and utilize your resources effectively. So open architecture of Trino is also one of the reasons why Iceberg, the leading lakehouse table format, was designed to work with Trino. So with proven success at one of the world's biggest companies like Netflix, Meta, and Pinterest, which use Trino to run data volumes such as really high data volumes at petascale at really high concurrencies. All backed by an open source community of 750 plus contributors. So this brings us to Starburst. The first thing I want you to know is Starburst is a Trino company. Co-founded by the creators of Trino, we bring the goodness of Trino to the enterprise. All the goodness without the hassle of maintaining these platforms for you. And we are the #1 contributors for Trino, and also we house one of the largest teams of Trino experts. Now, let's see in detail what are the different features that Starburst brings into the picture. To start with, Starburst is the analytics engine that fits into any environment without making any changes to your existing environment. This brings all the advantages of Trino with the additional enterprise-based features that makes an actual difference. With the massively parallel query engine, which is actually the Trino's query engine, which can parallelly scale and process your data at a petabyte scale efficiently. And we also have data products which actually help you to curate your data sets, govern them, and make sure they are always up to date. And with the fault-tolerant execution mode, which is specifically designed for ETL workflows, make sure that your queries always run effectively. And then with the query optimizer, which optimizes the query way before it runs so that it knows what is the best way to run your query and what are the resources it has to utilize. And starting with auto scaling, so as we already know, Starburst auto scales from gigabytes to petabytes in no time so that you can save on your resources. And also when smart indexing and caching are enabled, you can see a significant difference in the query times. All this combined with metrics and logging features, which make sure you have the entire view of the data and your data platform. So Starburst acts like a central hub for all your data sources. You can plug into it and query any data source that you have. So your data can be a data lake, relational databases, NoSQL, as well as a real-time data sources as well. So this creating a kind of a data mesh for your data sources. This actually breaks down the silos that we talked about earlier of fragmented, siloed data into a true sense of single source of truths. Plus, we have all your favorite BI engine, BI tools that you can easily integrate with Starburst without any changes. Now, let's see what we have in store for data engineers at Starburst. First of all, imagine a place where you don't have to write heavy ETL scripts and move the data in and out and have to spend hours just waiting for the jobs to complete. What if you can do all of that in a single place and get direct access to your data? That's what Starburst does. Starburst speaks your language. So it is all in for the open table formats like Hoodie, Iceberg, and Delta Lake. So you can use the tools that are best fit for your use case with no strings attached. So for those engineers who try to run the ETL pipelines for hours and hours, fault-tolerant execution is that mode of Starburst which makes sure that your queries run reliably. Even if something hiccups and the queries fail, it starts from where it left off so that you don't waste on the progress or on the resources. For those who are more used to using Python, so we have PyStarburst, through which you can actually write your data pipelines within Starburst without ever having to go after the clusters at all. So this all comes with a familiar data frame API, Python, PySpark APIs, and Starburst offers packaging on top of it. And also auto-scaling feature of Starburst helps you to analyze from gigabytes of data to petabytes of data in no time. And the best part is you can actually integrate with your existing tools like dbt or Airflow or Jupyter or Spark without making much changes on your existing data set, making it feel like the integration is just a breeze, right? And whether you're leaning towards a fully managed solution like fully managed cloud solution, you can go for Galaxy, or if you like the flexibility of having everything configured on-prem, we have the option of Starburst Enterprise. All of this comes with Starburst security and governance features that are built right into the platform. Now, let us look at what are the different data problems that we have today. So while Starburst conquers the chaos of the scattered data, the AI revolution has put forward a lot of challenges in front of us. The general purpose AI sometimes behave like how I would do on the exam day. So I would just run through the syllabus on the last day and then try to be really creative on the next day in the exam. No matter what the question is, the answer would still be the same. So sometimes the general purpose AI behaves something similar to this when it hallucinates. Right? This is because AI can't train on data it can't reach, and often your enterprise data is siloed and fragmented, and it is often outdated. And the most critical data for AI often sits into your warehouses and databases very well outside the reach of AI. Along with this, so we have issues with data collaboration as well. So you all are used to the AI initiatives that take really long time because they get stuck into endless POCs, because the IT teams and the business teams struggle to architect and govern the data around these use cases, right? And even if these initiatives make it to the end, because both the teams are working in silos, the outputs that they give, the models that are generated out of it, often lack the relevance, trust, and real-world applicability because they were working in silos. And data governance is fractured because AI use cases involving moving your data across sensitive data, across different technologies like vector embeddings, LLMs, and vector DBs, resulting in increased security and governance risks. Well, when this data comes from different sources, obviously there is very inconsistent policies applied on each of these data sources. And this further increases the security gaps that we already had and adding much more operational overhead to this. Now let's see how Starburst was built to address all of these issues. The enterprise data that you have, which is scattered and siloed across all your data lakes and warehouses, Starburst addresses this by federating the queries right to the data sources with a very powerful and massively parallel processing engine, which is capable of churning out huge amounts of data effectively. Additionally, Starburst also has built-in capabilities for ingestion, whether it's batch processing or it's streaming data. Next, let's go to data collaboration. So for AI to truly deliver the value, the team should be able to use these different data sets, work with them, share across the organization. Well, Starburst makes this possible using the intuitive data discovery tools and a simple SQL access. And also you can curate data sets, what we call as the data products, through which you can govern them effectively and share it with your teams. Finally, the data governance. So data governance is a really critical part in today's hybrid and multi-cloud environments. Starburst provides robust data features, including fine-grained access control, AI-powered data generation, AI-powered data classification, data and network security, making sure that all your data is secure and compliant and only accessible for those who are in really need of it. By addressing the three pillars of data problems of AI today, Starburst enables organizations to unlock the full potential of AI. Now let's switch gears and see for a moment how Starburst can improve the outcomes of AI within your organization. Now, retrieval augmented generation, or RAG. It's like giving your AI a superpowered memory boost. Instead of relying solely on the data in which the LLMs were trained on, RAG applications can dynamically query your enterprise sources and give it up-to-date and context-rich relevant information to derive the insights. Well, what this means is the AI can give you answers, not just on the data it was trained on, but on the data which is up-to-date from your organization and give you context-rich answers. This could be the secret sauce behind your smarter applications, or the engine, or a chatbot, or the engine behind the chatbot that actually knows what it's talking about, right? It's all grounded. It's all about grounding AI in your real-world data, making sure that you get the accurate results out of it. We already established that Starburst differentiates itself in terms of the giving access to the data as of now. So now we want to build a one-stop solution that not only connects your disparate sources, but also enhances AI-powered decision-making without compromising on the quality, security, or control. Now, let's look into two leading techniques of how to connect the enterprise data with LLMs. The first one is RAG. When a user asks a question, something like, what are the latest advancements in quantum computing? What RAG does is it goes to your data sources, your enterprise data sources, which house the critical data, and try to get the most up-to-date and relevant data for the RAG. So this drastically improvises on the relevance and accuracy of the AI-generated answers, ensuring that your answers are always up-to-date and grounded in your own data. So let's move on to the next technique, which is prompt stuffing. So a technique that leverages advancements in LLMs that can accept huge volumes of data as text. With this, you can add or send your data, enterprise data, as much as possible within the texting prompt. So when a user asks the query, summarize this research paper for me, what RAG does is it goes to your data sources, it collects all the relevant, most up-to-date data, maybe a research paper or the articles, and then it stuffs it within the prompt and sends it to the LLM. The LLM then processes the data based on the context which it got from your data, and then gives you the answers which are more relevant to you and up-to-date. So let's see how the RAG behaves and the steps involved in it. Well, the process starts when the user asks a question. In this case, what are the advancements in quantum computing, right? So when the user asks this question, the RAG application tries to go to your data sources and collect the most up-to-date data. That is, what are the recent research papers that were published, and also the articles surrounding quantum computing, right? With this data that is collected, we call it as a retrieval part or retrieval stage of the RAG. And then the next part, the RAG application tries to send this to the LLM. Before it does that, it collates all your data and with the user's question and send it to the LLM. This is called the augment part of the RAG. Next, the LLM generates the response on top of the data it just received, completing the whole cycle of RAG. Just make sure that the results that you get are more accurate, more relevant, and up-to-date. So next, moving on to see how Starburst can help you improvise the questions, improvise the quality of answers that you're getting from your LLM by bridging the gap between your enterprise data and the machine learning models, right? Imagine you're a data scientist and you're given the task to run through a complex observational data and give the insights. traditionally, what this would involve is you have to go to a data engineer, try to collect the data from various data sources, and write ETL scripts just to process it, and then use another set of tools to run your AI functions on top of it. Right? With Starburst, you don't have to do any of that. You can just run it in a simple SQL query as shown in the diagram. So let's say in our example, let's say you have your clinical trials data, which is in your Oracle operational database. And then you want to join the data with the trials that you ran, which is in your Delta Lake because of the cost reasons. Now with Starburst Query Federation, you can join both of these data on the fly. I'm doing so here on the patient ID. So then I'll select the only columns that are most relevant for me, the patient ID, the blood type, and the trial ID, right? So I can call the LLM functions directly from a SQL query. The functions that you see, classify text, extract content, and summarize, these are the actual LLM functions that you can call right from the SQL. And these process the unstructured data right beside the structured data that you have. With this, we are trying to classify here using the classify function. We are trying to see how did the patients behave with the different treatments that were given to them. Is it positive, negative, or inconclusive? And once I get that, I will try to extract the NPS pain value from the symptoms, which is a list of different symptoms that the patient went through, right? And after all this, I would like to summarize and see the top 10 results. What this actually does is, given a data set of trials, it tries to identify how did the patients behave based on the different treatments they were given, based on the different treatments they were given at different pain scale, right? So this would typically involve, medics and data scientists going through a lot of data, but with this Starburst, you can just do it in a simple SQL query without ever having to leave the platform at all. So we understand at Starburst, we understand that one architecture cannot really be a solution for an enterprise. So we give you the flexibility to choose your own backend. That is, you can choose any LLM that you want, whether it's something which you have homegrown, or it can be third-party apps like OpenAI or AWS Bedrock. Now let's see how we can integrate RAG within SQL, within Starburst, right? Consider an example. You are the operational person in your office, and you want to understand what is the top reasons why the dashboard was down, and how do we stop that from happening. So for this, where we start is trying to collect the data for this question. That is the support tickets that have been sitting in your platform, in your data sources. So we'll try to get the data from your support tickets from a simple SQL query, right? And the question that we have is the slow loading times on dashboard. We want to understand why is it and what are the solutions for it, right? So we are utilizing the vector search, and we are calculating the vector embeddings for each of the ticket that was generated in your system with the question that the user has, slow loading times on dashboard. And we are trying to limit it to 10 because we want only the top relevant 10 tickets that were created that was relevant to the question that we have. And then the next step is we'll create the prompt out of it. And the prompt, we can use a simple SQL functions like concat and list aggregate. The concat will try to glue in together the question the user originally had, and then we have the list aggregate, which actually collates all the results that you got from the previous stage. That is your tickets. And then from this, it is sent to the LLM using the prompt SQL function. This prompt is configured to hit any LLM endpoint, whether it's on cloud, on-prem, or it can be anything that is homegrown. So with this, the LLM will be able to give you answers which are actionable on based of the data that you already have. Now, there are many ways how you can integrate Starburst within your RAG workflow. Now we can see one example of how to do it, right? You can start by collecting the data from your varied data sources and using by ETL, that is extraction, transformation, load, and chunking the data into manageable pieces. Either you can use Starburst or Spark. Like I said, we are open for open hybrid solutions. So, and then while you're collecting and running your ETLs, you can also create your embeddings based on the data that you just collected and store it as iceberg tables in your own data lake. These iceberg tables are governed. Let's call this Starburst Ice House. And then the next, when the user asks a question, it goes to Starburst AI search. What it does, it does a full vector search based on the vector embeddings that you generated in the previous step, which it has in the delta lake in the form of iceberg tables. And it also does a full text search because the vector search gives you the semantic similarity or understanding, and the full text search will add on top of it. And next, we try to combine these two results to give you much more contextually aware answers which are more relevant to you. And then we use the Starburst AI functions like summarize, extract, classify, sentiment, and prompt. These are the functions which you can use to call your LLMs. And these doesn't have to be on-prem or cloud. It can be anywhere that you want. It can be anything that you want, right? And the prompt tries to gather the context from the AI search, also with the answers, also with the original question that the user asked for, and sends it to the LLM for generating the response. And all of it is underpinned by Starburst data governance and compliance via Starburst data products. So all the embeddings, vector embeddings, and text indices that we just generated are stored in your object storage, and which are fully governed by data products. Remember the questions that we initially had about data access, data collaboration, and data governance? Starburst solves it all. Thank you. We have much more content to share with you. Please meet us at the booth. Thank you. Yeah.
So in the same format, if you have a question, put your hand up in the air. We shall have someone come up to you. The gentleman up front. Can we have a mic go up to him? Can we have a mic up front, please? He's making his way. It's like a forest he's getting through. It's okay, we'll wait. If you could just pass the mic on, thank you.
Thanks for informative session. So my question is related to is it in the first part of the session we have seen that we may not need to move the data, and then it can be solved through federated way. Many times we have seen often when the data is logged in different places, so the characteristics when we access the data, like for example, data is there in relational databases which cannot perform analytical queries, or if we run analytical queries natively, then it will create troubles. So in this case, the Trino which executes the query on those databases directly rather than moving the data natively, so will it not create the pain at the time of read, like when we are waiting for something to happen? So sort of like I'm saying, we remove the ETL or ELT part from there, from the process, but that was giving some advantage in terms of like when we have repeated things which we know, like how we wanted to get the data, so we make the data ready, and then during the read path things becomes more simplified. So like
Right. So even when you're trying to move the data from your data sources, what you usually do is extract the data, transform it, and get into a format which optimizes your search, right, into a warehouse. So Starburst does all of that for you when you query the data sources, which you anyway do, and then you store the data. if you want to run your analytic workloads on certain sets of data for BI purposes and things like that, you would still store it in a Delta Lake, right, with iceberg tables. And what Starburst gives you, which you do in other ETL aspects as well, what Starburst gives you on top of that, it has smart indexing and caching. So with these features enabled, every time you query the data, we cache the data and also create indexes for these caches. So the more often you hit these queries, the more efficient it becomes, and it takes very less time.
Okay, so in a way you are saying that sorry.
Yeah, so unless you really want to have the data which is accessible really fast, you can have an option to store the data in a lakehouse, or you can directly query the data sources, which anyway, even if you store it in a place, you would query it. Even if it is in the original form, you would query it, right? The times would still be the same because it is going to your data source itself. Just that moving the data, just that if you create your iceberg tables within your lakes, Starburst will, you'll get the best of the iceberg tables and also the enhancements of querying, caching and indexing on top of it.
Thank you, understood.
Thank you for that. I'm guessing there are no other questions. Can we give a big round of applause to the speaker on stage? Thank you very much for joining us. We are going to move on to the next session. This is going to be the first panel here at this event. We're going to get 4 people onto the stage. It's going to be a riveting panel, I promise you that. It's a question on every data engineer's mind. And this is something that I noticed that a lot of the other speakers and presenters also talked about. It is the conversation around, will AI automate us out of existence? That's one of the conversations that's going to happen on the stage. The conversation is, will AI automate us out of existence as humans? Or will it elevate our role to new heights? So this is something we are about to unpack on the stage. We have 4 gentlemen who will be taking stage to have this conversation with us to unpack the future of automation, Gen AI, and the evolving role of data engineers. We're joined here by an absolute powerhouse panel. I will be bringing them on stage momentarily. We're just doing a very quick setup while that happens. And just to let you all know, there is also a space outside that is having a live telecast of what is happening on stage right here. You will see the speaker, and you will also see the presentation that the speaker is putting onto the screen. There's also a speaker where you can hear all of that. And just to run you through, in case we have any confusions with the format of taking questions, all you have to do is put your hand up. I will be on stage. I will look at you. We'll have someone come up to a mic with, to give you a mic, basically. Hopefully, it'll be faster than what happened before. Everyone's good so far? Yes? How many of you all are done with lunch? Hands up in the air. How many of you done with lunch? Okay, how many of you yet to do your lunch? Hands up in the air. Okay, that's the majority. I shall join you all over lunch right after this is done. We're going to have 4 gentlemen taking stage, like I said before, very quickly having this set up. The conversation we're about to have on stage is talking about the question that a lot of us have on our mind right now. And that question is, will AI automate us out of existence, or will it elevate our role to new heights? To unpack this, we have the following gentlemen taking stage. Please welcome the engineering head, Enterprise AI ML Solutions at AMD. Please welcome Vikas C. Sajan to the stage with a big round of applause. Vikas C. Sajan, if you could come up to the stage. Welcome to the event. Please do take your seat. This is DEES 2025, our first panel of the event, our first panel for the day. Joining him on stage, we have the Vice President of Engineering and Architecture at FSS. Please welcome Anirban Roy to the stage. Big round of applause, audience, big round of applause. Joining them on stage, please welcome the Senior Vice President of Technology at Make My Trip, Sambit Sarangi. Big round of applause, people of the audience. the gentleman who has the honor of moderating and having these conversations with these gentlemen on stage. Please welcome Vice President at Genpact, Saugatha Dawari. Make some noise for these people on stage, people of the audience. This is DES 2025. This is your first panel of the day. Gentlemen, over to you.
Thank you. Am I audible, right? Clear and loud? Thank you, and warm welcome to kind of one of the most hot topic that I feel before you guys are all waiting for the lunch, right? It can be taken as an appetizer before you go for lunch. And from the morning, we have heard many of our colleagues and friends, they spoke about how Gen AI, agentic AI are disrupting the data engineering. So with that, and that's the place where we are actually going to go more double click, that whether, we all know that it's actually disrupting, but what about, can it be completely automated? Can Gen AI or agentic AI will completely disrupt the end-to-end data engineering lifecycle, or there obviously will be some human intelligence, there will be human dependencies that will always be there. So that's our topic, and with that, what I kind of request my panels, right? I will go with Anirban first to share his experience about automation, how he feels that how the automation has really changed in the data engineering from last 1 or 2 decades, and what are the new changes in the automation that he is using in his organization. So that should be the first topic which I will request Anirban to throw some lights.
Thank you, Sagatha. So, interestingly, when we started our journey, and when I started my journey, in terms of automation, there was nothing much. It was all about putting everything out there as what you could say a brute force code. Even for data, you have to go and ask people that do you have the right set of data with you, and then assist them to understand their data structures, get it into place, and then use all your intuition and all your understanding to create the models and all of it. So it was all kind of manual when I started the journey. Now, over a period of time, what seen is that in last couple of years, and even 5-10 years, lot of automation that has come, at least in the integration space. Now, you have a data source, you have connectors, a lot of automation has happened to get the data from those connectors. When you get that data, then how do you, sieve through that, look at the quality. There are a lot of automation that is happening at the space where I'm working now, where the data quality and the gaps in the data is kind of, we are addressing using a lot of tools and automations. So that is one, advancement that is happening. We are using it on a continual basis. And recently what we have started to see is the use of agents to not just collect the data, cleanse the data, but also look at models. I will also probably, at some point in time, we will talk about how generative AI is getting into the space and changing the entire mechanism in which, the ERDs and stuff gets created automatically. So the agents are at play now, right from the collection of data, creating some of the curation of the data, finding out gaps in it, even helping you with, structures of governance, right? So all of this is something that I'm currently seeing and also using. And also at the same time, I'm a student of it, of data engineering and data science all my life, so learning also the new things that is now coming up, which was not there when I started my journey. Right?
Perfect. Thanks, Anirban. So that means like the shift already started, right? From the traditional automations to more Gen AI and agentic AI-wise automation, right? So
yeah,
that shift started.
It has definitely started, and I feel that it is here to stay.
Okay.
Right.
Thank you. So now I'll go to Sambit, and again, will request him to share that what he feels and what he is doing in his organization about automation.
You can hear me? Okay. I'll just go back to 20 years back. 20 years back, data engineering was all about ETL, right? People has very less amount of data. They were just trying to find out, bring in the data, put it into a place, and if you can do a daily report, that was like deja vu, right? 2005, when I was doing Walmart data architecture, 60 terabyte data. When I looked at 60 terabyte data, I had no idea how to handle those kind of data. There was no real technology tools available at that point of time, right? Here we are, 2025. At Make My Trip, we handle about 8 to 10 terabyte of data every day, right? So that's the scale. The scale has changed significantly. And what's the business dynamics here? So when, if you ask business, they will say, we are a B2C organization. For us, everything got to be real time, right? And then they'll talk about, you need to build a system which is scalable, right? And where we cannot really define this schema, and everything has to be observable, right? So that's your fundamental three characteristics which business is talking about to you, right? You build systems. I don't know what will be the system look like, but it need to satisfy that it need to be scalable, observable, and it has to be real time. When I say real time, at Make My Trip, we compute about 100 different user-specific metrics every 15 minutes. So my on-ramp, off-ramp runs on all of those kind of data, right? And we are talking about booking information. I will exactly get to know that Bombay to Delhi, every 15 minutes, I am supposed to do X number of booking, and the number, if the number drops, we'll exactly get to know number has dropped, and these are the correlation pattern, why it could have been, and is there is an intervention required or not required, right? That's why we are sitting. So what has changed? Fundamentally, a lot of automation has changed, definitely, right? One of the biggest part of the automation is basically data. A lot of our data is structured, so in that way, you really don't have to worry about, missing data and, data out of bound and all of those things. But one data basically go through hundreds of schemas, right? Because I'm doing minute compute and all of those things. So dynamic, schema mapping, calculations, running function on top of it, because it's not like 5 set of engineer who is writing the data functions, right? Anybody can write a data function, drop it, and my compute need to run on part of it, right? And the bigger part of it is basically the anomaly detection part of it, right? How do I run my anomaly detection? The problem with anomaly detection is too much of noise, either false positive, false negative. A lot of time, the causation is not the correlation is not a causation. Then how do I figure it out? What kind of guardrails I do that part of it, right? So if you really look at automation, everything that we do, how do you create orchestration using Airflows, and what kind of data structure that we are going to look at, what kind of feature store that we are going to look at, how much of code we can generate, right? Practically, a lot of our code is get generated, right? And a lot of stuff that we do on top of AB, right? Anything which I can define as a function, mathematical function, is all automated, right? That's where we are right now.
Perfect. Thanks, Ambed. Now I'll come to Vikas. And Vikas, you are part of AMD, right? As part of the semiconductor, that is the more place where. But help to understand, right? Like, what automation exactly mean in your area from like the traditional automations, what we are doing there, and then how that change in the current world?
Thank you so much, Sogata. Yeah, hope you guys can hear me. As Sogata said, right, so we at AMD, right, I mean, we are one of the largest GPU vendors, and the way we sell GPUs is based on the solutions we sell on top of the GPUs, right? So that is nothing but, we have a solution called ROCm, which is an open source solution. What does it mean is, I mean, that also houses a lot of models and everything else, but the biggest driver for those models is the training, right? And training comes with data. And the biggest automation change what we have seen in last 10 years, right? It could be, as one of the sessions which I was hearing, AI in data and AI in process and AI in insights, right? The data labeling and data annotation makes a big part of our journey, in which we train the model with a labeled data, in which labeling the data itself was a huge thing, and annotation and everything else, right? And if I take you back to around 2015 or sometime, where just before joining AMD, we're working on autonomous cars, and we had this driver monitoring systems where the human being, the face has to be annotated, and that used to be a laborious process. But fast forward 2025, now we have automated the whole sort of whole of annotation and labeling, and that enables us to sort of improve the efficiency and the kind of productivity we have gone in terms of either failing fast or doing a POC quickly on a particular model increases by multifold. That's on the AI data part. And look at the process part, right? I mean, gone are the days where we're only talking about DevOps. Now we have gone into the areas of DevSecOps and MLOps, where we need to ensure that all these data pipelines which are needed for training and inferencing has to be continuously monitored, and we need to have alerting mechanism and sort of diagnose themselves and fix it proactively. Probably we'll come to those points when we talk about self-healing architectures, but that was one of the areas where we have got a lot of automation in terms of pipeline monitoring and data ingestion to our training and inferencing segment. So that way, coming 2015, it was completely manual and laborious and not very productive. 2025, fast forward, we have automated sort of all of AI. We have brought data AI, we have brought AI into the process, and we have also brought AI into the insights, and which will give us some kind of monitoring dashboards, which will help us to make sure we are doing the model training and inferencing pretty quicker.
Okay. So what we heard from all our panelists, that there are automations happening, right? That automation used to happen in the past, and automation is happening today, and automation will continue to happen in future, right? But let's now try to understand from them, right? Like, because of this shift that are happening in the automation journey, right? How the roles are changing. We will want to get into a more detailed deep dive with our panelists to understand how the data engineers' roles are evolving, whether data engineers are getting replaced completely or we still need data engineers with a shift in the role. And also we try to understand from our panelists that what they think about the future in respect to how we are going to shift in more on the data engineering things, right? So with that, again, I will go to Anirban. And we heard from Anirban that currently there are lots of automation happening. But Anirban, my question to you is that we know that data engineers used to build pipelines. That is one of the main core functionality of data engineers, right? So they used to build the whole pipeline from the data ingestion, and then they establish the data quality, they ensure the consumptions layer having the right data. So in the current world, what you see is that role shifted from doers, where we need engineers to really build those pipelines, or the engineers are required to oversee the pipeline, to govern the pipeline? So how you like, what's your reflection on that part?
Yeah, see, there's no easy answer to that, right? It is little nuanced. It depends on what kind of maturity in your data lifecycle your organization is, right? If you are a very mature organization and you have put all the tools and guardrails and governance structures and everything in place, then your data engineer is not just executioner, right? He would have moved into the role of a data steward or a data governance guy, right? If you're at a lower end of maturity, you would still be doing a lot of those doer kind of executioner kind of activity, but at the same time, you would also be doing a lot of this data stewardship and governance kind of activity. So when I say that, what it means is, even if you use a lot of automation, the end result of that what kind of ingestions it is doing, what kind of transformation it is making and realizing, right? That has to be looked at by a human. So often what we refer to as human in the loop, right? So the data engineer is now becoming more of a guy who is a custodian of all that is happening around in the data landscape. Plus, there is a big area where there's a lot of relevance, and this is where the data engineers also needs to graduate, is managing the entire complexity of the landscape, right? There's so much of tools, platforms, technologies that are available. How do you make sure that you make a prudent choice of what to use? Because there are a lot of dimensions, even in terms of time quadrant, right? And the cost angle to it. If you put an entire data pipeline and data architecture in place, what is the cost that will be involved in terms of what you choose, right? So architectural choices, the overall design, that is something which is not going away. I mean, and that is where I think the value will get added more, not at the bottom of the pyramid, I mean, where it is all about automation and executing the thing, but in terms of architecture, governance, stewardship, a lot of standards and governance frameworks that are coming up, like your GDPR and AI Act and all of that, right? How do you make sure that your enterprise, your entire data landscape is compliant with that? Those are the things where the role of the data engineer, according to me, is kind of shifting.
So to you, is like the repetitive work can get automated or will be automated, should be automated,
That's
right?
an
But we don't need
eventuality.
the data engineers at that level of skills. But still the governance, the compliance, the regulatory, bringing multiple tools, what tools should be, so that advisory might still require a data engineer's role is shifting towards more advisory and consulting instead of doers, right?
Right,
Okay.
right.
So with that, Sambit, I'll come to you about, we heard AI is like kind of driving lots of autonomous decisions. It can take decisions by itself. So do you feel in the whole, the life cycle of data engineering, we have data governance, data quality, and we used to do anomaly detections on those using data quality, right? But do you feel that AI is still mature enough to understand all the various business context, the changes in the rules? Like for an example, suddenly there is a change in the tariff that has happened, right? So how the automations of leveraging AI along with the business context should come into more data quality and data governance? What are your thoughts on that?
Absolutely. So what fundamentally AI does, AI has tremendous capability to process information at scale, identify patterns, right? Spot patterns, and based on that, probably tell you what is the next big action or insight, right? That's exactly what it is doing, right? There is no real decision making happening. It is simply pattern. It is no different like if you take a 5-year old boy and you throw a ball, very unlikely you will catch it up, right? But if you do 100 times, you'll find the boy started catching it up, 8 out of 10 times, and probably after 3 months he's probably catching all 10 out of 10 times. Does he really learn the physics, the curvatures, the speed, the what is your terminal velocities and all of those things, and they are applying and catching it? No, not necessarily, right? He's simply applying. From his previous experience, he has captured some insight, and based on that insight, he's taking action, and there is a reinforcement learning happening, and that's exactly how the boy has learned, and AI is no very different from that. So if you can construct anything to a formula, I think you don't need developers. And two things, right? One is basically you should be able to construct, you should be able to verify, right? So I know 2 plus 2, as long as I see an answer 4, I'm fine, right? So that means when you are doing your data engineering, you need to make sure that your feedback loop is closed. So if you have 100 use cases that need to run, test case need to run, it is running. As long as this test case is matched, you're fine. Right? That there is no observability, nothing is required on top of it.
Mm-hmm.
But fundamentally, there is no context, right? So you have defined a schema where you're saying customer ID is not null, right? Integer. So it can have any value, and suddenly you see a customer, not customer ID, customer age, and you see a customer age with 150. It is probably anomalies, but it doesn't really understand that a person age cannot be 150. It cannot reason out, right? And it cannot reason out a 150 person, health insurance probably is not available, or it will be 10x of a 20-year guy, right? It has no reasoning. It probably just saying anomaly is part of it, right? So as long as you are doing pure anomaly detection, there is no problem. But it has no real business context, right? Looking at a revenue number, it cannot take, this is the top line of the organization, because there is no context, right? So, and data engineering is not about build, right? How typically a data project start? Data projects start with business strategy, right? Fundamentally, if you go to TOGAF, you talk about business strategy, data architecture, application architecture, and all that part of it, right? It start with a business strategy, what exactly we want to solve, what kind of insight we want to build. There is some hypothesis, then you figure it out, what kind of data I'll really look at, do I have the data, I need to build some system to capture the data, right? Lot of those discussions happen, and there are a lot of underlying motivations, whether it is political, social, that needed to be handled. So there is a lot of trade-off discussion happens before you build it. And once you come into an architecture, you are trying to figure it out, whether it's an enterprise architecture, whether it's a large scale, whether it's a small business unit, try to play something out, right? All of architectural decision, your AI is not going to do that for you, right? And none of your business strategy, your AI is going to do that part of you, right? Once you laid that things out, your tool selection AI is not going to do that for you. Once you figure that out, now I am in a phase where I want to test it out, implement it out, start creating a pipeline, store it and validate part of it. That's the build part of it, right? So what we talk about build part of it. All of those build you can, it is code. End of the day, it is code, and there is already a lot of knowledge base already been created, and I can look up into those knowledge base and create, irrespective of the language, right? That is fully automated. Your job is to create the closed loop. You know what is the use case, test case that you need to run. You need to figure it out, how do I stitch together my test case and figure it out whether my test case is running, if the test case is running. So your job is to make sure you create those guardrail, create those domain, because there is a lot of places where you'll create false positives, suppress those part of it, right? Create the pipeline, create those test cases. And that's your job. And that is probably much important job than actually creating the pipeline part of it, right? That means you will have lot more time to actually go and solve large business problem rather than actually stitching the last mile.
Got it.
That's how that's how I see the actual career progression is going to happen.
Okay, great, Sambit. So what I understood is that there obviously the business logic, the domain context is very imperative, very important, and while AI can still be kind of be a catalyst where we can keep on fine-tune the models, we can kind of self-reflect the models, but there will be some advisory that we need to keep on provide to the AI so that they can understand this context and they can self-heal and achieve the goal, right? Okay. Thank you. So I'll come to Vikas, right? Like with the what Anirban and Sambit mentioned about the pipelines and the quality governance, right? There's another word which is coming very frequently nowadays, is called autonomous architecture, which is called self-healing kind of architecture, right? So can you just help us to kind of make us understand, right, what exactly the autonomous data architecture looks like, and can it be really a self-heal from the ingestion, from the quality, from the governance? Can everything be kind of self-driven? Can you throw some lights on that?
Yeah, sure. So, I mean, if you look at a typical architecture, right? I mean, that largely the layers you can see is you have to detect whether the pipelines are running or not, properly, and then you have to diagnose if there are any issues with the pipelines, and then probably you have to respond or maybe mitigate it, right? These self-healing data architectures, I mean, it is not fully mature yet, but there are a lot of efforts being done towards to make sure we sort of automate some of the layers at least in this self-healing architectures. Say for example, detecting, right? I mean, one is monitoring and alerting, wherein you can look at the pipelines and see, if there are any anomalies, if there's something going wrong with the pipeline, and some of those aspects of data monitoring kind of a thing can be automated, and that's where the self-healing architecture comes into picture and sort of has a lot of tools today, right, where in terms of Monte Carlo or Big Eye, where you have monitoring and alerting systems, right? Once you detect those kind of a things, you have to diagnose and root cause, because it can't be just you detected something and, of course, I think there was a discussion point about human in loop kind of a thing, right? And of course, there is an aspect of where human in loop has to come into picture, and where sort of, you can't be automating everything else, right? Having said that, so there are ways to, the diagnosing part, the root causing part is still not that mature. There is still, it is like, there's a bit of a human, there's a bit of a logging mechanism, and then probably before applying the root cause, the responding part of it, right? So you cannot go and respond and sort of fix the issue. There could be issues in terms of governance, it could be issues of ethical governance, I should say. There could be a lot of data outliers, which are, when an automated AI can try to fix it, but it may not be falling under the policy that may actually go fix it, where we are actually trading off the quality to the uptime. We want to make sure the architecture is always up and running, but what if you just make sure it is up and running, but what about the security aspects? What about the GDPR aspects? And what about the compliance aspects? So the self-healing architecture, it is sort of going at a fast pace, but we are not there yet. But there is a need for a lot of guardrails in terms of we need to bring in so that all this self-healing architecture do not go overboard and sort of put a lot of fixes or anything else, right? If you look at the human intervention and auditability, you should be able to audit why this particular fix was done. Is it for this particular use case, this user story, or is it for a particular policy, right? If you take as one thing fits all kind of a thing and start fixing and mitigating the issues, so we need some guardrails like this where you should be able to audit, you should be able to explain why this particular fix was added, and we need to have human intervention, and we also need to have some kind of a governance so that with these guardrails, we can become more of a AI literate architects, AI literate engineers, than of allowing everything to AI to do, right? So that's where there is there's always a trade-off between how much you want to automate and how much you want to give it as a human in loop kind of a thing. So I think it is still maturing, but probably you will see maybe another 3 to 5 years from now, probably the 70 to 80% maybe self-healing, but there is still a lot of a lot of aspects has to be figured out, wherein all the task levels can be automated and self-healing, but as the panelists were saying, right, there are a lot of policy-driven things which need to be taken care of.
Okay, so with that same context, right, like what I heard that it's real. There are self-healing architecture is the concept is going on. We are making it real with some guardrails, with some audits, and it will get more mature, right? But tell me, like Vikas, did that mean that we are kind of AI is democratizing the whole data engineering space, right? Because what we are saying now, it will be a low code, no code, like zero ETL, right? The architecture can be scaled, auto scaled by themselves, right? So what I'm trying to understand more is about, like now even a non-data engineer can manage a whole data platform, right? So do you feel that that's the democratization is really happening now?
Yeah, that's a good point. With this advent of all the Gen AI and everything else, right? So there is, of course, entire not only data engineering for that matter, everything is getting democratized where everybody has access to all this chatbots and Hex and chat GPTs and everything else, right? Where there is a lot of democratization happening across other landscapes, but coming to a data engineering part of it, right? There is sort of a divide is getting created in terms of tool users and tool creators. The way it is democratizing the whole data engineering aspect is, look at data analysts or business analysts, where it actually helps them to sort of input some of the user stories to LLMs and probably come up with some kind of a generate the code and probably do a quick POC, and they could fail fast. In that way, it is giving access to a lot of non-engineers who could try things and do quick POCs and make sure that whatever the idea they had, they could test it and fail fast, or if it works, they could go ahead, right? So that way, it is giving access to data analysts, business analysts, business users, product managers. There are cases where a lot of my product managers have a couple of engineers in their teams. They actually get access to these LLMs and sort of do a quick POC, and even without coming to our engineering team, they sort of figure it out themselves. So that way it is democratizing, but there is a clear divide between tool users and tool creators. What I mean by that is, the fact that the tool is so easy to use and everything happens magically, that you query a question and everything sort of comes out. You have a code snippet, you have a test case, and everything magically happens under the hood, right? The fact that it is so easy, that means it is quite complex under the hood. So that means that there's a clear divide between who creates the tool and who creates the user. On one aspect, it is a democratization between how the data is used and data engineering is getting into, but the engineering is sort of should move into understanding the complexity of the whole tool creation under the hood. So that way, I would say it is democratized, but there is a clear divide between the users and the creators. And coming years, I guess more of the data engineers should focus on how do we ensure that the complexity is sort of is reduced, and they could make sure it could percolate down to more users of data engineering. So I think that's what I believe. You getting access to the tool is good, but there's a clear divide between the creators and the users.
Okay, thanks, Vikas. So we are almost on the time, but I'll still go with the panels for kind of 30 seconds to 1 minute on your kind of reflection about what really cannot get automated. So I'll go to Sambed, and if you can just spend 30 seconds and help us know that we all discuss about the automation, right? And we are all saying that future we will do more automation. But do you think anything which can't be automated at all?
I think we briefly spoke about the upstream activities, business strategy, architecture, a cool design cannot be automated. And a lot of data products, we speak, we generate code. But the most beautiful data products are those which are most optimized, right? Because of the velocity and the volume of the data. And the quality of the code that you can write, if you have the experience, cannot be substituted through a machine. Because machine will try to write a very generic pattern of that code part of it. That still cannot be automated. And any organizational politics cannot be automated. That needed to be factored, right? And that's a big part when you are actually a data engineer.
Okay, thank you. I'll come to Anirban. What's your closing statement on that?
Yeah, so I talked about the policy frameworks and, of course, the governance angle, right? To me, I don't see it getting automated anytime soon, because obviously there are political angles to it. There is context of a country handling that data context. Those are there. So, for example, the same query, if you fire in India and you fire in Pakistan, based on the recent events, what has happened, you will see different kind of results. And if you exchange the results in the two countries, the effects that you'll have in the societies also would be really funny or scary, right?
Yep.
So those are the things in terms of governance and stuff. I think that is something which is not going to get automated.
Or we might need to mature on more of responsible AI, ethical AI, right? So that the responsible AI needs to be matured much more to actually get into that kind of automation. But
yeah, ethical AI and ethical, practices, that is something, or machine ethics, that is something which is not going to get automated. Yeah.
Thank you, Anirban. So I'll go to Vikas for your last closing statement.
I'll make it quick. I think time is up, I guess. But yeah, I mean, what can be automated? I mean, what could be replaced by automation? If you look at anything, right, it's like three parts, how, what, and why. The way I look at it, the how part, the execution, the low-level mundane tasks can be automated, and that's happening today. And the what and why part is where still needs a lot of scope for automation. So that's where I would request all of data engineers to look into the architecture and sort of a thing, and sort of least focus on the automation part of it, right? And because all code generation, writing test cases can be automated, and it is getting done. We are doing it every day as we speak. So focus on what and why, because how is taken care already. Thank you.
Thank you. So thanks to AIM for giving us the opportunity to have a great discussion. I'm not sure, like we are already time sharp. Do we have time for a few questions? We don't, okay? So if you guys have any questions to the panelists, feel free to ask those questions outside. They're all available, and they'll be happy to kind of provide more response and more detailed response to it. Thank you very much.
Thank you all very much. Can we hear a big round of applause for the first panel of the day? Thank you very much, gentlemen. We really appreciate it. If you could get together for a quick picture right in the middle, that would be fantastic. While they're clicking pictures, just a quick announcement to the audience. We shall be back at sharp 2:45. Mark your times. 2:45, we're back in this room to kick things off. If y'all come a little early, I'll do a little performance for y'all, if y'all would like that, yeah? So lunch is being served outside in the lobby area. Please make your way outside. Once again, thank you very much, gentlemen. It was a fantastic panel. And we shall see you all back at 2:45. Yep.
By 2025, enterprise spending in Gen AI will soar by 50%. And it's not just statistics, it's actually a call for all of us. And we're already helping many organizations create the value by reshaping customer experience, by generating the content in every medium, by automating innovation, by improving demand planning, and also streamlining many different data and business processes.
Traditionally, large language models operate in zero-shot mode, producing output token by token without revisiting or refining their work, much like writing an essay in one go without any revisions. While impressive, this method has its limitations in achieving top-tier quality. Agent workflows address this by introducing an iterative process, enabling LLMs to refine their outputs.
Are you tired of using the same data quality approach without seeing improvements? Remember, the root cause of 80% of data issues come from development, 15% from operations, and less than 5% from the data itself. Think of your data system as a data factory. Implement data reliability engineering. 1. Implement data testing during development. 2. Monitor your data processes. 3. Observe the data and the system in production. With IceDQ's unified data reliability platform, automate data testing, automate data monitoring, implement data observability. IceDQ, data reliability engineered.
MathCo began with a bold yet simple vision in 2016 to help enterprises unlock the full potential of their data and solve their most pressing challenges. We started as a small, passionate team of problem solvers, driven by the belief that data could empower businesses to think bigger and do better on their own.
Self-sufficiency remains at the core of our offerings to enterprises. We strongly believe that we live in an age of hyper-personalization. Enterprises, in the quest for being digitally at the top of their game, often face critical challenges. Challenges that can result in millions of dollars lost or missed opportunities to earn them. They're looking to evolve while overcoming their own unique set of challenges.
We today engage with more than 60 plus global enterprises across multiple verticals like retail, consumer goods, pharma, technology, and many more to come.
We're here to enable them to make smarter, faster decisions with enterprise intelligence. It's not just about solving problems, it's about building trust both with people and with tech and creating everlasting value.
Our strength doesn't just lie in numbers, it's in the unparalleled expertise of our mathematicians. Our people are the heartbeat of MathCo. They innovate, collaborate, and bring ideas to life in ways that drive real-world outcomes.
Every individual has a space to take ownership, make an impact, and shape not just their careers, but the success stories of our clients.
Everything we do revolves around creating meaningful experiences, whether it's through exceptional delivery for our clients or the way we collaborate and support one another as a team.
Field for specialists, scientists, experts. An amazing technology, but so complex only a few people could use it. Well, that doesn't fly with Snowflake. Since the day we were founded, we've made it easy for all types of people to work with all types of data. And today, we're applying that can-do, let's-do, will-do attitude to AI. We're eliminating complexity, simplify, 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 and putting the power of AI into the hands of everyone. The era of enterprise AI is here. It's easy, efficient, and trusted. Right now, thousands of organizations around the world are driving success in the AI Data Cloud. Join us, and let's put AI to work for you.
In a world clouded with complexity and ambiguity, there exist significant opportunities for disruption and growth. At Tiger Analytics, we help our clients navigate this uncertainty, empowering them to move decisively through shifting sands, unlocking these opportunities. We work with our clients to strategize, design, and engineer a future-ready enterprise. At Tiger Analytics, we've been reimagining possibilities with cutting-edge AI and analytics, solving some of the toughest problems out there and building the blueprint for tomorrow. And at the heart of this mission is our battle-tested team of exceptional technologists and consultants. It's our unique expertise and character that enable us to create exceptional value even in hazy conditions. That's our Tiger Gene. The Tiger Gene is what makes us learn relentlessly, experiment without fear, seek help and offer help. The Tiger Gene is what helps us uncomplicate complex problems, build for the future, deliver clarity amidst ambiguity. To our clients who are traversing a fog of uncertainty, we are not just a technology partner, we are a certainty partner, relentlessly seeking, solving, challenging, and growing. Together, as we set bold ambitions and target extraordinary outcomes, let us experience the power of data-guided decisions, the potential of connected insights, the promise of an AI-empowered future. Experience certainty to shape a better tomorrow with Tiger Analytics.
AI is changing the world around us, and the complex world of software development is no exception. EPAM AI Run is transforming the entire development lifecycle, not just by generating code, but in supporting multidisciplinary teams, boosting enterprise-wide productivity and optimizing every step of the process.
AI Run, it really helps us accelerate product ideation. It helps us arrive at new product hypotheses more quickly.
You can validate your hypothesis faster in production.
Writing test cases.
With keynote requirements, help us align our product roadmaps.
Instant market research.
To create stories.
For rapid and collaborative business case development.
AI Run drives a first-time right approach, boosting speed, productivity, and quality, from project onboarding to product deployment, with an ecosystem of trained Gen AI agents that unlock next-level collaboration. It's a natural evolution for one of the world's leading engineering and innovation organizations.
At EPAM, we have been delivering tech-enabled solutions for leading global enterprises for over 3 decades. Over the last decade, our AI capabilities have accelerated from early apps and code generation to enhancing the efficiency across the entire SDLC.
All the silos that were existed in the form of ticket passing back and forth is gone.
It's a better quality product, it's faster product. It doesn't replace real humans, but allows us to do better our research work.
With a superior quality product at a 30% faster time to market, AI Run delivers instant ROI.
It's kind of in the name, AI Run.
We're revolutionizing the way we deliver digital products with EPAM AI Run. The future made real.
By 2025, enterprise spending in Gen AI will soar by 50%. And it's not just statistics, it's actually a call for all of us. And we're already helping many organizations create the value by reshaping customer experience, by generating the content in every medium, by automating innovation, by improving demand planning, and also streamlining many different data and business processes.
Traditionally, large language models operate in zero-shot mode, producing output token by token without revisiting or refining their work, much like writing an essay in one go without any revisions. While impressive, this method has its limitations in achieving top-tier quality. Agent workflows address this by introducing an iterative process, enabling LLMs to refine their outputs.
Are you tired of using the same data quality approach without seeing improvements? Remember, the root cause of 80% of data issues come from development, 15% from operations, and less than 5% from the data itself. Think of your data system as a data factory. Implement data reliability engineering. 1. Implement data testing during development. 2. Monitor your data processes. 3. Observe the data and the system in production. With ICEDQ's unified data reliability platform, automate data testing, automate data monitoring, implement data observability. ICEDQ, data reliability engineered.
MathCo began with a bold yet simple vision in 2016 to help enterprises unlock the full potential of their data and solve their most pressing challenges. We started as a small, passionate team of problem solvers, driven by the belief that data could empower businesses to think bigger and do better on their own. Self-sufficiency remains at the core of our offerings to enterprises. We strongly believe that we live in an age of hyper-personalization. Enterprises, in the quest for being digitally at the top of their game, often face critical challenges. Challenges that can result in millions of dollars lost or missed opportunities to earn them. They're looking to evolve while overcoming their own unique set of challenges.
We today engage with more than 60 plus global enterprises across multiple verticals like retail, consumer goods, pharma, technology, and many more to come.
We're here to enable them to make smarter, faster decisions with enterprise intelligence. It's not just about solving problems, it's about building trust both with people and the tech and creating everlasting value.
Our strength doesn't just lie in numbers, it's in the unparalleled expertise of our mathematicians. Our people are the heartbeat of MathCo. They innovate, collaborate, and bring ideas to life in ways that drive real-world outcomes.
Every individual has a space to take ownership, make an impact, and shape not just their careers, but the success stories of our clients.
Everything we do revolves around creating meaningful experiences, whether it's through exceptional delivery for our clients or the way we collaborate and support one another as a team.
Each mathematician's goal aligned with a larger mission to empower decision makers in global enterprises to own and activate intelligence.
Our goal is to scale MathCo from where we are to 10 times our size. 10x in terms of the value that we add to our customers, the quality of experts we have on board, and the capabilities that we invest in. All in all, we want to be a one-stop shop for all our customers' digital transformation needs.
Until recently, AI was a field for specialists, scientists, experts. An amazing technology, but so complex only a few people could use it. Well, that doesn't fly with Snowflake. Since the day we were founded, we've made it easy for all types of people to work with all types of data. And today, we're applying that can-do, let's-do, will-do attitude to AI. We're eliminating complexity. Simplify, simplify, simplify. And putting the power of AI into the hands of everyone. The era of enterprise AI is here. It's easy, efficient, and trusted. Right now, thousands of organizations around the world are driving success in the AI data cloud. Join us, and let's put AI to work for you.
In a world clouded with complexity and ambiguity, there exist significant opportunities for disruption and growth. At Tiger Analytics, we help our clients navigate this uncertainty, empowering them to move decisively through shifting sands, unlocking these opportunities. We work with our clients to strategize, design, and engineer a future-ready enterprise. At Tiger Analytics, we've been reimagining possibilities with cutting-edge AI and analytics, solving some of the toughest problems out there and building the blueprint for tomorrow. And at the heart of this mission is our battle-tested team of exceptional technologists and consultants. It's our unique expertise and character that enable us to create exceptional value even in hazy conditions. That's our Tiger gene. The tiger gene is what makes us learn relentlessly, experiment without fear, seek help and offer help. The tiger gene is what helps us uncomplicate complex problems, build for the future, deliver clarity amidst ambiguity. To our clients who are traversing a fog of uncertainty, we are not just a technology partner, we are a certainty partner, relentlessly seeking, solving, challenging and growing. Together, as we set bold ambitions and target extraordinary outcomes, let us experience the power of data-guided decisions, the potential of connected insights, the promise of an AI-empowered future. Experience certainty to shape a better tomorrow with Tiger Analytics.
AI is changing the world around us, and the complex world of software development is no exception. EPAM AI Run is transforming the entire development lifecycle, not just by generating code, but in supporting multidisciplinary teams, boosting enterprise-wide productivity and optimizing every step of the process.
AI Run, it really helps us accelerate product ideation. It helps us arrive at new product hypotheses more quickly.
You can validate your hypothesis faster in production.
Writing test cases.
With clearer requirements, help us align our product roadmaps.
Instant market research.
To create stories.
For rapid and collaborative business case development.
AI Run drives a first-time right approach, boosting speed, productivity, and quality, from project onboarding to product deployment, with an ecosystem of trained Gen AI agents that unlock next-level collaboration. It's a natural evolution for one of the world's leading engineering and innovation organizations.
At EPAM, we have been delivering tech-enabled solutions for leading global enterprises for over 3 decades. Over the last decade, our AI capabilities have accelerated from early apps and code generation to enhancing the efficiency across the entire SDLC.
All the silos that were existed in the form of ticket passing back and forth is gone.
It's a better quality product, it's faster product. It doesn't replace real humans, but allows to do better our research work.
With a superior quality product at a 30% faster time to market, AI Run delivers instant ROI.
It's kind of in the name, AI Run.
We're revolutionizing the way we deliver digital products with EPAM AI Run. The future made real.
Artificial intelligence.
AI.
Coexisting. AI.
By 2025, enterprise spending in Gen AI will soar by 50%. And it's not just statistics, it's actually call for all of us. And we're already helping many organizations create the value by reshaping customer experience, by generating the content in every medium, by automating innovation, by improving demand planning, and also streamlining many different data and business processes.
Traditionally, large language models operate in zero-shot mode, producing output token by token without revisiting or refining their work, much like writing an essay in one go without any revisions. While impressive, this method has its limitations in achieving top-tier quality. Agent workflows address this by introducing an iterative process, enabling LLMs to refine their outputs.
Good afternoon, everyone. This is the part where I wave once again and say hello to you. And for the few of you all paying attention, you can say hello back to me. Hello, hello. Hello, hello, hello. Everyone's okay after lunch? Yes? Everyone's done with lunch? Can I hear a big yes if yes? Okay, that's a small yes, but we shall work with it. Would you like a little bit of a beatbox before we jump into the first speaker post-lunch? Yes? Yes or no? Okay, super. I'll quickly do a little something for you. Actually, I'll teach you while I do this as well. So, a couple of things. I call this the techno bass. Basically, I'm hitting the lowest note I can. Keenan, can you put my settings on? Thank you. So I basically hit the lowest note I can, and I'll walk you through it. Can everyone just go, just find like a comfortable sort of a pitch while you're just saying, yeah, for different people it's different pitches, right? So now what you have to do is you have to close your mouth and the sound comes out through your nose. So it's basically, little louder if you can. Perfect. Now what you have to do is, by the way, if you start coughing and whatnot, take sips of water, you'll be better. While you're going, you're basically squishing your throat together, you're squishing your vocal cords together to stress it out a little. So you're going, yes, someone's getting it over there. All right, so that's the sound that you need to get. And when you keep practicing it over and over again while you take sips of water so you don't mess up your throat, it starts sounding like this. And it's all coming out through your nose. And then you add a little sound to it. So you're going, and when you hold the mic all the way up there, it sounds like this. Okay, people are paying attention, people are awake. This is a good thing, this is a very good thing. Now can you all say hello to me? Hello? Super, this is good. This is a good way to start something after all our bellies are full with a lot of food. Okay, up next, we explore what it really takes to enable machine learning and Gen AI at scale. And it all starts with the right foundations. With over 2 decades of experience designing scalable data platforms, our next speaker is helping global enterprises at EPAM Systems unlock the full potential of AI. People of the audience, since all of y'all are super awake now, I'm going to ask all of y'all to please welcome our next speaker to the stage with a big round of applause, the Senior Director at EPAM Systems, Srinivasa Rao Kattu Boina. Please make a lot of noise and welcome him to the stage. Come on, with a bigger round of applause. There we go.
Okay, thank you. Yeah. Okay, thank you. Good afternoon. I know the post-lunch session has always been difficult. Today, the session is going to be intelligence data platforms in the era of machine learning and generative AI. We are hearing a lot of noise in AI, and everybody is talking about it, and a lot of pressure within the enterprise systems and enterprises in terms of what to do with this noise. How do we address that noise with the existing data platforms? So I'm going to talk a little bit about evolutions of a data platform, and if you see, AI noise is everywhere, and it is being increasingly in multifold these days with agentic architecture. Now, we have had an opportunity to build data warehouses, data lakes, data lake houses, and the RAG systems over a period of time. All of them, some form of, the batch in nature. The moment you get to the generative AI, you need to look at data differently, the platforms differently, and the way you process them differently. That is where real time is going to be a lot more important, and hence, how do we reinvent data insights and actions in the era of agentic architecture? Let me talk about a little bit is that everybody is talking about a data-driven organization. Now, in the context of machine learning and AI is also a data-driven, we have seen a lot of challenges. Everybody says that it takes a lot of time in processing the pipelines, processing the data, right? Everybody complains about reliability of the data, quality of the data. Everybody talks about, hey, I don't have any governance today. With all of these challenges in the last 30 years, we build a lot of data platforms. A lot of advancement happened using a machine learning, deep learning, and neural networks. Yet, the moment we see generative AI, the moment we see agentic architecture, our platforms, which has been built over the years, is tumbling. And it is a time for us to relook at what is the best way to really need to see that. The diagram which I put in here is some kind of a thought process to see what is really needed. Do we need engineering frameworks? Engineering frameworks were always there over the years, and we are all build automated pipelines and using a metadata driven approaches, but that is not sufficient in the era of agentic AI. You need to really think about it differently. We always been talking about data lakes. How about open way of looking into building some of these data lakes, right? And similarly, right, everybody is talking about algorithms, Gen AI, and frameworks. The reason I call it as the intelligent data platforms is that can we bring in a lot of intelligence to all of this, whatever we are doing? When we are building a pipeline, when we are processing it, when building the AI frameworks, when we are looking into the AI assistants and agent architectures, it is important to see that, what is that we could do to be able to, build an intelligent data platform, right? So, and I call it as a dark data in the age of, agents. Let me say that, why I'm calling it as a dark data. Enterprises have over years ingested a lot of data. We still have a lot of data. Every time when we look at it, we always look at a small machine learning model, which is a logistic regression model or forecasting model. I always look for a portion of the data, and then that is it. And I still have tons of data lying down in my data lakes and data warehouses. Nobody is really touching it. Now, when we come to the agentic systems, I mean, you build an assistant and you ask for a conversation, and the conversation can be any SQL which goes back and then look into your data lake. That could be any data which you never touched it, which you never looked at it. Is like the dark side of the world for your enterprise insights, right? So in the year of agents, the data warehouse, data lakes, and lake houses, so far so good. It's all batch one way or other. Of course, we have done a little bit of a real time in that, But when it comes to the agentic systems, you really need the data to be absolutely real time. If your agents are taking a specific action, that data needs to be fresh, that data needs to be clean, that data needs to be accurate to be able to give the right results in the agentic architecture. Hence, it is important to see how do we repivot the current way of doing the data platforms to a lot more intelligent the data platforms, right? How do I define the data infrastructure for new era of AI? I mean, we have been talking about many technologies, but having said that, I kind of, put in some options here to see, not that, we need to define a specific architecture, but we really need to see that how do we process the data in real time, how do we have an open architecture, how do we create frameworks, and what technologies are available is something that, which everyone needs to really need to look at it, right? For example, iceberg. Transforming the way we are looking at it. Do we really need any other a platform for you to query it, for you to look into it? It is very difficult to say today, but tomorrow the way it is happening, the iceberg, the kind of new features which is coming into the iceberg, you may not really require platforms like Snowflake, platforms like Databricks. Maybe you could use a compute and do many other things on open format tables and could able to achieve it, right? So that you are reducing the lot of layers in between when you are processing that. That's an idea of building a new way of looking into the data platforms, which is scalable, which is automated, which is intelligent. When I say intelligent, think about it. You connect to a source and you have a table. How about that table is all the way processing to your golden layer without anyone really looking into that, right? You don't even need to go to the metadata table and try to insert an entries. You don't need to, also need not need to look into that. That's the intelligent I'm talking about it, right? Now, the intelligent I'm talking about is that you really no need to deploy ML ops by creating the flows and then, the entire orchestration of it. Can it be created a framework so that you could run a model and automatically deploy on that? That's an intelligent way of looking at it. See, the idea is that do I need a 6 months, do I need a 1 year to really implement a specific project for AI purposes versus can it be done pretty quick in a few weeks time? Is the concept of intelligent data platforms, that's a thinking, something that, which we all need to look into that, right? And that's an idea of look at this. For example, you have a Flink, you have a Kafka, you have an iceberg, and you have a Finnote. You could create a great real-time a platform which is scalable, which you could do data science and AI parallelly along with the agentic architecture. Is a fantastic way of looking at it instead of having multiple layers of data products within your enterprise, right? Let me move on to the next slide, which is essentially how do you accelerate machine learning with the help of intelligent data platforms, right? We talk about a future engineering, we talk about the model deployments, but all of this really need your centralized data platform, which is real-time in nature and which can be looked at it, right? If you really see, a lot of action happens in and around building the MLOps ecosystem and AI platforms, but in the middle, which is your open data lake. What we call it as an open data lake is that once you have the data, you don't really need to create your own portion of the data marts or data stores. Every step of the life cycle of a AI product development or MLOps. That's what the fundamentally I'm looking to transform for all of us to think about it. What's a better way to build a MLOps platform on a new infrastructure which is a real time and which can solve many challenges in the industry, right? Now, similarly, look at rise of a generative AI. I mean, many things which needs to be done. If you see generative AI, a lot of development happens using agentic systems, a lot of development happens in supervision of those applications. You build a lot of intelligent applications, a lot of monitoring happens, but at the end actually you have to have a platform which is intelligent enough, which is a real time, which you could process quickly, and which can be scalable, which can be integrated with all kind of scenarios. Today everybody is talking about multiple protocols for the AI, which is important that in your platform should be able to connect and then to be able to deliver it, right? Now, you see AWS, Azure, GCP, everybody is having a lot of technologies. The point is that how do we build a platform which is nimble, simple, which is a real time for the AI use cases to be implemented. So that's the idea of seeing that how the AI is transforming the intelligent data platforms. With that, I wanted to talk about a couple of use cases, rather the implementations, what we have been seeing it. Customers are really thinking about it. Why this AI noise is so big, and it is a lot of pressure. Everybody thinks that by an enterprise is having a 20,000 reports, 30,000 reports, can I build an AI assistant? I can eliminate the entire reporting layer, right? How do I do that? Of course you could do it, provided if you have the right representation of your data platform, which can be processed, which can be looked at it. And in the industry, at the same time, if you see, over the years, terabytes of data lakes have existed, very large scale in every enterprise. All the machine learning, deep learning, neural network models have built on top of those data platforms. Now, when generative AI comes in, or AI assistants comes in, people are not using those platforms. You are having a separate thread of your own data stores, and then you are building a separate thread in achieving those real-time aspects of it. The question is, can we make those platforms a lot more intelligent so that you could look at it? So here on the first use case, it is all about on AWS and then the Snowflake. I think the trick is that you build an engineering framework using a Kafka and a Flink, and the idea is that it's a touchless. When I say touchless, you just need to configure the what tables you wanted to process and which layers you wanted to orchestrate. That is it. After that, the entire data engineering process will kick in, and you should be able to process the data using the the open source, the Flink and Kafka, and finally land in the Iceberg. And Iceberg is playing a very important role today. The moment the data is there in the Iceberg, you could process onto the Snowflake, or you could take it into the ML AI use cases without further taking the data into the next streams, right? That's an idea of creating a real-time way and using a open format tables, and then finally building the frameworks. If you see AWS also having the bedrock like any other ChatGPT kind of scenarios, but at the same time they are also building intelligent assistants. I think they build a queue business which is very useful for everybody to look at it. But at the same time you can talk about it in terms of how do I build a custom apps, bring in a lot more intelligence into that is a very important thing to look at it in that particular use case. Very, very advanced way of building it, but in this we only build a frameworks and engineering processes, but there is not any manual work. It's not like 50, 60 people coming and building the pipelines. It is a lot more intelligent to look at it. The second use case is very interesting. Think about it. If you were to process 20,000 orders per second, 500 million orders in a day, yet you wanted to track what is happening in the every 10 minutes, every 15 minutes. You have to have an alerting mechanism. Yeah, that is where the Pinot, Apache Pinot, which is a real-time use case, as in when you just bring the data here and you don't need to create any aggregations, right? And that's a one way of building the real-time use cases of implementing the low latency kind of a use cases. But at the same time, you also can push the data into the open formats so that your enterprise can start building the other AI and ML use cases, which is also important for the enterprise to look at it, right? So a lot of use cases are pretty real time, and anyone who is using agentic architecture, you have to have a real time data. You have to have a real time information to be able to successful. Otherwise, there is no between a RAG way of doing versus agentic way of doing it. Today, RAG is a batch. And the way we have done our data lakes, the way we have done our data warehouses, the way we have done all our machine learning models are all batch today. The only way to get to the agentic is with the help of a real time. That real time requires a different thinking, a different way of processing it. Earlier, we used to talk about, whenever we wanted to do a real time, always questions being asked is, hey, do we really need a real time? And based on that, you will take a lot of decisions, because real time is expensive, real time is difficult to do it, and you need a lot of infrastructure to do it. Today, it is not about do you really need a real time. Real time is the way to go for the generative AI kind of a use cases, and especially agentic way of doing specific use cases. Your platform needs to support it. And a lot of technology exists, and it is a mainstream today. And building intelligent data platform using some of these technologies will be very interesting to look at it. I thought I will share these two use cases about intelligent data platforms. So with that, I just wanted to conclude and take a few questions you might have. You need to talk a common language of your data. When I say common language, I have a S3 data lake, I have a Redshift, I have a Pinot, I have a few other systems. That's not a common language of your enterprise data. You should have a common language, which means that data is available, which you could able to look at it, and we should be able to see that how do you able to process it. Real-time engineering and AI frameworks, think about it, everything can be processed in real time. And you don't need to wait till the end of the day. Let the data comes in. If you really want AI use case to be up and running, you can transform it. There are a lot of many use cases which you could be looking at it. Of course, over the years, we spoke about a lot of replication tools. We spoke about Spark streaming. We spoke about Kafka. There are many other technologies exist today to be able to look into that, right? Of course, you could do a mini batches, which is the history. Now, those use cases are no longer really, a lot of people are using it, but that is not what you wanted to do when the AI is advancing so much that your data platform also needs to advance, and then the technology needs to be advanced and thinking needs to be advanced on that. And then finally, I'll talk about using the AI-powered data quality, AI-powered frameworks, in the sense that use as much of AI possible in building your frameworks, building your decode to be able to look at some of these the scenarios. The bottom line is this, right? You have to have an integrated governance which has the metadata, lineage, cost governance, as well as responsible AI principles to look at it. Now I will talk about a few of the scenarios, right? You have a Databricks platform. Can I do everything within Databricks, including LLMs, including agentic way of doing it, including the report, without going anything else? Of course, it is a possibility. Can I do a real-time streaming? Yes, it is a possible. It is all about how do we really need to architect your entire ecosystem so that you could able to see that how fungibility will be there, how tightly you could integrate in and around it, right? So a lot of customers are building the Gen AI use cases on Databricks. Same thing is happening on the Snowflake. Same thing is happening onto the other hyperscalers. But it is about how well you design your architecture so that it is real time. It can be processed pretty quick into that ecosystem, right? That's a pretty much what I wanted to share, but I'll take any questions you might have, happy to answer. Yeah, please.
Can we have the mic switched on, please? Just
Hello?
check. Yeah.
Hello.
Thank you.
So as we are talking about the lakehouse architecture, so we have option of iceberg and delta lake format. So as an organization, which one we should prefer, or what should be the selection criteria between iceberg and delta lake?
See, everyone is using iceberg in the sense that, you know, a lot of features being built up, and iceberg is a table format, right? Within your, you could still build your medallion architecture. Even in the gold layer, you could create iceberg tables. Since iceberg is coming up with a lot of new SQL engines, as well as a geospatial kind of the futures, and a lot of intelligence is building around it, I would suggest that, you know, probably that is a better way to look at it, because a lot of openness is there.
Okay, but delta lake is also an open format, right?
It is open format. It is built on the same ecosystem, but it's your choice on that.
Thanks for the wonderful presentation.
What about the space? Means because we have a large amount of data, then how we can store it in table format?
See, when you say large amount of data, at the end actually if you don't store in a stable format, it is only the external table, right? It is the storage layer you are putting it, right? Otherwise you will take it to one of these cloud data warehouses.
Yes, sir, please go ahead.
Thanks for the wonderful presentation, but it would really make sense if we are building a new data platform tomorrow morning. But the reality is, in large organizations, we have fractured data across systems which are not in sync. So keeping in mind that we need to put something in production in weeks, as you said, where should we start as a big organization which has been through multiple mergers and acquisitions, and where data is not in sync across all those systems?
So a very good question. Everybody modernized from the legacy onto the cloud very recently. You have a Teradata and then you took it to Databricks or a Snowflake. Nothing has changed. And everybody is thinking about, let me migrate and then I will do modernization, right? That event never came through, right? So the point which I am trying to say is that, you know, if you redefine your architecture for a modernization, slowly if you get onto the path of transforming it, that will be a very good decision to change. Otherwise, you won't be able to implement any of the use cases. If you are thinking about using AI, you definitely need to transform. You definitely start thinking about real time. Otherwise, I could still think about the traditional way of doing a machine learning and deep learning, which is a batch, which we have been doing it for years. We'll continue to do that, but we will never be able to adapt to the the advancements and innovation is happening into the AI. I'm not saying that everybody needs to change, but if your use cases are such that you really need to think absolutely real time and better way of processing the data.
Please go ahead.
So you said like iceberg, we can say it as tables, right? So we have a large set of data in Oracle database. So it can be an alternative. It will support ACID rules and similar to Oracle database. For a higher scale, we can use it. for OLTP?
See, there is a huge difference between a data analytical platform versus your OLTP systems, right? Concurrency is important, and you have many other features which is required for you to look at it. I wouldn't suggest that for your OLTPs you straight get to the open format, while open format has a pretty good way of doing the ACID transactions, but it is not really comparable to your OLTPs like Oracle. For example, in Iceberg, right, you could delete it. It's a soft delete. Yeah, not necessarily that again you need to run another process to clean up some of these the processes which you have done, right? So hence, for OLTP, you really need to keep it outside of some of these analytical way of doing the scenarios.
Thank you. Thank you.
Anyone else with a question? There's a gentleman all the way at the back, and there's a lady up front, please.
Yeah, please.
We'll start with the gentleman at the back. Please go ahead.
In the world of AI agent and agentic AI,
could you lift your mic up, please?
Okay. In the world of, am I audible? Yeah. In the world of agentic AI and AI agents, how important do you think MCP comes into picture? I mean, do you think every organization needs to follow it, or is it dependent on use cases?
I would say is that it's a framework, right? MCP is a framework, and people have used A2A protocols as well, right? Google's protocols as well, right? Agent to agent protocols. The point is, if you have a framework, you have a consistent way of doing it, versus if everybody is trying to connect and if everybody is trying to do differently, then there is no consistency within the ecosystem. So it is very important if you follow a specific framework, and MCP is a good way of looking at it. For example, I was using that Anthrop as build MCP framework for the Pinot. Otherwise, Pinot generally is a low latency query engine. We always think that you need to bring the data from the Apache Pinots onto somewhere else and start doing the data science models. With this MCP framework, you could able to achieve pretty convincingly. So it is good to adopt, and it is good for the enterprises to follow a specific standards.
Thank you for that. The lady up front, there we go.
You keep telling that if for agentic AIs, we need to have real-time data, but most of the organizations have the lowest granularity of the data at a daily level. How do we adapt this kind of an intelligent data platform for a daily granularity data?
So at the end, actually, what is your use case? If your use case is to look into 5 minutes, 10 minutes kind of a scenarios, you have to have a real time. Otherwise, it will be very difficult to look at it, right? Now, you have a RAG. You can use RAG as also agentic RAG. There is a different way of doing it. If you really don't need a real-time data, you could still build agentic architecture using RAG way of doing, still a batch process way of doing it, right? For example, you can ask a question that if you are a retailer, you could ask, or a CPG, you could ask a question. In that question that why my specific product sales is not great, and the agent will come back, RAG agent will come back and then give you all kind of scenarios. But if you wanted to really implement and some pricing decision changes in your pricing systems, you really need a real-time data. But if your questions and then agentic way of responding, it is still a batch kind of a thing, you could use a RAG agentic way of doing it. So it's all depends on your use case. But my point of saying real-time is that sooner or later, the level of advancement in AI is going to increase, and your data platform should have a capability to bring in the real-time data, which will be very helpful for processing it and taking actions and decisions in and around that.
Thank you very much. Can we hear a big round of applause for our speaker, please? That is our time for question and answers. Thank you very much. In the interest of time, we're going to jump into the next introduction very quickly. It's time for us to talk about building a future-ready data foundation, one that doesn't just support Gen AI, but accelerates it, bringing together engineering strength from Sigmoid and real-world Gen AI transformation from Kenvue. Our next speakers have co-created a fair-aligned data marketplace that's already driving impact. People of the audience, we're going to welcome them to the stage. Your job is to clap for them. Please welcome from Sigmoid, Mausami Kar and Shalvi Kapiswe from Kenvue with a big round of applause.
Good afternoon, everyone. I hope I'm audible to everyone. Is it audible? Okay, thank you. Welcome to today's session on preparing your data foundation for generative AI. We are standing at a pivotal moment where Gen AI is no longer a futuristic concept. In fact, there are companies who have adapted it into the way they create, they automate, and they innovate. But here is a reality check for all of us. AI is as good as the data it learns from. In today's presentation, we will try to walk you through, with one of our partners, how we build a strong data foundation for them to turn the AI from hype into a real enterprise value. I have Shalvi with me. She is Principal Solution Architect at Kenvue GCC India, where she leads some of the data and analytics initiatives, very business focused, and she is very good at it.
Thank you, Maushmi. She is Maushmi, Director of Data Engineering at Sigmoid and our trusted partner for building data solutions. We'll get started.
Shalvi, does your business often face this problem with the data science teams where they spend a quality amount of time in figuring out where the right data is and at what place?
Almost always.
I'm not surprised. 25% of the time every engineer or every analytics person spend is to figure out where the data is. And when they actually find the data, do they actually get the value out of it?
Do organizations even generate or track the ROI on data? Is that a true use case?
Like you, there are a lot of leaders. Only 33% of the stat says that the leaders are able to connect the value of the data which they bring onto the table with the ROI. That brings us to the introduction with today's session.
Right, so we saw the common data problems which are faced by organizations, right? We will talk about our step towards solving those through a strong data product strategy. We will go over the data product execution framework which we have, and the key highlight for the day is going to be a demo on the data product marketplace, which is Gen AI enabled. All right, so traditionally, we have always seen data as a utility, right? But now there is a shift in the way we think of data, and it is more of an asset on which we can monetize on, right? Imagine going to a well and fetching a bucket of water. Before you can use it, you have to filter it, clean it, probably boil it, and then it becomes usable. In the contrast, data as a product is something which is trustworthy, ready to consume. Consider a packaged drinking water bottle which you get, right? It is clean, curated. We have a clear ownership defined on the data and then governed. So this is probably a shift which we are talking about today, and we will go into a details where data is used for solving business problems. Move on. Let's talk about how a data product organization operates. So everything funnels down and starts from defining your business priorities and needs. Once we know that, whether it is revenue growth management or improving your customer relationships and experiences, we define that, what it is. And then we start defining our data strategy. We build domain-specific foundational data product, right? Once that is done, every time we shift from left to right, that's where we add more business context to the data. We make it more meaningful and ready to use and to be consumed by the data science and analytical partners, right? One thing which I want to highlight over here, the way we traditionally operated, especially the data teams, it was mostly from the back end. The data teams did not know how, when, where the data is being used. This is a very broad shift right now, where the data products team work in collaboration with the business, and then they design and define their data products, right? And of course, all of these are done in tandem with our data science and AI partners. With this, we will move on to the next one and double click how have we done this.
The problem statement starts with understanding what the data quality is in place. So we started the engagement with understanding where the data currently resides, whether it is the external data sources we are dealing with, whether it is the internal one, what is the granularity, what is the completeness, the accuracy of the data we are talking in here. Once that assessment has been done and a governance framework is put in place, we moved to the curated data layer where it was more domain focused. We wanted to give the data layer to the product teams, the customer teams, the supply team, who can then nurture into it and find out the analysis they are looking for. Something like a sales visibility, a finance 360. Then we moved into the integrated data because the teams wanted to understand what the other team is dealing with. Cross collaboration between the domains is very critical for a complete use case on the analytics side. So the revenue growth management cannot happen in silo. It has to be a collaboration between the domains. Similar thing is on the retail execution. So we built that layer for the teams who are very focused on the analytic. The question answered in here is what is happening. The enriched data set in here is for the data science and analytics team who wanted to use a curated data model which can then answer their why question and what next. So something like forecasting, predictive modeling, price elasticity, all of that was answered through this. The whole model was governed with the framework where we had the quality index defined as per the CanView standards. Now, in all of this process, we didn't throw genetic AI at everything we worked on. We were very selective on what to automate, where to spend it on the infrastructure for generative AI, and how to build the entire process. Once we were done with this one, the major challenge for us was how to make it visible to the enterprise. And that's where we built the data product marketplace, where not only the teams can discover, access, but can also have a self-service and publishing facility. So as and when they come up and build more use cases, they can use this platform to make it visible to others.
Okay, so we spoke about what our strategy looks like, right? Now let us talk about the use case, right? The execution framework, taking an example of customer 360. So for any CPG organization, driving retail executional excellence is the key, right? Under that, we define what are our business priorities. That is the step number one, where under the physical availability and perfect store umbrella, we ensure the physical availability of product on the shelves in the store, right? That is, say, one business priority. Second is your total distribution point improvements. And then in case of online sales, we also have digital shelf compliance and availability of the product, right? Once these are defined, we go towards defining the data strategy, right? That's where we were talking about in the previous slide, that it happens hand in hand with business, right? So the data strategy here, we at CanView start defining the key data elements which are used to build all of these. So if I take an example of on-shelf availability, right? To go and predict whether a product can go out of stock from the store or the shelf, the very first thing in terms of key data element which we might require is your sell-in information, your inventory data, product attributes, retail scan images, and so on. Once we have all of those defined, for any data product, we finalize what our governance strategy should look like. What is the accuracy of the data which is required? What is the minimum coverage criteria which we have. Once the data strategy is built, that becomes the blueprint for building the data products, right? I'll not go in depth of how do we do data products. I think all of us do it. Just a key call out over here is building a common data model or semantic, which is key for us to scale it across geographies, right? It reduces our time to market and it makes it faster. So that is one of the key call out over there. And then of course, in the previous sessions also we heard about the importance of tagging your data, capturing your metadata, lineage of the data. So all of these are done, and then the data is democratized and made accessible to the entire organization who needs it through data product marketplace. We'll go there soon. And of course, it becomes usable by the data science and the analytics team during the course. One key thing again over here which we follow at Kenvue is the activation strategy. We have a very strong activation strategy for any of the product which we build, whether it is data or AI or any solution, right? This ensures that whatever we have built is actually deployed in the retailers and in the stores, and then we start tracking the return on investment, right? What have we investment and what return it is giving us. It ties back to our business priority in terms of numbers and green dollars. So this is how this looks like. We can go into the demo.
I think let's move to the demo section as well, right?
So the entire concept of data product marketplace, right? We spoke about, just log in.
Yeah.
All right, so we spoke about, the problem statement in the beginning, where data discovery was an issue, right? We build the data, but we do not know where to find the data. That was the key problem which every organization faces. And for that, we had this vision of building data product marketplace. We partnered with Sigmoid where they helped us to build this end-to-end, right? And not just the data product marketplace, even defining our data, right? The basic data foundation which is required even to have a product like this. So let's get into the demo.
So any new user or a repeated user has to go through the single sign-on. If you are a new user, we collect the information related to your demographics, where you are logging for, what persona you belong to, what designation you are, what is your org hierarchy looks like. We collect all of that information, but for a repeated user, we already have that metadata with us. This is the landing page for everybody who logs into the marketplace, whether you are from the product side, the customer side, or the consumer side. I will take the demo for the customer domain. Now, this product was not built with the only vision of serving the data and analytics team. When we went for the requirement gathering of this one, we spoke to a lot of end users, the business users who are actually going to use that. We just don't want to build another platform which is sitting onto the server and nobody else is using it. So all the discussions of what they want to look into is accumulated into this. When you log into this one, we first give you a highlight of what the domain is, who are the owners of the domain, what is the quality score, which are the regions it has been made live into. And you can see the screen has been divided into two parts. There is a derived data products, and there are the foundational data products. These are the foundational ones are the one which is like your audit data, your syndicate data, the hierarchies which the company has defined, both global and regional. Based on this data, we created the derived data products which are used by either the analytics team or the data science team. If you see into the global perfect store, you see a green batch. You can see the green batch. It has a threshold of what the quality index is, and based on that, the batch turns to amber or red if the quality of the data is not trustworthy. In the bottom section, you can see some icons. The first icon tells you if you want to make this style your favorite, so that the next time you log in, this is where you land in first. You can see the next one, which tells you the quality index of the Power BI report, which we publish across the tables which has been used for the derived and the foundational data set. Every column, what is the score, which is the region which is scoring less, all the reports are displayed. The next tab will give you a report on where the Global Perfect Store KPIs has been used by any of the teams in reporting or insight generation. The fourth style is that of a catalog. You click on it, you go to the Alation website where you can know the details of the whole data set, the ownership, the granularity, the quality checks, how the columns are related to each other, everything. The last but one is where you can raise your request. It will connect you to the Snowflake database where you can go play around with the table, the version available for you to play. And then the last one is a self-service, which will take you to a Power BI dashboard where you have the curated data set available for Global Perfect Store to drag, drop, and do your own analysis on the fly. If you dig into the Global Perfect Store...
Just a disclaimer, sorry Moshmi. So the numbers what you see here is just for demo purpose and does not represent Kenvue's data. So we can move on.
Thank you. All right, so these are the KPIs which are very specific to Perfect Store. And the person who is dealing with it will be working on these KPIs as they work. The following sections has been divided into where you have the year-over-year analysis done. And the next section tells you some of the business questions which are directly related to the KPIs in here. So if we have some predefined questions which business generally wants to know about. This is a pre-curated analytical data which we went to the business users and collected that when they want to see Perfect Store data, what are the common questions which they have to answer. Based on that, we have curated the list. It is not interactive. It's a one-time load. You can see the questions they generally deal with. The next is a hotspot. It will give you the relationship between the different metrics like OSA compliance, on-shelf availability. When you change the filters, how does the numbers change and how does it impact to each other? The third one is a lineage. Every business user wants to know the source from which the data they are seeing is coming from. So we have created the lineage from the bottom, from the source systems, till the end users, where it is flowing in and where they have joined, what are the changes and interactions it has been doing. The fourth slide is cognitive insights. These are something which the org generally deals with. It is published on the org, but we have curated it in one place, which is very specific to Global Perfect Store. So anybody who is interested to know what is the org looking like from the product side onto the KPI side, they come into it and they can have their cognitive insights. They can read more about it. They can do more research, whatever is published in here. The last style is smart search. Now, traditionally, we have been very familiar with search in instance, where generally it is to search a table, a column, or some of the entities in here. What we have done in here is the use of LLM models, where you ask the question in natural language, in plain English, and it has a master LLM model, which is then broken down into SLM models. They have agentic AIs in here, where the query is then broken down into pieces, and it is assembled by the master LLM and returned to you. So let's say you have a question like, what are my top 5 retailers based on the OSA compliance for August 2024? It will not only show you the numbers, will also give you a graph, which you can then readily use and place it into your presentations. You can ask further questions to it. For demo purpose, we have restricted it to this, but you can go deep, and this is where your data starts talking. We don't want just the data lake to be sitting there. We want the data to be interactive. As we are speaking, we are doing more feature enhancement into it by talking to the business users, how they are using. So it's a self-learning in here, where it understands the query which the users are putting in, and it is trying to do advanced search by itself. Shalvi, would you like to show one of the case studies which we are working on?
Sure. So this tool, right, we have, once it was built, we introduced it to multiple personas within the organization, right? It is definitely built keeping in mind technical as well as non-technical users, business users, so that they can come and then if they have any requirement of understanding any data, we could not show you a lot of features right now, but what Moshmi was talking about, if you click on these, right, it is actually going to take you to an Alation catalog where the entire data is cataloged for you to self-service it later, right? So all of those features are available over there. one of the use case which I want to talk about, right? It is one of the AI use case, which is on-shelf availability, which we had built for North America first, right? So basically what it does is it predicts whether any of your product is going to go out of stock from a store or from the shelf, right? So this was something which we deployed for multiple retailers in North America region. Once it was done over there, the business across multiple geographies heard about it and they were interested to even build. This is of course a global data product, and they reached out to us. So once they decide that they want to go ahead with this, the very first thing which we have to do is a data sufficiency test, right? Whether you have the right data within your region to even go ahead and build it, or there's something which you need to procure first before you think about it. So this is the page where they usually land up. They say where is it live, and they can get into again details, the use case report, which again redirects you to the analytical use case as well. And when they click on the data metrics, they know what exactly do they require to implement an OSA solution, right? What granularity of data is required. There are a lot of other informations in terms of history, the exact column which is required, and then we also maintain must to have and good to have kind of columns which they can go ahead and take a look at. So with all of these, I think the amount of time they take to come to a data engineer for checking on their data queries, that is drastically reduced. And it was difficult initially, I will tell you, because there is a way in which the entire organization is used to communicate and gather the information. So it required a lot of effort to kind of push this across. We conducted multiple office hours for adoption and so on. Once it is now in flight and people are using it, we have also implemented a Google Analytics to track the consumption of this. So yes, I think with this I would like to conclude the session for today. And the food for thought is, right, data product strategy is a must. It's no more an option if you are looking to build, and enable your AI and Gen AI journey. So with this, I will open the floor for questions.
Once again, just put your hand up. We have the gentleman in the middle there. Can we have a mic go to him, please? Anyone else with a question? Please go ahead.
Hello, can you hear me? Hi, my name is Paul. I'm from Fidelity Investments. I want to know how was this journey? How difficult was it to get into data product mindset, and what were the biggest hurdles for you to overcome? I know everyone wants to do it, but not that happens all the time. So I wanted to know how was it for you, for your company's journey?
It was difficult, right? And I think it is an ongoing journey, I would say. It started, maybe the battles were fought long back, and we at Kenview GCC, it is just 1.5 years old, right? So I think the time when we joined, at least we did not see a lot of pushback. There were a couple of it because there were a lot of regional teams trying to do the same thing, and getting into that product mindset required a lot of education, lot of successful deployments, lot of ROI tracking, which we did. And once we were able to generate the value in last 1 year, I see it getting easier day by day.
Thank you.
Any more questions?
So one question, are you tracking how effectively these data products are being used internally by your organization? And have you been able to quantify any kind of like ROI? Like, because like, earlier, it used to take so much time in order to find what data we have. But right now, we just go to this catalog kind of thing and find it very easily.
So I'll answer it in two parts, and Maushmi, please feel free to add. So on quantifying the ROI, right? So as I told you initially, that all the data products what we build is associated to a solution. And we have a very strong activation strategy where we go and deploy all of these in the retailers, right? We have ways of tracking over there that what is the ROI which we are getting in terms of, you know, whether it's your total distribution point improvement or say recovery of lost sales in terms of OSA, right? So that's how we kind of see what is the ROI. On the data product marketplace,
Yeah.
would you answer?
So on the, once we launched this, we also had Google Analytics built on top of it. We just wanted to understand what are the personas which are using it, what is the time they are spending on the site, what is their tracking in the journey is, and what is the next outcome which we are getting from that business who has spent a considerable amount of time on the website. The time we tracked on the ideation to the execution has you know, reduced significantly. So the number of use cases which the business were previously able to work, let's say in a quarter, 1 or 2, that has increased, where they are spending more time into doing something which is going to affect business directly, rather than spending time on finding out where will I get my data from.
Are there any other questions? I take that as a no. Can we give them a big round of applause, please?
Thank you.
Thank you.
Thanks.
Thank you all very much. That was an interesting presentation. We're going to move on to the next conversation that's about to happen on this stage. Seems like a few of y'all are leaving. Not too sure if the tea break is on as of yet, but we shall find out. Maybe you should tell me once you go out. Give me a thumbs up if the tea break is up. Okay, so everyone's good, everyone's okay. Just give me a thumbs up if yes. Yeah, give me a thumbs down if no. Looking for some hands to go up with a thumbs down. Anyone? Anyone? No? Okay, maybe y'all are still shy. We shall work on this. It's time for us to go into the next speaker who's going to be taking stage. We have with us someone who's going to shift gears to a real-time analytics, the kind that operates in milliseconds and keeps pace with the most demanding user experiences. At ClickHouse, performance isn't just a metric, it is a mindset. And leading that charge is this man. His name is Rakesh Puttaswamy. He is the principal solutions architect who's helping companies unlock the full potential of lightning-fast analytics. He is currently side of stage. You're good to go? Yes? Okay, we're going to get him a minute to get mic'd. Yes? All right. And we're going to bring him onto this stage. Before we do, just a quick reminder. As of now, the entire lobby is completely blocked. Can you hear people screaming? Apparently, there's some game going on and people are winning a bunch of prizes, and so that whole place is blocked. So I suggest you just sit in your seats. But do check out the AIM stall. They have a bunch of other events that's happening throughout today and throughout tomorrow. A bunch of prizes to be won there as well. Also, make sure you walk and check out the different people displaying outside. Make sure you head out, have conversations with people, network as much as possible. And that is it from me. I'm going to look to you once again, sir, while you get mic'd up. I don't know what else to say, so I'll just look at your faces for a while. Hello. Everyone's good, yes? Do you have any questions so far, so I can probably try and answer them? You want more beatboxing? I think, okay, so I think the person who asked for beatboxing, was it you? You, okay. I think your request is being answered, but anything else apart from that? Anyone else? Anything else? No? No other questions so far? I don't know when tea or coffee is being served, so that cannot be asked to me right now. I'm still waiting for that gentleman to say, haha, or haha. No? No other questions, so just beatboxing? Yeah? Okay. So, I'm going to teach you some more beatboxing skills. And you've seen a drum kit. Everyone's seen a drum kit on stage? Yes? If you've seen a drum kit, then you've seen the kick on the floor. There's a big drum on the floor that we call that the kick drum. So basically, the kick drum, you play it with your foot. So you go like that, right? And when you go like that, it makes a sound. To get that sound, you have to say the word two. Can everyone say two, like the word two? Two, very nice. Now when you say two, you forget that you're saying the word. Instead, you make the sound. You go, yeah? It's relatively simple if you keep trying it. If you keep practicing it, just, yeah. With a little bit of practice, it starts sounding like a proper kick. It starts sounding like this. Little bit of practice, okay? The second sound are the plate-like things on the side. They're the hi-hats. They sound like this. Can you all try? Very nice. The third sound is the snare in the middle. It sounds like you're clicking. You're going click. Lots of practice there. Very nice. That was the third sound. What was the first sound? Very nice. Was the first sound. The second sound was. Third sound was. Very nice. You put three sounds together, you get a and a. I do it slightly different. I do a and I put three sounds together, you get a. And that's how I learned how to beatbox, using these words, sounds, and syllables, and I sort of started putting them together. And then I started doing a little bit more. Okay, I'm going to teach you a different version of this. The kick, can also sound like this, which is a lot more fun. Basically, I'm saying burr. Can you all say burr? Now, when you say burr, you forget that you're saying the word. So you're not saying burr anymore. You're making the same sort of action with your lips. So you're just going burr, but not saying the word. You're just going. Don't laugh at me. I make money with this, okay? Okay. Yeah, so you're saying, or you can also say purr, like P-U-H or B-U-H, purr. And you're not saying purr anymore, you're just going. So that's all I'm doing. And on the mic with the beatbox setting, it sounds like this. And then you go, and then you add a, and you put them together, you just go. No. Yeah? Thank you. Does it seem simple? Does it seem difficult? How many of you think it's difficult? Hands up in the air. It's still difficult. Oh, no. How many of you think it's easy if you practice? Hands up in the air. Oh, y'all are lost causes. Okay, another little thing. Let me teach you something very, very simple. Can you say boot, like boot? This. Cut. This. Boot this, cut this. Okay? Now, keep in mind, every time you're saying these words, forget that you're using your voice. Forget that you're using your voice. You're just making the sounds. So you're going boot, this, cut. So the cut is a k. Try it. There. Cut, this. And then you start stitching it together until it sounds like a beatbox. So you're going boot, this, this, this. Simple enough or no? Boot, this. And then you forget saying the words all together. It'll start sounding like this. This. I'm not saying those words anymore. It's just the sounds coming out. You think you're hearing the word, but you're not. This. Or simpler, you can just say boots and cuts. Can you say boots and cuts? Now forget the and. Just say boots, cuts. Yeah? So the person who just did it, it sounded like a female voice. I don't know if it was yours. It's exactly that. It's boots, cuts, boots, cuts, boots, cuts, boots, cuts, boots, cuts, boots, cuts. And that's how you learn how to beatbox, using all of these words, and you put them together in these stupid noises. Yeah? I'm desperately looking towards the right of my stage, hoping they'll say, but there's no so you have to deal with me for a little while longer. Is that okay? Yeah? So I started off back in 2007 and 8, where I needed to make money, and I was playing the guitar and singing, and I couldn't make money as a musician, and so I picked up the mic as an MC. But I got a little sad because I was just hosting events and there was no music, there was no fun. It was, oh, welcome to the stage. And everyone goes, ha, 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 marvelous, darling. And then beatboxing kicked in because it was a little bit of fun. It was a little bit of music, and I started practicing. So by 2008, I started making these sounds. But since I could sing, I would do stuff like this on stage. I'd go, my dream is to fly over the rainbow. One person knows this song. My dream is to fly over the rainbow. So high is what you're supposed to say. Do you not know this song? No? Oh my gosh. Okay. My dream is to fly over the rainbow. I gave you the words, damn it. So high, I wanna. Yep. Thank you all. Yes, okay, we're good to go. It's time for us to introduce the next speaker on stage. I already have. I shall quickly do it once again. We're here introducing the gentleman from ClickHouse. Keep in mind, I said before, performance isn't just a metric for them. It's a mindset. And leading that charge is this man who's going to come up on stage. Please welcome the man himself, Rakesh Puttaswamy, Principal Solutions Architect, with a massive round of applause. Come on.
Thanks for the intro. Hi guys, very good evening. How was the sessions? I think look pretty tired. It's already 4, just 1 hour to go. I looked at the agenda and it was pretty amazing. Looking at all the data engineers, data scientists, data engineering leaders in the same place, talking about a lot of data stuff. Amazing. Yeah, without a delay, let's kick start. My name is Rakesh. I'm part of ClickHouse solution engineering team. I lead solution engineering in India for ClickHouse. Been in the data and data space for more than 13 years now. Worked with most of the databases and data spaces in the past. We'll talk about ClickHouse in detail today. A lot of you guys came to our booth and was asking about what is ClickHouse, etc., right? So the takeaway from this session would be to understand what is ClickHouse, where does it fit, and what are the architectural patterns where you can use it, etc., right? So I would keep the agenda in that way. And if you have any questions, I would park that Q&A during, you can come down to our booth and we are happy to assist. We have our team there. We'll take it forward from there, right? With this, a little bit history about ClickHouse before I jump in and talk about what is ClickHouse and what does it do, where does it fit, etc. I think most of your company has already started using ClickHouse. I saw a lot of your company organizations, etc. So we know that your companies are already using ClickHouse, whether it would be open source or ClickHouse Cloud or any other offerings. We'll talk about that as well. Just talking about the history, ClickHouse is there from quite a long time, I would say. Started with 2008, 2009 with our founder, Alexei. Started this database product. He realized that the data, the click stream, the warehouse was not there back in the 2008-9 time frames. It was all people were using Oracle, SQL Server, and other items. So the word ClickHouse comes from the keyword clickstream data warehouse, right? That is when Alexei decided to build, we need to have a data warehouse at that point in time, and the journey started from there. So 2012, we went into production, and 2016, we licenses in Apache. And 2021 is when we incorporated as a company ClickHouse Inc. In this last 4 years, the engineering effort and the integrations and the engine itself has enormously grown, and I'll talk about some of the features and functionality about that as well, right? So if you see ClickHouse now, there are very less number of databases now, especially handling analytical space. I would say it's the #1 analytical database on DB engines and over 39,000 GitHub stars, which is amazing. We are almost touching to Apache Spark. Very soon we are going to cross that, and over 200K of community users. Just a quick background about ClickHouse and the history. Talking about what is ClickHouse, right? So think of ClickHouse as a pure play analytical database. It's a SQL distributed database, comes with the purpose-built operation for handling a huge amount of data with blazing fast analytical capability with scale. That is important. A lot of databases can do analytics, they can run aggregations, but when it comes to volume of data, handling terabytes and petabytes of data, that is when ClickHouse comes into picture and serves for the purpose. So there are 3-4 main components I would consider when you're talking about ClickHouse, right? So it's a SQL database, as I said, distributed SQL, processing the data very fast. We store the data in a very highly compressed and encoded format, very efficient algorithms to reduce your overall TCO of the storage, right? And easily scalable to any size. It's massively auto-scalable. You can scale up and down very easily, seamlessly, scalable, right? So this overall together makes some important features of ClickHouse. And also, just to summarize now, right? So ClickHouse being an analytical database, now it has evolved, as I said, in last 4 years. It has evolved in such a way that it's no more just an analytical relational SQL database. It has gone beyond, above and beyond. So we have become now a unified data platform to analyze the data and also to contextualize the data. When I say unified data platform, you can stream the data, you can load the data, structured, semi-structured, unstructured data, horizontally scalable, distributed SQL, real-time processing. Very less databases does real-time analytics, and we'll talk about some of the architectural patterns as well. When you say analyze, so we are, again, ClickHouse is a columnar database, very well efficiently built to handle a very large amount of aggregations. And if you have a requirement of ingesting millions and billions of records, then we have something called click pipes, which makes your applications more data intensive and much more real time, right? And built for low latency and high concurrency. And now we are all talking about AI and generative AI, agentic workflows, etc. So a lot of engineering efforts and investment has been gone into contextualization of the data, meaning you can have agentic workflows with ClickHouse. You can store the vectors within ClickHouse database used for semantic search, hybrid search, and also you can use it as an offline feature store, right? So as I said, very easily used for processing SQL, JSON, which is semi-structured, time series, and other formats of the data. So it's more of a multi-model where you can store all type of data in one single platform, which is amazing. So building on ClickHouse, so we are seeing 2 patterns here, right? So what is ClickHouse used for? Where does it fit, right? So it is very good for 2 cases. One, if you are using ClickHouse as a primary data store, meaning you have a new projects, and let's say if you have a sensor data, telco data, or any data which needs to be analyzed and used primarily for that, then you can use ClickHouse for that. Absolutely absolutely fit for that. And a lot of customers are also using ClickHouse as an analytics layer, right? So that is where the USP comes into picture. So if you have any relational databases, everybody uses relational databases, transactional databases, Postgres, MySQL, you name it, right, Oracle. But at scale, you will not be able to do analytics. So you will have to move the data to some data warehouse or other analytical platform to get the real-time insights. You can do that with a lot of other products, but getting a real-time insights is a challenge. That is where ClickHouse comes and solves. Data lakes, easy integration with data lakes, Iceberg, S3, Delta, and open table formats very easily doable, right? So we have a lot of table engines which can directly get connected to other databases and pull the data into the system and start querying that. So two types of medians, I would say, where ClickHouse fits very well. Coming to use cases, so a lot of people ask this question, right? So what are the different use cases, where I can leverage ClickHouse into? There are 4 important verticals we categorize it. One is primarily the main is real-time analytics, where you power your application. It could be your generative AI applications, it could be your native applications, used for very large amount of data, aggregating it. As soon as, when we say real-time analytics, the term, right? So the meaning is, as soon as the data comes from any data source, it has to be available in a real time. As soon as it gets committed, it has to be available. A lot of databases suffers that, because even though it is distributed, there is a rebalancing, reshuffling, a lot of things has to happen before the commit will take place, right? So we have a little bit uniquely architected in that way, so that you get a better time to insight when you start querying the data. So business intelligence again is extended unit of real-time analytics, I would say. Lot of your applications get connected to Power BI, Tableau, and other business intelligence tools. So when you say your dashboard is slow, actually your dashboard is not slow, your database is slow. That means your queries underneath is not performing well, right? So that is where ClickHouse comes into picture, where you can do a lot of modifications for different query patterns and get the faster insights on your data warehouse or business intelligence tools to serve for both internal and external customers. Logs, events, and traces, one of the important vertical in ClickHouse for observability. So you can monitor, stream the metrics, traces, etc., detect the anomalies, fraud, any issues out there, and easily monitor it and take actions out of it, right? So how fast you take actions of it is very important. Your applications or your organization cannot wait when you detect an anomaly and to take an action on top of it, right? So while the data is flowing in, you will have to identify if there is an anomalies or anything happening in your system and immediately take actions. That is where ClickHouse is also, a lot of our customers are using it. I'll also show some of our customer case studies as well. Machine learning and generative AI, again, it's a lot of investment is going on, as I said. We are now getting vector search into GA very soon, probably in a couple of months, where you can store, where you can use any LLMs, chunk your data, put it in a vectors, and then start doing a hybrid search, right? Contextualize, use vector indexes. It could be cosine or Euclidean distance, nearest neighbor match, and all of those things. So very efficient. And DeepSeek, by the way, everybody knows DeepSeek, so uses ClickHouse as a vector store behind the scenes, and they have announced this in public as well. Some of the logos you can see, just some of the big logos who use us with respect to that particular verticals of ClickHouse. Good. ClickHouse cloud architecture. So before getting into that, there are 3 main offerings with ClickHouse. ClickHouse is open source SQL distributed database. You all know that now. ClickHouse cloud architecture is slightly different. And this we started with 2021, as I said in my initial slide. We have divided, ClickHouse has been now divided to cater the data into separation of compute and storage, right? So when you start ingesting the data, all your data will be backed by object storage. Virtually, you really don't have to shard your data. It's a single unlimited sharded system, right? So it's a limitless database for you. And with that, you have another layer which is compute. It's all Kubernetes-based pods. You have multiple nodes around it. When you start querying the data, based on your query patterns, the data will be pre-warmed and stored in this multi-layer cache. So this becomes your faster access of the data, right? So there are multiple caching layer here. I'm talking about file system caches, uses fast SSDs here. There are a lot of other caches which you can use it to pre-warm the data and use it. And you can always use your object store data for your historical needs and etc. The beauty is now when you start writing the queries, right? So the application writes the query, it gets into load balancer, it goes to different nodes and fetch the data if the data is already available in your cache. If the data is not available in your cache, it goes into object store, prefetches the data into cache and keeps that into your as a hot layer and serve the data immediately into the clients. And you have an admin console which typically takes care of monitoring, backups, billings, and other things, right? So this is a very high-level ClickHouse cloud architecture, and it's slightly different from what open source architecture is. And there are a lot of things inside compute and object store, how we store the data, how we compress the data, how we encode the data, and how we decompress the data. That is where all the uniqueness comes into picture when compared to any other. You might have seen a lot of other databases saying separation of compute and storage, etc., right? So, but how efficiently you store the data and how efficiently you retrieve the data is very, very important. With ClickHouse, you get almost 10x compression. That means if you have 1 terabyte of data, you probably just end up storing 100 GB of data in your object store. Yep, this is the main concept of ClickHouse cloud architecture, shared merge tree design, meaning the compute nodes and the object storage has a connection with ClickHouse Keeper where it will keep all the metadata information in ClickHouse Keeper. It knows which node has which data so that it goes and particularly picks up that particular amount of data and gives it back into the system. Virtually, object store has unlimited storage, gives you very high insert throughput, and the merges and mutations will be very, very efficient in shared merge tree. And this is not there in the open source. And this is the main differentiation actually. So the replicated merge tree, if you know about ClickHouse in open source, is replaced with ClickHouse cloud architecture by shared merge tree design. Yep, traditional architecture, data architecture, you might have all seen this, used this, and done some work with this. A lot of complexity here, a lot of data sources. It could be data coming from other databases, applications, servers and devices, etc. There could be 2 methods only you could stream, right? One could be either streaming and other could be batching. Streaming could be Kafka, batching could be anything like, use Talent, Informatica, etc. and put that data into Lakehouse. And Lakehouse also comes into a lot of tools and techniques. Probably you might use Hadoop or any object store like S3, blob storage, etc. and do some transformation. So a lot of things happening in the Lakehouse. That is where a lot of time has been consumed, moving of the data is happening. So the time to insight is more when using this traditional style of data architecture. And finally, you have to move to any data warehouse or analytical system to visualize that data, access that data patterns. With ClickHouse, what we do is we simplify this architecture, reduces the system bloat, and increases the resource efficiency, right? Now, if you see ClickHouse being in the middle, the streaming layer always will be there and batching layer will always be there. We need some tooling to stream the data into system. That will be done either through Kafka or any other mechanism. But in the real-time data warehouse where ClickHouse sits, so you can do all of these 4 use cases in single platform. There's no data movement from, let's say, S3 to a transformation layer and then to databases like ClickHouse, Snowflake, and or BigQuery, Redshift, etc. And we also have a great integrations with data lakes. You can directly get connected to Iceberg, Delta Lakes, read the Parquet files directly from S3. A lot of integrations are directly available. There are a lot of table engines where you can directly fetch the data as well. And you can also get connected to OLTP systems like Mongo, Postgres, etc., and make this more resource efficiency, avoid the complexity of the data structure. So when I say real-time analytics, I think I've said this multiple times, right? So what do we mean by real-time analytics in ClickHouse is using click pipes, right? So this is another feature which ClickHouse Cloud brings onto the table, where it acts as a man in the middle between your data sources and database. ClickHouse seamlessly uses massively parallel processing technology and put the data into the ClickHouse. And there are a lot of integration engines available. Good to read about that later time. There's a projections where you can store the data in the hidden table, where if your, let's say if your where conditions is not there in your primary index, and if you want to query that, it's a common problem across data industry, right? So it has to go to a different projections and fetch the data. So very efficiently can be done with ClickHouse. Materialized view, we have 2 types of materialized view. Incremental materialized view, which does pre-aggregation and start filling up the data, and also refreshable materialized view, where it gets refreshed for every 5 seconds, 10 seconds, 15 seconds, and configurable as well. Yep, the landscape has evolved from last 30 years, as I was talking about, from traditional data warehouse like Oracle, Vertica or Hadoop, Teradata, etc., to a traditional cloud data warehouse from last 10 years. If you see Redshift, BigQuery, Snowflake kind of a databases, and now where we are is real-time data warehouse. That is where ClickHouse is coming into picture. There is also a real-time data warehouse and offline data warehouse as well. So we stand at real-time data warehouse, but we also can do offline data warehouse like Databricks, Iceberg, and other platform does as well. So it's basically we are becoming more simplified, cost-effective, getting unlimited scale with low latency and high concurrency kind of needs in this data-intensive application world. Combining data lakes with analytical database, right? So if you have a data source, you can write either directly to a real-time data warehouse analytical system like ClickHouse, and also write to a slower inserts to maybe Delta Lake, Icebergs, and etc., right? So you have the system in two storages. You can connect both of them and use data lake for a historical purpose, and use real-time system for your most frequently used data, which requires a faster performance needs. There's also another pattern where just the raw data goes with the slow insert goes and sits in data lake, but this will powered by ClickHouse, gets connected to data lake as a query engine and starts pulling the data and giving the results to you, right? It can do both times, and again depends on use case to use case. So good to have the both writes and reads from real-time warehouse and also offline data warehouse as well. What makes ClickHouse unique, right? So first of all, it's a columnar base. It's not row based. We don't. It's not a very good fit for us if you want to do a single seek operation, single updates. traditional databases or traditional transactional databases is really good for that. But there's always need for transactional database. So we're not replacing transactional database. We are more of a columnar database where you go pick the subset of the columns, go deeper, pruning, and pick only the relevant granules where the rows are required and give it back to the client. Multiple layer of indexes. We have different types of indexes, right? So ideally, the data stored in ClickHouse is called as granules. These are the set of rows, the chunk of rows that grouped into a logical unit called as granules. And we have something called sparse primary index where it tracks these granules. Now, when you query this data, if the primary key index, sparse primary key index matches, it goes and fetches only that particular granule and skips all of the other granules. And this has been efficiently designed using vectorized query engine within ClickHouse, and that is one of the USP where you get lot and blazing fast performance, milliseconds on billions of records and trillions of records, maybe terabytes to petabytes of data. Efficient merging, right? So whenever there is a data warehouse distributed system, merging is very, very important. When you insert any data in ClickHouse, you create something called as parts, right? That is where the granules is stored. And when you create a lot of inserts, it creates a lot of parts. But efficient merging is very important. Behind the scenes, we track all of these parts, keep merging these smaller parts into bigger parts, and then push that down to object storage, right? So when you have a larger part, it's very easy to access the primary sparse key index to access that particular granules and give the details out of it. So again, there are different table engines. What happens during a merge? There's a table engine called merge tree, which combines the parts without deduplication. You insert all the rows and keep all the rows. Very good use case for append only kind of a use case. There are a lot of sub-family of this merge tree. Good candidate for reading. Replacing merge tree, if you have a requirement of, okay, I have a data coming in, I also have a duplicates, I want to remove that duplicates, then use replacing merge tree to eliminate those duplicates. Very ideal for absurd kind of a scenarios if you have that in your system. Aggregating merge tree again combines the parts by aggregating the rows. If you want to pre-aggregate the data as the data flowing into the system, it can be done using aggregating merge tree. So we have a lot of merge tree engine tables where it is built for different purposes, right? So very unique actually, and there are a lot of table engines which can directly connect to different databases and read the data as well and write the data back as well. So these couple of things makes really unique with ClickHouse. Some of the architectural efficiencies has been incorporated from last 1 year, which includes compute separation, which is also called as workload isolation. If you have a very high write throughput and also read heavy kind of a workloads, so we can separate your services to write the data into one service and read the data into from the other services, right? Basically, you are doing workload isolation with shared object store. So both of the services, the important point here is it shares the same data, right? So the data is being written into service 1, but you can read the data in service 2, which is cool. ClickPipes, as I said, is an integration engine where you can bring the data from various different data sources. These are some of the logos you can see where you can easily bring the data sources into the system. Very efficient, very blazing fast ingest. You can use MPP technology and put the data into the system. Lot of integrations, third-party integrations. When you take any database, it has to have a good ecosystem around it. And we have more than 250 plus integrations out there, right? So you name ETL tools or a BI tools or a streaming tools or a batching tools. We are all have a native connectors with ClickHouse so that you can consume that all ecosystems from whatever cloud provider you are using it. ClickHouse for real-time analytics, as I said, right? So use click pipes. That's where the real-time analytics comes into picture. Use the dictionaries, projections, and makes the system blazing fast. So one of the use case for real-time analytics, customer left, we ingest almost tens of millions of rows and also execute millions of read queries on ClickHouse daily. So we are talking about 25 terabytes a day of data. They are ingesting it and reading it into the system in a real time. And when I say real time, I'm talking about milliseconds here. The second use case, which is data warehouse or BI, as I said, so use again click pipes, very good candidate. Use table engines and put the data into the system, and UI layer you can use, as I said. So we have native connectors for all the BI tools out there in the market, and make your dashboards as a fast boards, right? So we call it as fast board and ClickHouse when some tools, when Power BI or Tableau get connected to ClickHouse. JustPay is again one of the use case with BI or data warehouse. It's one of the leading fintech company in India. The SDKs of JustPay, the software has been installed in more than 200 million devices, doing more than 5 million transactions a day, right? And doing aggregations on top of it, and they have to run 200 to 500 reports on a daily basis, and they want this in the real time to make the decisions real quick, and they are leveraging ClickHouse for this. Observability, very great use case. If you have a hotel collector, if you are anybody from observability, then use Kafka, Streamit, and use Grafana for monitoring. We have a great integration with Grafana and HyperDX, alerting UI and reports as well. Cloudflare uses us for observability, and if you see, Cloudflare uses 2 petabytes of data for ingesting 2 petabytes of data into the system, and they uses logs, metrics, and traces into the system, and identify if there is any malicious traffic in the system and take immediate actions, right? So these are some of the 4 important use cases I would put into different verticals and some of the examples of the customers. Yeah, and last, not but the least, ML and generative AI, right? So we have integrations with almost all LLMs. You take it OpenAI, Anthropic, and we have a ClickHouse MCP server now where you can get connected to a Claude kind of a tool and start connecting to ClickHouse service, and you don't have to really write a SQL query. It does it for you automatically. You don't have to create a report as well. It does it for you. So it's going really well. Anthropic and Claude with MCP server, I think it's definitely must try. I can show some demo as well if you come towards our booth. Tools and visualization and the models and AI services. You train your data, store all your data in the vector format, and start contextualizing that. Cognitive uses for a feature store for training ML models, really fast and cost efficient. A lot of their data science team uses it. Again, it uses 2 petabytes of workload in ClickHouse Cloud as well. So one of the use case. That's it. It's just the main idea or purpose for you all to understand what is ClickHouse is, where does it fit, and what are the architectural efficiency. Happy to answer any questions in our booth. You can join our community channels and etc. Thank you so much, guys. Thanks for having me.
Thank you, Rakesh. Appreciate it. We're going to go into the next person who's going to be coming up onto the stage. It's time for us to talk about intelligent systems that don't just react, they act. And to do that, AI agents need one thing above all, which is real-time contextual insights. At Startree, this gentleman is enabling the next frontier using Apache Pinot and Kafka, powering AI agents to make smart, autonomous decisions at scale. This person is the principal solutions architect at Startree. I'm just giving the audience a few moments to settle down, please, if you don't mind. Could we all just settle down and take our seats, if you don't mind? Thank you very much. Just keep the conversations for later. Yeah, thank you. Like I said before, this is the Principal Solutions Architect at Startree. Please welcome to the stage, Jayesh Asrani.
Hello, am I audible? Yeah, seems like. So I think the presentation is still being layered up. I know it's been a long day. Hopefully we can continue for another 30 minutes with me. And hopefully the solution will be RCB might just win the title, right? If you just have good hopes there. So just bear with me for 30 minutes. I'll try to keep it interesting. And I'm putting my job on the line by doing a live demo using an LLM, right? So it might or might not work, so you never know how it pans out. So just we'll wait for a couple of minutes for the presentation to line up and then kick off from there.
This almost feels like the meditation before, the event begins, or the moment of silence.
Yeah, that's fine.
So just give us a moment. We'll just push up the music. Yeah. Just give us a tad bit. We'll be back.
Hello, I hope I'm still audible. Seems like so. Cool. So my name is Jayesh. I'm a Principal Solutions Architect at Startree. What we are going to do today is talk primarily about three things, right? One, we'll go on a small journey, look at how real-time analytics came into being. That is one. Second would be, why do we care about real-time analytics, right? And the third would be, what does it all mean in the age of AI and the changing world, right? How does this interface with the changing world today? So we'll go back in time to probably 2011 or so, and we'll go back to LinkedIn, right? You must have seen some of these pages back at LinkedIn, right? These is who's viewed my profile, your LinkedIn profile, so on and so forth. So LinkedIn had a huge problem back in 2010, 2011 phase, right? The platform was being used on an ad hoc basis. People were not coming back to the platform because it did not have any engagement drivers. It was more of a platform where people could just submit the, let's say, resumes and look out for jobs. What they wanted to do was drive engagement on top of this particular platform. And the brilliant product engineers back at LinkedIn came up with the feature which is who's viewed my profile, right? I can instantaneously look at your profile and you get a notification as well as, let's say, a metric which says how many people are looking at your profile, right? And humans being humans, this was an instant driver for engagement, right? People were very keen to know how many people are looking at it, who's looking at my profile, where do they belong, so on and so forth, right? So we'll go back and see how does that work back at LinkedIn itself, right? So this is 2011 or 29 to 10 kind of a time frame, right? So what happens in the background is, whenever there is a metric that you're shown on LinkedIn, right, how many people have viewed at your profile, how many likes do you have on your post, this is what is actually happening in the backend, right? It is running an analytical query, give me sum of or count of a particular metric where the time frame was XYZ and looked at by user, so on and so forth, right? But it is not just about the query that is running, right? What is beautiful is, this is running at a scale that is unprecedented, right? Everybody today in this hall can open up LinkedIn page and still be able to look at those metrics. Everybody on this planet together can open up the same page and still be able to look at those particular metrics, right? So what we are talking about is nearly 930 million users. QPS, what we refer to as is queries per second, nearly 10,000 queries per second, and the latency of less than 100 milliseconds, right? Because it is a customer-facing application to the end consumers, there is no delay involved. It is not like a traditional BI where the spinner can keep widgeting out and the people will still be on your page. They will more likely abandon that page altogether, right? And this is what LinkedIn built. We'll go back and look at what the high-level architecture of that looks like, right? Basically, any event that happens on LinkedIn, right, in terms of me liking a post, me looking at your profile, or you just viewing a particular post itself, it generates an action which is then translated into a message onto a Kafka queue. This message is then ingested into a system that we are going to learn more about, which is Apache Pinot. But what happened with this entire pipeline is Apache Kafka reduced the cost per event, right? Now Kafka has become the backbone of our messaging systems. You can pick up any digital event or any real-life event, translate it into a digital twin, and push it via a streaming system like Kafka. What Pinot is trying to do is reduce the cost per query. The amount of cost that is needed to run queries which are internal facing to the amount of cost when it is required when tens of thousands of people are together on your platform and trying to execute that queries, right? That is how the birth of Pinot was back in 2013, 2014. It was formed back at LinkedIn and then open sourced around 2018 or 2019 timeframe. The question though still begets, right? Why do we care about fast OLAP? Why do we even care, or what is different between this OLAP system versus the OLAP system that we are looking out, right? I would try to think about it in two ways. One is the business phase, right? From a business perspective, analytics has always been logged internally. It has always been for internal users. It started with, back in the day in 1980s or 1990s, only for the CXOs. You get a T+1 report, CXO looks at what were the sales previous day, what were the invoices previous day, right? Moving from that, we went into a more batch mode where you are able to do every 15 minutes, every 1 hour, and all of your internal users are privy to that data, right? You have analysts figuring out what are the data patterns, you have operators figuring out where is the gold mine of data, where we can jump in next. However, the true power of data, how LinkedIn showed is to take that same data and push it back to your customers itself or to your partners itself, right? The data that I'm looking at it personally, my views, my likes, I am able to make informed decisions based off that, right? Which posts are circulating well, what content should I be writing, in what area, so on and so forth, right? So they took the power of same data and pushed it out in the back in the hands of their consumers, right? And that is a difference which brought in engagement for the platform all in all together. But again, this question still begets, what does it differ from a technical standpoint, right? Why can't the traditional systems or the current systems be able to handle that particular, let's say, scale that we are talking about? We'll be talking about 3 metrics back and forth. So the first one is data freshness, right? Data freshness refers to when the event has happened in real time to when the data is available in a system like Apache Pinot for querying. Again, if you are using a traditional data pipeline, an event which is there on the real-time system can take anywhere from hours to days to get into a system, then be available for querying, which is, of course, not the right way if you are doing customer-facing analytics. If I am making a payment right now, if I'm looking at a profile right now, that event should be available immediately for you to be able to understand the metric going up and down. That is what we refer to as data freshness. The next is query latency. Internal users are okay to refresh a Power BI dashboard, go for a coffee break, and come back again, right? It is okay if an internal Power BI dashboard takes 20 seconds, 30 seconds to refresh, or any Tableau dashboard takes that much time, right? But you won't allow same level of SLAs within customer-facing app. If your LinkedIn widget keeps spinning for 10 to 20 seconds, you will more likely than not abandon that page altogether and don't even use that particular feature itself, right? Hence, it has to be fast. It has to drop from seconds latency to milliseconds latency so that it is immediately visible as a new metric that you can browse or play around with. That is where the query latency comes into play. And the third important, let's say, the dimension that these real-time analytics platform differ on is the query concurrency, right? Or the user concurrency. Primarily, again, if it is for internal analytics, at max, you might have 100 operators, 100 analysts, or even 1,000 analysts. But okay, you can again take this on the other end of the spectrum. When you allow this data to be viewable by all of your partners or all of your consumers, the number increases manifold, right? It can be tens of thousands of users, or be scaling to millions of users. And the app has still to function in that particular latency with that particular freshness and still be able to provide insights which are available at the tip of your fingertips, right? So these are the three, let's say, I would say, core dimensions. Whenever we are talking about real-time analytics or analytics in general, you would want to look at these three particular dimensions and decide where does your use case fit in, what is the problem that you're trying to solve, and if it falls into which of these categories, right, and which of these buckets, I would say. So coming to the answer back at LinkedIn, right? So LinkedIn team started using a platform which was based on Lucene index for powering this who's viewed my profile, right? But the amount of hardware required or the cost of hardware required was much, much greater than the ROI they were able to generate from the business case of who's viewed my profile as a feature itself, right? Which just makes the whole offering useless pretty much from a company perspective. Hence, they went ahead and built a system of its own, which is known as Apache Pinot. We'll spend a few minutes now to discuss about what Apache Pinot is. And yes, Pinot is actually a wine, and the name comes because the founders actually love wine, and that is why the name is Apache Pinot. Just a quick tidbit there. So Apache Pinot, in a nutshell, is a real-time OLAP database. It is basically a columnar database that is able to ingest data in real time. And when I talk real time, I don't say that chalega type real time. I'm talking true real time in the order of seconds. So whenever that event hits a Kafka topic, within a second, you can ingest that into Kafka. That is the data freshness that we are talking about. And then the other two dimensions are concurrency and the query latency that Pinot is able to solve, right? So it is a distributed OLAP data store used for analytics, which are primarily requiring these combination of these three particular dimensions in a higher order magnitude. And it is, of course, highly fault tolerant because it is being running at scale at LinkedIn and few other places. It is a distributed OLAP data store and columnar in that nature. We look at a traditional, let's say, a data pipeline or a typical data stack, right? So to typically know where does, again, Apache Pinot fall into all the gamut of that, right? So basically what you can see is this is the Apache Pinot, or this is where the Apache Pinot fits in. You have your source systems where the data is coming in from the left-hand side. What has happened is there has been all this effort spent to do change data capture, to capture the events in real time. But once you get the data in real time, currently it is still being pushed onto the batch-based systems. The problem with these batch-based systems is the latency required for the data freshness is always order of minutes or hours, depending upon your data pipeline. And the throughput concurrency is very, very limited, right? If you have your data already coming in with high momentum and high velocity in Kafka within seconds, why not store it in a system which is capable of ingesting that data in real time, rather than doing micro batching or doing some sort of batching and taking the momentum out of that particular data set itself, right? And that is where Pinot fits in. You can ingest this data from any real-time system, Kafka, Kinesis, PubSub, so on and so forth, and achieve the combination of these three metrics, right? The latency, the throughput, and freshness. And you will see what is the difference between the data lake systems. So when you have order of seconds or the freshness requirement of hours to days, it is much better to go with a data lake system than a Apache Pinot as a system, so on and so forth. So this is where from a traditional, I would say, landscape of analytics or a modern data stack, if I may, this is where Apache Pinot fits into play. These are some of the use cases that Apache Pinot is currently serving in production, right? So we talked about LinkedIn. Any number that you see on LinkedIn today is actually powered by Pinot. Similarly, Stripe. Any transaction that happens on Stripe globally is ingested via Kafka onto Pinot. And what they use it for their merchant-facing dashboards, right? Basically, you have merchants which are using Stripe as a payment gateway. Stripe provides real-time analysis of how many transactions have happened in the last 1 minute, what is the ARR looking like, what is the MRR looking like in real time, right? All of those dashboards. They have more than 1 million merchants that are using Stripe as a payment gateway, right? All of them can log in simultaneously, still look at a real-time data and be available to that. Similarly, any number that you see on Uber Eats or Uber as an app. So for example, Uber Eats, which is of course not available in India right now, but any geo-fencing query, right? So if I'm searching for pizza within 5-kilometer radius, that search is also happening using Apache Pinot. So Apache Pinot has a geo-location or a geo-index primarily used for that. And again, the important part is to note the latency of it, right? Like all of these are customer-facing applications. So latency is 25 milliseconds and not seconds, and similarly, it is less than 100 milliseconds. That is the order of magnitude. It is actually just slightly longer than the blink of eye. The blink of eye is 20 milliseconds, if I understand. This is just 25 milliseconds. So if you just blink your eye, you will see the dashboard get refreshed. What about back home in India, right? So these are some of the customers who are already actually using Startree or Pinot at the moment, right? So any transaction that you do today on Razorpay actually goes via a transactional system onto Kafka, onto Pinot together. And they are powering it or they are using it for multiple use cases. One being their merchant-facing dashboards, looking at Stripe. And then there are certain microservices aggregation use case, right? Basically, they compute something known as a success rate to be able to figure out which is the payment method working best at that particular instant of time, which payment method has certain failure rates, so on and so forth, right? Similarly, any order that you do on Blinkit today goes via the same system. Each dark store then basically gets a real-time dashboard of how many drivers are active, how many drivers are inactive, which SKU has what sort of inventory, what is our average delivery time, and all of the metrics available to them in real time, right? So each and every order on Blinkit, as well as each and every delivery on Porter actually goes through the same ecosystem and goes back into Pinot for their customer-facing or their partner-facing dashboards primarily. Now, we'll take a slightly step pause, right, and take slightly a longer view, right? So back in 2022, I believe, 30th November 2022, our world changed slightly, right? ChatGPT was born, and post that, the things have changed slightly. Just like retirement of Virat Kohli brought an end of an era, this, I would say, brought a different era to begin with, right? Now, what we'll do is, again, we'll spend a couple of minutes to just unpack some of the keywords which are associated with this, and then we'll come back to the real-time analytics and how that piece tie-ups together, right? So the first is just want to quickly differentiate between an automation, an AI workflow, and an AI agent primarily. So all of those are used interchangeably very loosely, but all of those are different, right? Your automation is your classic automation. If this, then that, right? You have strict logic. You know the input that you're going to pass. You know the output that is going to come in. This is very, very useful. The best work done is where you don't need an AI. If you're able to handle your Boolean logic, go ahead and do automation. AI workflow is the second part of the ecosystem, right? Where the LLM call or an work by an AI agent is just one step of the process. So if you have 5-step workflows, only a couple of steps are part of the, let's say, the LLM calls that are happening. The rest of them is a Boolean logic. So the AI workflow is where you're mixing a combination of Boolean logic and a fuzzy logic. This is useful where you want the LLM to perform some of the actions, but not all of the actions, right? And that is where AI workflow comes into play. The third is the AI agent. Now, AI agent has complete autonomy. The AI agent works in a different way. You are basically giving a set of tools, giving it a set of permissions, and allowing it to perform the task for you in an undefined manner. You are not defining the quantum of steps the task should take to be able to achieve its output. You're just basically defining what is the output that you're needing. You're giving it the right tools and the access to environment. It goes on to a continuous loop, takes an action on an environment. If it needs to, takes the human feedback back into an LLM and keeps on this loop unless it has exhausted a certain set of attempts or it has been completely able to task, right? So just a quick, clear differentiation between automation, which is the Boolean logic, the AI workflow, and the AI agent piece, right? But how does it tie up with the RTA or the real-time analytics that we are talking about here primarily? Just before we do that, these are a couple of the building blocks which go into either one of those pieces, right? Either the AI workflow or the AI agent, right? So you have an input that is going into an LLM, and there is an output that is coming in. The LLM in turn has access to 3 or 4 things. One is retrieval, right? The standard retrieval augmented generation, right? You have basically textual data which you have converted into a vector, And for your LLM to know the context of your real-time data, you go ahead and retrieve the current set of vectors, provide that as a context to the LLM so that the responses are much more accurate. So retrieval sort of becomes the one armor in the LLM's chink. The second is memory, right? So, and the memory is divided into short-term memory and the long-term memory. Short-term memory is what is the context of the current conversation I'm having with the user. Basically, the current context window that the user has. Long-term memory is what is the memory of the user across different sessions, right? So if I'm having 10 different chats with OpenAI, what is the memory across that? And OpenAI has actually just released this long-term memory. It knows about your history of all of your chats, and you can actually ask it about what are my strengths, what are my weaknesses. You should try out. That is pretty fun to do. And then finally, to act on the real world or the digital environment, the LLM has access to tools, right? So if the LLM is poor in math, you give it an access to a calculator. LLM does not have access to the current information, you give it access to a web search. And similarly, the other forms of tools that it can do, right? So these are some armors available with the LLM to be able to go ahead and perform the task that it needs to primarily go ahead and perform. So how does it tie to Apache Pinot or the real-time analytics, right? So what we are seeing is the shift. We talked about the reports data, and then we talked about the data apps, right? The apps that are available directly within the applications itself, like LinkedIn, Stripe, Razorpay, so on and so forth, right? But from that, we are seeing a quite shift to conversational, let's say, response or conversational request, right? So rather than a single person, again, looking at the dashboard, it is more of conversing with the data. So that is the change from the data apps to conversational apps, right? People want to even talk to their data, get the insights, or even let the agent figure out the insights, right? You give me the raw data, ask the agent to figure out, okay, what are the top insights, which post will work better, so on and so forth, right? So this is a slight shift that we are seeing. The agent, the conversation has to be real-time, as well as be a conversation in that particular nature. So again, you can again imagine from a different perspective, right? If there are 1 billion or 1 billion approximately humans who can open up a LinkedIn page together, assume everybody has an agent together, right? That is where the future is going, right? Assume everybody has an agent. Assume there are multiple agents for an organization. When all of these agents combine together and want to query a system, the system should still be able to handle the SLA of the response as well as the concurrency of the queries that are coming in from the agents, right? Hence, the agent or the swarms of agent require the same SLAs that we were earlier talking about, right? The similar data freshness, because an agent is useful if it is working on a day-old data. It needs the same, let's say, SLA 100 milliseconds, 200 milliseconds. But more important than that, hundreds or billions of agents need to simultaneously query the same data and still be able to get response within that, right? And that is why something like Apache Pinot goes and makes a good use case for this. We have actually added vector index support in Apache Pinot as well. So Apache Pinot is a database which is known for its indexing capability. So vector index is just one of the new indexes that is added. So you can actually do cosine search similarity using hierarchical small words navigation algorithms. So you can actually take a text, convert it into a vector using any one of the algorithms, push it into Pinot and do a search. But what is more powerful about this is you just don't want to do a vector search, right? Vector search is just one part of it. You will typically want to query the system on the other dimensions as well, right? What is this text similar to? Where is the user coming from? Which pin code? And contextualize more, right? And that is where the power of the other indexes comes into play, right? You can create a combination of not just, let's say, Apache vector index, but the combination of other indexes as well, which allows faster querying of data. We are able to pinpoint to the data that is needed at a much faster pace, reducing the quantum of work done per query. And that is how we are going ahead and reducing the cost as well. Apart from that, from a conversational perspective that I talked about, so this is a model MCP protocol, right, released by Anthropic in November 2024. So we have built out a layer, which is the MCP layer, which can actually go ahead and converse or use Pinot as a tool. So there is a conversation which can happen via Cursor, Claude, or any of the clients, which can go to a MCP protocol for the translation from text to SQL, push that SQL onto Pinot, get the responses back. So there is a thin layer that we have built out. It is actually going to be available in open source pretty soon, but you can actually do a conversation right now. And if time permits, I'll do a quick demo of the same as well. And this is continuing on the same thread of the real-time RAG, right? Again, if you want to do retrieval augmented generation, it is important that you're able to get the data in real time, convert that into vectors, and do a vector similarity search. You don't want to, again, fall into a, let's say, a batch-based mechanism where you are taking bunch of textual data, converting it to vectors, and then doing that. You pretty much want to do it on a real-time basis because the real world is moving in that world, right? You are basically twinning that system onto a Kafka queue. So the ability to do real-time RAG is basically due to the upserts mutability which Pinot allows, right? You can actually take a order status or an order payload and mutate that continuously in Pinot at a record level rather than at a later level, which is again very, very different to how other, let's say, OLAP systems work, right? You create a merge on later. So this is the shift we are primarily seeing, right? We are going from random intuition based to the consumers, users, and then finally agents. But the common pillars of both of them are still those three dimensions. Everyone wants fast data, everyone wants real-time data, and the ability to have concurrent access to that particular data and still be able to perform within that SLAs, right? Believe me, there will be agents which each one of will have, which will be running these queries on a system like Apache Pinot, expecting responses in that particular fashion. I'll just spend a couple of minutes now talking about what is star tree. So Apache Pinot that we talked about is the open source technology. It is, of course, available for you to download, play around with, so on and so forth. Startree is the company which is behind the open source project and helping manage the open source project, and I'm the principal solutions architect at Startree. So what Startree does is a bunch of things on top of Apache Pinot. So from features like upserts, from features like cloud tiered storage, right? Basically, you can define, okay, this is my hot data, keep it on SSD servers. This is my, let's say, warm data, keep on EBS servers, and then rest of the data on the, let's say, tiering system, right? You can create a tiering system. So that is cloud tiered storage. And the scalable upserts in terms of using off-heap upserts to mutate that data at a very, very large scale. So you can actually go ahead and deploy the core Pinot on your platform, on of your cloud of your choosing, right? So there are multiple deployment options that we can go ahead and do it. We can actually do a traditional SaaS model. You can basically deploy it on our system. Or we can do a combination of bring your own cloud, right? Basically, you can tell me, okay, this is the infrastructure that I have. This is the AWS environment. This is the GCP environment. And we will deploy a complete managed offering on your system. The data plane remains within your infrastructure. The control plane remains on Startree. So it is complete managed offering. And apart from that, on the private preview, what we have is bring your own Kubernetes. So if you just have a EKS cluster or a GKE cluster, you can just give us access to that cluster and we'll deploy the complete application for you. And still being a managed offering, we will manage the complete deployment for you from that perspective. And of course, this is available across any of the clouds which you want to go ahead and deploy on. So this is again, a high-level architecture. So on the left-hand side, you have connectors. So Pinot has connectors for doing ingestion from real-time sources as well as some of the batch sources. The new feature that we are adding in terms of an AI capability is auto-vector embedding, right? So we are calling this as an enrichment. So if you can tell us, okay, this is the textual data that is coming in, and I want to create vector out of this textual data by calling an open API, open AI APIs, you can directly do that within the Pinot ecosystem as well. So you can just point to the table, point to the column, and we can do that vector generation for you and store that vector for you. So that is where the auto-vector embedding comes into play. And then on the storage front, right, you can choose, as I was mentioning, how do you want to tier your data? You want to use open table formats, or you want to use Pinot's formats for the best or fastest access? You can go ahead and do it. Where do you want to store that data itself? You want to store it on a data lake or on the servers? And then finally converse or get the data out either using the broker APIs, traditional BI tools, or go via the conversational Pinot agents, right, using the MCP protocol. So this is, again, a quick, I would say in a nutshell, what the architecture looks like. So I'll go on a demo, but before that, I just want to tell about what is the demo looking like. So basically, I have some data, which is the blue sky data or clickstream data that is coming in via a Python application, simple Python application. I'm pushing that real-time data onto a Kafka layer. Apache Pinot, as I mentioned, has a connector to the Kafka layer in itself. So Pinot is ingesting this data in real time. And then what we'll do is we'll actually use an MCP agent right now to converse with the data which is actually sitting in Apache Pinot and then be able to talk to it. Claude is visible, right? Awesome. So this is, just for context, this is the Apache Pinot UI, where you can, of course, run standard SQL queries, right? So if you were ingested some data into Pinot, you can actually go ahead and run certain sample queries on each one of these tables that we want to do, right? But what I have done is I've taken my Claude agent or the Claude UI, I've connected it as a tool to Pinot, the Pinot deployment that I was just talking to you about. So if you just go ahead and see you will see a Pinot MCP Claude, which is what the integration that we have built out. So what we'll do is we'll actually chat with the data which is sitting onto Pinot today, right? And please bear with me, as I mentioned, my job is on the line. This is an LLM, so it might hallucinate, and it might go off wire. Then I'll go off script as well. So I'm starting with a basic question, right? Can you help me analyze my data into Pinot? Maybe just start by listing the tables, right? So we know it has access to Pinot, and it can then go ahead and list all of the data. So you can see it is actually doing a tool call right now, and you can see there is a JSON response. And these are the similar tables that we saw into the other platform itself, right? So these are the tables that it was able to go ahead and sort of bring that together for me in a chat form, right? Now I can go ahead and actually ask to chat with it, right? Again, I'm being slightly vague here. Just want to show you a couple of capabilities. The abilities it has to, for example, to first of all connect. And I did not give it a very specific name. There are multiple tables of clickstream. So it will go ahead and first look at what is the clickstream table looking like. It is smart enough to then figure out, I just need to do a select star to figure out what is the structure of the table itself looking like, right? What are the columns? How can I do a time-based analysis? And then I've been slightly vague in terms of just telling it to do a time-based analysis. So it will go ahead and actually run a bunch of queries, right? This is the true example of AI agent. The output is not determined here. I am asking it a vague operation to be performed. So it is actually, you can see running a bunch of queries on it and getting the response out of it, right? It has actually already done a pretty good job of analysis using epoch timestamps and getting back so on and so forth. So it will actually go ahead and keep running a bunch of queries. So what it is actually doing in the backend is taking my inputs, deciding what needs to be analyzed, right? It is not that I have told it. I have not given it the response of what are the columns, what analysis it needs to do, and still be able to write queries which are Pinot compatible. Even if it fails to, with a certain syntax, it will actually auto-correct itself, go back to Pinot, and then get me the response back itself. Right? So you can see, based on the clickstream data, it has done some sort of analysis of date-wise, right? How many each events are actually available on each one of these particular dates. And it has actually done a bunch of other analysis as well, the screen navigation, user engagement, so on and so forth. Yeah, and this is just me showing off Claude here, nothing to do with Pinot, but what it can do is, it can go away with that whole ecosystem of, okay, traditional database and then having a BI layer on top of it. I'm able to generate everything in real time. It is just that my database is capable of running those parallel SQL queries, understanding, and if I have the latest data in that database, I don't need a BI layer on top of it. I loosely don't even need a base analyst to start with. I can ask it to do analysis of its own and then run a bunch of queries and then generate dashboards out of it, right? So what it is actually doing right now is generating a dashboard for me, which is reusable across. So this is coming back to the MCP protocol and the conversational AI part that I was talking to you about, right? Everybody today can go ahead and still be able to converse with this particular platform, just having the access to real-time data and then the ability to do, I would say, real-time analysis. So you can see it has actually gone ahead and created a very beautiful set of charts for me with all of the data and including different types of, let's say, analysis on top of that particular data. So just in conclusion, what I would like to go back is on the topic that so if you don't remember anything about the presentation, just remember 2 or 3 things. One is about Apache Pinot. Apache Pinot is a real-time OLAP database. The 3 dimensions always that are important is query latency, the data freshness, as well as the query concurrency. Pinot as a system is designed for doing real-time analytics when you want millisecond response time for hundreds or thousands of your users. You can use it to pair for a conversational AI or for your traditional dashboarding tool as well. And Startree is the company which helps manage the open source project and, of course, helps you manage the deployments as well as built up a bunch of other features on it. With this, that was my time. Thank you very much, and I hope this was useful for you folks.
That was fantastic. Can we hear a bigger round of applause for him, please? Like he said, putting his job on the line. In case you have questions, will you make yourself available outside these doors? All right, super. He will make himself available just in case you have to have some questions for him, but in interest of time, we are going to jump into the next introduction for the next speakers coming onto the stage. We have a duet that are about to take stage right now. And in today's digital fast world, data engineering is changing the lending industry from credit risk modeling to real-time loan approvals. In this session, Harish Ravuri, VP Technology, and Sandeep Didwania, VP Data from MPocket. Y'all are so loud in the front there, I can hear you all the way here. From MPocket, will explore how modern data pipelines, scalable architectures, and intelligent automations, how is it driving more accurate, faster, and inclusive lending decisions? This is a conversation we are about to have on the stage. They'll share how financial institutions are harnessing the power of data engineering to fuel innovation, ensure compliance, and deliver seamless experiences for borrowers. Please welcome to the stage Harish and Sandeep with a big round of applause. DEES 2025, can we give them a big round of applause? They're on stage right now. Thank you.
Hi everyone. Good evening. We are from MPocket, India's one of the largest instant loan application. Myself, I am Harish, and this is Sandeep. So we want to speak about the powering lending with the data engineering. So in our economy, lending is the backbone, which is empowering individuals and the businesses. But the competition is fierce. The market is crowded with so many new lending players coming in. And with the increased complexity, right, with compliance demands from the RBI, as most of you in the fin space will be knowing. So the requirements will keep on changing. Suddenly you will have a requirement to push the data within 7 days, within 1 day. And there is huge amounts of data that we have to process. And there is a very high customer expectation that the customers want the loan in few minutes. The moment they apply, they want the loan within few minutes. If they don't get, then they will go to another application and they will try there. And we have to process all this data within few seconds and then have to deliver the loan in within few minutes. So traditionally in the fintech space, right, there is a slow and manual process. You have to fill a lot of forms. And traditionally we used to rely on only the credit bureau scores. But we are creating a new segment, or we are the kind of a segment creators, right, where we have 10% of India's youth sitting on our platform. And we have disbursed more than 15,000 crore worth of loans. And we are also kind of, we can say that one of the, or the largest player in India who has given the maximum number of loans. And we are able to do all of this through the data engineering capabilities that we have. But let me speak about certain problems which are there with the historical approach. We are only relying on the credit bureaus, whereas most of the people that we are catering to, they don't have enough credit information to rely on. So we have to rely on alternate data sources, information on internet, and we have to process it with speed so that we can remove this incorrect, inconsistent risk assessment so the customers are not denied the loan. And the other problem with the traditional approaches is the high operational cost. And enough of the problems that I have highlighted. So now I would pass on to Sandeep to speak about the data engineering solutions that we have.
Thanks, Harish. So, on top of what Harish has just mentioned, that we have a lot of regulatory compliance, we have a lot of data silos, a lot of data to be processed, a lot of information to be shared. The customer's expectation is very fast and they need instant loans within a few minutes. So with all such things in place, the traditional method doesn't work out. We need to have an environment wherein we have all the data repositories together. There should be no data silos. You have the availability of alternate data sources. You need to have, on top of what Harish mentioned, M-Pocket's customer base, 50% of the customers are students. So as we talk about students, they would not have credit history. So with the unavailability of credit history, it becomes very important for us to have alternate data sources. Could be in any form you can think of. Maybe it's utility bills, maybe telco bills, maybe his expenses which he is doing in the online platforms, or other marketplaces from where you can leverage the data. As well, from the demographic information of the customer, from where he belongs to, which region he is belonging to, and for example, if you have floods in some region, whether he would be able to pay back the money. So there are a lot of alternate data sources available in the market. With the help of those things, we need to gel or stitch all these things together to make a rich and robust profile of a customer, which essentially helps us to reduce the underwriting cost, which helps us to reduce our NPAs, which helps us to give more accurate predictions for our data science models. All these things together helps us to provide tailor-made products as well. Basis the credit history or basis the capability of the customer to pay back the money, we can provide tailor-made lending rates, tailor-made offers to the customers. Having such things in place, if we have a complete ecosystem together, stitched up together, a robust foundational data platform is very much required for the lending industry to work good, or a company to work good. So data engineering in the lending context is not like a data science team or a data analyst who would be wrangling around with the data or building data science models. We cannot exist in silo. Whatever the data we generate, that is definitely used by them. And they actually are the powerhouses. It's like data engineering is a pipeline. We build fuel pipelines, and they are the actual drivers of the car. Data engineering helps to, you can say, make the data high quality, reliable data accessible to the downstream customers, be it for the reporting purposes, be it for analysts or data scientists as well. Now, as part of the data engineering components, as you all know that the first step is towards ingestion of the data. The ingestion of the data in the lending space could be not just the CIBIL or bureau score, but it could be unstructured data, structured data, maybe your Form 16s, maybe your ITR returns, bank statements, OCR informations. There are n number of data sources which are powering the lending. So all these things together, stitched together, and in a very limited amount of time, we need to have all these things scanned, processed, inferences derived, and basis that your data science models are powered, on top of which certain decisions are made, and then the lending process starts. Then the disbursement happens. So data ingestion plays a very vital role. You can have the data from various API sources like Udyam. You can have from maybe UN as well, or PAN or Aadhaar. All these things are linked together. On the data storage side, the type of data which you are going to use or type of data which you are going to process, it needs to be stored optimally. It could be a SQL database, or it could be a warehouse which is powered on SQL, or if it's unstructured, you can go for some other type of repositories. If it's warm and cold data, then we have data lakes and stuff wherein we can power the data. So all these things essentially ends up into being a cost. Now, since we have talked about unstructured data, so having said we have so many number of diverse type of data types, data which is going to come in, we need to have association or maybe linkages between all such things, so that you can derive certain inferences out of that. To do this, we'll have we need to build a lot of data pipelines, which you can call as an ETL or ELT layers, which will help us to stitch all these data together. Governance and security in the lending space is the most important thing, I would say, because with the advent of DPDPA, Data Privacy Data Protection Act, the regulators have become so stringent that any information in any manner cannot go outside your system. It cannot be shared with anyone as well. You need to have all the data in your system hashed, and it should not be readable by others as well, in fact the teams as well. So there are a lot of regulatory constraints on top of it, which makes it even harder. Again, like for orchestration and monitoring, we have tools like Uzi and other, or if we have some COT solutions like Databricks or Snowflake, we have schedulers inbuilt. On the serving side, as I mentioned, like we can have Tableau, Cognos, or Power BI, any other tool which can be integrated for whatever the data is generated. It could be served as real-time or non-real-time reporting as well. So I'll walk through a couple of use cases, and apart from the slides as well, 1 or 2 use cases. So one of which is the enhanced risk assessment and underwriting. So again, like as I mentioned, the diverse data sources helps us to profile the customers even better. Having said the profile is richer, we are able to take proper decisions on the data points and give more accurate data to the machine learning and risk models, which leverages us with the information whether this customer
Check 1, 2. Check 1, 2. Am I clear? Am I heard? Yes? All right. Can we put our hands together for all the people that ran behind like crazy people to make this happen? Yeah. These things unfortunately happen from time to time. Just to give you a quick update, one of the power units went out and these things pretty much never happen, but it's happened now. So that's the way life is. Can we put our hands together and welcome these gentlemen back on stage? Harish and Sandeep, give them a big round of applause. Gentlemen, if you could make your way back on stage. Big round of applause, people of the audience. Thank you very much.
I hope I'm audible now. So I was talking about a use case with respect to dialing system. So wherein I talked about, let's say you have customers based out pan-India and you have multiple regional languages. Not all the customers would be comfortable in English or Hindi, and you would need to give them a personalized touch. Basis the language which the customer understands. Let's say you have taken some information prior hand for the customer, and the data engineering team tries to build a couple of pipelines with respect to the customers coming into the platform, going across the journey and drops off at a particular stage. Now, you would like to definitely reach out to them. They could be a potential customer, and that is where you can extract multiple patterns of data from the data lake or from the data platform, and it can be sent to the dialing system for customized campaigns, customized communications as well. Now, let's say a customer has registered on mPocket or any lending platform, but he has not taken a loan. So let's say you would like to make a welcome campaign, a welcome call. Or let's say if a customer has been overdue for quite some time, let's say his due date has passed and you would like to connect him basis the region, basis the type of customer, basis his preference, basis his earlier communication history as well. You try to get a lot of information prior hand, pass it on to the call center team. They try to build a customized communication and then they reach out to the customer that, hey boss, X or Y, Z amount is pending, would you like to clear it up? In the similar lines like dialer, you could have notification systems as well. Now, like as Harish mentioned, mPocket is on an annual basis, we lend roughly around 15,000 crore rupees. And it's in terms of number of loans, mPocket is the biggest lender in India. More than even SBI, the number of loans, not on the size of the ticket of loan, but on the number of loans. So in that context, the volume of data which we have is enormous. And let's say if we need to make email communications or SMS or in-app notification, or in the SMS or email as well, you want to have customized campaigns. In that case, traditional OLTP based systems or your existing applications would not work out. You need to have a robust data platform which can empower such use cases, wherein you need to send millions of SMS and millions of emails on a daily basis. Now, I'll go with the slides. In this use case, we are talking about faster loan origination and automation. So like in the initial section of the presentation, I mentioned about alternate data sources. Now, let's say a customer comes to the platform, he does some basic registration information and tries to go ahead in the journey. You just have less than 30 seconds. And in that 30 seconds, you would like, whatever the documents he's uploading, you would like to verify them, validate them, then and there. Otherwise, if there is a delay, it is a potential loss and the customer will move out to other platforms if there is a delay. Secondly, if wrong informations are captured from the platform, like your decisions are incorrect, then in that case, it would be a loss to the company in terms of customer coming in the platform, taking the money and not coming back again. So in that case, a real-time data checks against the underwriting system, wherein you have built the profile of the customer with respect to alternate data sources, transactional data, or his behavioral data as well, like how he browses the app, what time he is looking at the app in the night, weekend, whether it's a festive season. There could be n number of parameters you can think of. So basis all these things, a behavioral profile is created for the customer. And on that, a real-time decisioning is made. At the end, if you have a robust data pipeline, this will help you to significantly reduce the cost and the overall processing time as well. And all of these things would result into customer satisfaction. The next use case is on fraud detection and prevention as well. So let's say customers have already taken the loan on M-Pocket and he is coming again for loans. Basis his past historic behavior, basis his current dynamics from the market data which is available, or from bureau or from CIBIL or other alternate data sources, we try to build his profile. With those things, we are in better position to say that, okay, whether we should lend him further money or not, or what is the potential, his debt to income ratio, for example. How much should we lend him? What should be his upper limit? All these things can be defined. Now, let's say in the same journey, a person has paid the money and he again tries to take a loan, and due to certain system glitches, your underwriting system behaves abruptly, and in the meantime he again applies for another loan. There are situations wherein it could lead to potential revenue losses. So such systems, such sort of behavior are also factored inside the real-time pipelines, wherein if any of such patterns happen, basis the previous behavior of multiple customers, the models have been trained to take care of such things. At the end, all of these things will help us to reduce the losses. In the previous slide itself, I have one more example, like during the registration process as well, like when you register with ICICI, SDFC or any bank or any NBFCs, they would ask you to do KYC. Now there are very common names in India, Santosh Kumar, Ram Kumar, Shyam Kumar. There could be thousands of such people. How do you end up saving, let's say if I am Santosh Kumar and one more person is Santosh Kumar, I have used his PAN card or Aadhaar card and I have done these things. There are lots and lots of potential use cases wherein how do the intent of the customer, of the malicious or such activities or the fraud activities which are happening, how do you evade them? How do you stop them from doing such things? All these things can be factored with a proper and a robust data foundational layer and a proper data pipelines if you have in place. Now, these were a couple of the use cases with respect to fraud detection and all the others. Now, let's say if you have a big customer experience team and they frequently interact with customer, you need to have a customer 360 degree, wherein the complete details or whereabouts of the customer can be viewed. Now, with this event-driven architecture and such things coming in place, we end up making small databases across the systems, and then you have, again it results into data silos, wherein we need to bring them back into one single repository, and on top of that, further you need to enhance or enrich the data, and then you need to feed it to a platform which could serve as a customer 360 degree platform. From there, basis his behavioral journey or basis his lending journey with the institution, you can have a lot of personalized product offers and communications. You can have proactive customer support. Let's say basis the customer's previous behavior on the platform, he has taken the loan and he went to overdue. I mean, he has not paid the money on time. Later on he pays, and second time again he takes a loan. Now this time you are preemptively calling, okay boss, your due date is coming, when are you paying back the money? So proactive customer support. All these type of data sets can be extracted from data engineering pipelines and could be well-versed, well served with the customer experience team for them to follow up with them. Or in fact, it could be fed to a dialer system, and from the dialing system, calls can be made. And the moment call lands on the customer, your customer 360 view of that particular customer is visible on the agent screen, who can further communicate. With all such things in place, definitely it would result into better portfolio health. Your NPAs are going to come down, your risks is coming down, your frauds are getting reduced. So inherently, your risk exposure comes down, and definitely it results into your better portfolio health. I'm sure many of you would be from fintech, so you would have faced regulatory bodies and reporting to bureaus wherein on a defined date and time, a huge amount of data needs to be shared with them. And these asks are very ad hoc. It could come on a Friday evening and it needs to be given in just a couple of hours. In such situations, if you have a customer 360 degree, if you have a proper data pipelines, data platform in place, and the capability to churn this volume of data quickly, then definitely all such use cases or all such problems can be easily addressed. Now that we have, in the lending space specifically, we talked about a couple of use cases, and now there are a lot of challenges and considerations which we need to take care. First and foremost is data quality. I mean, data quality and security, these two are the fundamental pillars, without which it is very difficult. Your data quality, right from the first place wherein it arrives to our system, till the number of versions it has changed, and what all versions at what all times it has been reported to regulatory entities. All these things need to be captured and preserved for multiple years. Having said, if you have consistency in data and you're able to answer the questions of anyone or any person whosoever, like regulatory entity or even a customer asks, if you have the platform available, you have a data engineering platform available proper, wherein you have robust foundational layers, these things can be very well achieved. On top of that, I would like to add one more point, that all of you might be making payments online and you would be seeing settlements of 48 hours or 72 hours multiple times, wherein the money has got deducted from your bank account but has not received on the customer side. And after a certain period of time, that transaction gets declined. Now, in such situations, when you portray this particular problem statement into a lending space, you have generated a loan document for the customer. You have said him that, okay, hey boss, your money is going to be credited soon, and fortunately it ends up being declined. And due to any other system glitches, if it happens that your data gets corrupted or your data gets spoiled, at the end it's very difficult to bring it back. In such cases, if you have a proper data quality or data assessment process in the pipeline, such things can be very well managed. I had talked about data privacy and compliance, which is with respect to Data Privacy Data Protection Act. Integration with the legacy systems, always you'll have multiple systems, old systems wherein you would be needing to bring those data, or you need to send some information or maybe call some APIs and transfer some data. Scalability and performance requirement, having said foundational platforms are available and due diligence at the very stage has been put in, it becomes very easy. And the last two, like the cost of technology and skill talent, that's always there with any emerging systems and technologies. Now, in the future trends, I can talk about like increased demand for the real-time processing, as and when more and more need for diverse sort of problem statements come in, or maybe with the evolving nature of business and the competitive stance in the market, it becomes, it is imperative that we need to have such things in place wherein we have the capability for real-time processing. Embedded AI ML within data pipelines, adoption of data mesh, focus on ethical AI wherein, and bias mitigation and fairness wherein every customer is given the same treatment. Continued migration to cloud-native platforms. So, I mean, with the evolving nature of business and the pace at which we need to move out, it's very much required to have things on cloud, so it becomes easy a bit. Key takeaways and the concluding slide would be like data engineering, again, like is the foundational system. If you need to have a robust platform in place and you need to do all such things in place, then you need to have a system which is able to manage all your data requirements and data needs. And it should be capable to withstand the workloads, withstand the needs and the rapid changing demand which we have in the market that is being addressed. We can't keep on evolving, or we can't keep on changing the data platforms. It needs to be faster, smarter and more efficient in the lending operations. Again, when we build such platforms, ingestion, storage, processing, governance, serving, all these things are very much essential stages of the data ingestion or the data engineering ecosystem. The more tangible benefits would be reduced risk, increased speed, better customer experience, and at the end, reduce the cost. Thank you. Any questions? Yeah.
So, unfortunately, due to the time thing, we can do one question.
Okay.
So, should we go for the lady up front? Yes. Can we move quickly? The mic there. Thank you.
This has been very informative.
Madam, could you hold the mic up, please? Thank you.
Is it okay now? Yeah. It is very informative, but it also seems something impossible that has been implemented, right? Where my question goes is two parts. One is NPAs is something that affects all fintech, right?
Absolute.
Right? All banks, so many other financial institutions go through that. So how much, I mean, I don't know if it's business related, but how much percentage of your loans are NPAs, and how, what are the steps that you've taken to overcome them?
I'll take the second question. First question I will not be able to answer. But yeah, in order to take care of how do we reduce the NPAs, there are various aspects to this, not just one. The more cleaner data you have, the more better your customer outreach program is there, the more better your notification systems are there wherein you timely reach the customer, the more proactively you do a risk assessment of the customer while disbursing the money, and the behavioral insights of the customer over time. All these things, apart from that, there could be multiple aspects as well. These things need to be taken care while we disburse the money. And for taking back the money as well, these things does play a very crucial role. Like as I said, debt to income ratio is one very classic example which all the banks or NBFCs does. You need to know how much debt a customer is able to pay back, or how much you should lend basis his current liabilities. So with all such, this is just one example. There could be n number of others which needs to be considered before you disburse. So you need to have a very strong data science models in place, engines in place, and an underwriting system to gauge whether he would be able to pay back the money. And these things would definitely at the end lead to reduction of NPAs.
Thank you for that. Can we hear a big round of applause for the two gentlemen on stage? And to the two of you, thank you for being so kindly patient during all of the little madness happening here. Once again, a massive round of applause to the two of them, please. Thank you, gentlemen. Maybe after this next session, if you have the time and can take questions out in the lobby. Yes? Perfect. Thank you all very much. Alrighty, this is just day one. Everyone is good. How many of y'all are sleepy? Be honest, hands up in the air. Okay, sleepy people. Lots of sleepy people. That's like 50% of the audience. Okay, very quickly, everyone just look left and right, say hello to the person next to you. Very quickly. Look left and right, say hello to the person next to you. Like, hello. Look forward and back, just say hello to them. Say, are you ready to laugh a little? Ask them. Go ahead. Yeah? Okay. Up next, we have a